Test. Test. Okay. Can you get the microphone signal? Check, check, check. 1, 2. Check. Testing.
Let's go, GM, Algo fam, welcome back to day 2 here at Decipher. All right, my voice is a little bit not as good as it was yesterday. Can understand meeting so many great people here. The connections have been awesome. I'm glad you're all here. I'm glad you're joining us on the live stream. I know you just got done listening to Sean Ford, our CEO, speaking of what an inspirational talk he had. I mean, LFG guys, come on now. This is our time. We are here to build, and that is what today in the greenhouse is all about. So yesterday, we heard from a lot of my colleagues. Paul Riegel, he was in here talking about his 3 core pillars, right? The core protocol, interoperability, and programmability. So yesterday, what we saw was really all about the what and the why would you want to build on top of Algorand. And today, it's all about you, the devs, and the how. So what we're going to go through today, I'll kick it off, right? All right, hey, LFG devs, we're gonna figure out how easy it is to set up your developer environment. I'll walk through that this morning. After that, we are going to have a bunch of my colleagues here within the engineering team as well as the DevRel team. They're going to go through and introduce the various languages that we have available in the Algorand ecosystem for building smart contracts. First, we're going to go through PyTeal, then we're going to take a look at the Beaker framework, and then we're also going to learn about Reach as well. So whether or not you are a Python developer or a JavaScript developer, we've got languages to meet you where you are. We've got all the SDKs and stuff. We're going to figure out how to get it set up. We're going to figure out how easy it is to actually write and to begin building. Over the lunch period, we've got the scale competition. So we're going to hear from builders who are in the early stages and trying to scale their projects. After lunch, we're going to come back and we are actually going to build some smart contracts. So we're going to build the same dapp. We're going to build an auction dapp, and we're going to do that using the Beaker framework in Python, and we're also going to use the Reach lang. And so we invite you to stick around all day. We got great content all day long. Let's see what the next slide is. Hey, that's me right there. Our first speaker today is me. All right. All right, here we go. So LFG devs, let's go. All right. I'm going to teach you how to launch your Algorand developer environment today. Hello, I am Ryan Fox. I am a developer advocate here at Algorand. I'm joined by many of my colleagues here in this room, as well as online in that Discord server. So we thank everybody on this team for coming together and being available for the devs out there. That's me a few years ago, so that's how it started. All right, so that was me when I was working for a mortgage banker. I was doing that by day, and at night I was mining Bitcoin, and that was back in 2013. And I guess how it's going? Well, as you can see, yes, I'm fully Web3. There's my Decipher Gator from last year. All right, welcome everybody. I hope that we can connect. I'd like you to connect with me using that Bird app. That's probably the best thing. You can reach me. I am Ryan R. Fox, as well as I want to make sure that you connect with the @AlgoDevs Twitter handle as well. We're here. We send out all sorts of updates whenever we are making new releases, and we got all sorts of good things. So make sure you're doing that. Let's connect. And why the heck are we here? Well, we're here to build. And if you're new to Web3, we spelled things a little bit funny. So yeah, that's build. But we're here to build. And this talk is really all for you, the devs. And the first thing that we're going to do is talk to you about how to set up your developer environment to begin your journey to become an algo dev. So I want you to build smart contracts, dapps, DeFi protocols. I want you to build provably fair games. I want you to build smart NFTs. I want you to move beyond just the basic JPEG art towards mutable attributes that are enforceable, that have enforceable royalties for creators. And I want to increase the utility for those end users and the collectors. I want you to use our verifiable random functions within your Algorand smart contracts. I want you to build oracles. I want you to bring oracles so that you can then use that in other smart contracts. I want you to build bridges, and I want you to build trust minimized bridges using our decentralized layer 1 protocol for building for using our state proofs technology that you heard a little bit yesterday, Chris Piker talking about. And I also want you to build bridges amongst yourself. That's why we're here at Decipher, and that's what the AlgoFam is. It's about building bridges to other developers as well within this community. And that is what the AlgoFam is, and that's what it means to be a developer here in the AlgoFam, is community. So thank you for being here, and I want you to become a Web3 developer, because in short, what I want you to build is the future of Web3, and you can do that here on Algorand. I want you to build it on Algorand. I want to welcome everybody here to the AlgoFam, and I want to convert all of you into becoming Algo devs. Let me show you what it takes to do it. This is where we start, right here. Every successful algo dev has started right here. File, new, WTF. All right? Trust me. We can get beyond this, and we can figure out how to get to done. We're going to start building the Web3 future from right here. My recommendation is for you to start using VS Code. I think this is a great tool. It's free, open source software. You can install it on any of these various platforms, so wherever you're at, on any platform, click download it, install, and then we want you to search within the extensions portion, and you search for Algorand, and you're going to see a couple of different extensions that are there. One is for Algorand, one is for Reach. Install them both. All right, that's easy. It adds syntax highlighting for PyTeal, and the Reach lang. And I think that this is a really great IDE for most devs who are getting started, and especially these extensions make it very helpful for the algo devs. All right, so let's get familiar with what that Algorand, or the components of the Algorand developer environment. Basically, we'll break it down into 3 different components here. We've got infrastructure, SDKs, and languages and frameworks. All right, so the first component we're going to talk about is the infrastructure. That is a tool that we call Sandbox. And what this is it's all your infrastructure bits, right? So this is about building the local development environment for you, all within this containerized environment. And then we have all sorts of SDKs available for you here. So wherever you're at, we've got SDKs to meet you where you are. Come on and pick one of those, and then come and pick a language, and perhaps a framework as well to go with that. So we'll take a look at all of these components here and get them installed on your local environment. If you are here in this room and you are following along, get ready. We've got lots of QR codes you've already seen. You can scan them, you can get them going. If you've got any problems installing anything, you just find the guys in the back of the room there. The DevRel team are back there, and they will help you, or just put your hand in the air and they'll come to you, all right? We're going to get this thing set up now because it's going to be what you're going to use for the rest of the day today as we build out the rest of these solutions today. All right. So, I know, first thing in the morning, what should we do? We should do a little developer calisthenics. So, hands in the air. All right, good. All right, hands down. So, who am I? I want to know, are you a PC? Do you identify as a PC? All right, hands down. Do you identify as a Mac? All right, hands down. And then, do you identify as a Linux? All right, that's pretty well split between everybody, I will have you know. So, good news, like we've got you covered wherever you are. All right, so let's just go through and talk about the basics. What are the prerequisites to get your developer environment set up to work with Algorand? So if you identify as a Mac, you've got just 2 prerequisites that you got to consider here. You're going to need Docker Desktop at version 4.8 or higher, and you're also going to need Python at 3.10 or higher. Now, if you identify as a Windows or a PC, you've got one additional prerequisite, and that is WSL2. So, yes, and my recommendation would be if you are on the Windows, use the latest version. It does not work on WSL1, so you would have to make an upgrade if you're there. Love to have you, love to help you with that. All right, so let's start right there. WSL2, we will follow some instructions that Microsoft provide. This is a non-trivial task, I will tell you, and we get some people who get hung up right here with WSL2. Again, if you have any struggles with this part, reach out in our Discord server. That's discord.gg/Algorand. We're there to help you get your dev environment set up for you. It starts right here on the Windows platform, WSL2. It's actually pretty easy if you got, especially if you got a brand new workstation. You just go WSL-install. All right? Doesn't take too long, actually. What's going to happen is it's going to download the bits to install a virtual environment. By default, it will install Ubuntu. That's my recommendation. Just take all the defaults there. A few minutes later, you're going to have this nice message down at the very bottom. The requested operation was successful. You now have a virtual machine, Ubuntu, loaded on your Windows platform. You're really not going to see it when you're developing, but it's just there. It's a hook so that we have, so that we can interface with Docker. We'll talk about that in a moment. So, after you get WSL installed, you need to reboot Windows, and then you are going to actually start this Ubuntu the first time because it needs you to configure it by putting in your username and password the very first time. It doesn't have to match what your Windows password is. You can make it whatever you want, but it will prompt you to do that. When you are done with that, this is what you'll have. You'll have this nice command line that just says username at hostname. Cool, okay, great. So you're done. So WSL2 is now installed on your machine. You can close that window. You're not going to use it anymore. The next thing you need to do is have Git installed. And if you're, again, on a brand new PC, you will need to install this because it's not installed by default. So return back to your IDE. Here we're looking at Visual Studio again. And just hit New Terminal. The command prompt here, this is PowerShell. The terminal that it opens by default is PowerShell. So you can issue a command that is no, it's not wget. What is it? Back up. It is winget install, and then you are installing the Git. And this will run quickly. As you see here is the output, right? So now what you will need to do is within your PowerShell terminal, you will type another command, you are going to come over here and hit the little plus button so that you can change your default terminal from PowerShell to Git Bash. All right, so you click on Git Bash and you will get a new window that looks just like this, or a new prompt that looks like this. So now we've got the little $sign here. So now we are actually using a different bash shell, so that now we can do commands for this in bash. All right, this is okay. You're ready to go. Right, next thing. So we're done with Git, and we're done with Ubuntu and WSL. Now, everybody is going to do this part here, regardless of if you are a PC, a Mac, or on Linux, which is to install Docker Desktop, because we are trying to get to Docker Compose, which is one of the prerequisites for the sandbox tool that we're going to use here. So head over to docker.com, you click on the icon of your choosing that matches your environment, and it downloads. Again, this is not, that is not too difficult. Next thing you're going to do is head over to python.org, and you are going to download, recommended, the latest version of Python at the time. It is currently 3.11. That is greater than the minimum requirement of 3.10. Go ahead and install that. If you already have a Python environment installed, you will need to make it at least 3.10 in order to work with our tooling. Once you have that installed, you can now verify your prerequisites. And you can actually you can actually start here. If you already have, if you're already a dev and you've got a developer environment set up, you can check if you're ready to go by just typing these two commands, which would be Python -- version, as well as Docker compose version, and verify that these are above the minimum requirements. There we are. As we can see here, I've got 3.10 installed on this one, and I've got Docker compose 2.12, so I'm good to go. All right, so let's now install the infrastructure tools that we want. So we're going to walk through these three different components here, infrastructure pieces. Tool is called Sandbox. All right, and where do we go to get it? Well, it's pretty easy. You're going to return back to your IDE. Make sure that you are opening up Git Bash if you are on Windows, or if you're on Mac or Linux. By default, you'll just get Bash here. So all you have to do is issue the command git clone, and then the repository on GitHub is Algorand Sandbox. All right, so quickly it will download that repository, and you can simply change directory into Sandbox, and then let's is a fast way to create and configure an Algorand developer environment that includes AlgoD node and the indexer as well. That this is recommended only for development environments, and it is not meant to be a tool to use in production. But this is going to get us going quickly and bootstrap our development. So what is Sandbox? What are the components of Sandbox? There are these four components here. So Sandbox is actually a Docker container, right? So that's why we had to install these virtual the virtual environment to make sure that we could get this container there. So it explodes out and it provides these four components. It provides networks. And what I mean by networks is you can deploy, and we recommend that you deploy it as a local private network that only exists on this network. It can be configured as well to connect to the public testnet, and could actually connect to the public mainnet as well. So as you advance your smart contract code and you deploy it and test it locally, you can then change the configuration of Sandbox to connect to the test network, deploy and test your code there, and then finally reconfigure Sandbox to connect to the mainnet and deploy it there finally. So network in parentheses, networks. All right. It also has a built-in wallet or a key manager. This is called KMD, the key management daemon. So that'll manage all of your accounts, and by default, if you're running the local environment, it'll set up a handful of accounts for you, and they'll all be pre-funded. If you're going to connect to any of the public networks, you will, on the testnet side of things, you can use a dispenser in order to fund those accounts, or if you're on mainnet, you will have to import accounts in there and have those funded with real money. All right. There is also a query tool. This is the indexer. If you are building, again, the local private network, the indexer is installed by default. If you are installing it connected to one of the public networks, it is not installed because it can't sync this, but it can start from default, which is, it can start from the genesis, which is what we will do by default when we are creating our private network. So query tool, very helpful. And then lastly are APIs for each of those three things in order for your code in order to query and get data and push data to the network and to those other infrastructure pieces there. All right, so the APIs are provided on these ports by default. You can change these if you want, but if you're using the other tooling that we're going to take a look at, when you are configuring your clients, it will by default look for the AlgoD node, the networks, on port 4001, the wallet, or KMD, that'll be on 4002, and then the indexer, or that query tool, will be on port 8980 of localhost. That's Sandbox. That's all the infrastructure kit right there. All right, so we saw how to install it. How do we run it? Pretty easy. We just issue the command sandbox up. The recommendation is to give it the keyword dev, which will load the developer configuration. It will start as a local private network. The indexer will be there, and it will also put it in dev mode, which means that every time that you issue a transaction, it will then commit that transaction and to the blockchain, and so you can go very, very quickly. You don't even have to wait the very fast that we have anyway. 3.7 seconds for your transactions. They will just instantly be committed. So we recommend, again, sandbox up dev. All right, so what do? Head back to your IDE. You've got your terminal open. Again, if you're on Windows, make sure it's git bash and not PowerShell, and then you can issue your command sandbox up dev here. And I like to add the little flag there, -v, which is verbose. And what you'll get is a bunch of output here. What it's doing is it's connecting and downloading the sandbox environment, which in and of itself goes and downloads the latest binaries for that are released by Algorand, and takes them, builds them if necessary, and then ultimately, a few minutes later, you're going to have this output here, which shows that the sandbox successfully started. Now, at the beginning, or kind of at the top of this section here, we have 3 different accounts. So starting in dev mode, you automatically get 3 accounts by default. These are funded, so algos are already in these 3 accounts. And these are stored within the wallet software, the KMD. And the next 2 lines down here are a couple of command line, they're commands at the command line that you could copy and paste and actually run here at the command line to create your very first transaction, to transfer algos between account number 1 and account number 2. So you could see that. And then the last line down there is using curl, which is asking for data from the indexer so that you could actually see that transaction that you have done. So this is demonstrating that all of the networking components and the infrastructure is there available. It's running behind the scenes. So next thing we need to do is to connect our SDK and our code to it. A couple of commands that you will likely use will be, well, you can always hit sandbox help, and that'll tell you all of the different components that it has available to you. You will often do sandbox status to, well, get the status. What block is it at, and make sure that the node and the infrastructure is running as expected. You can stop it if you want so that it's not running anymore. And then you could just do sandbox up again, and it would restart the network from where the last block was. Oftentimes as a dev, you're going to use the reset. Now what this does is it wipes away the network, and then it restarts it from scratch, from the genesis. So when you have a testing framework, oftentimes what you are doing is deploying and testing a script, and then you may always want it to be the same application ID, so then you would redeploy it, make some changes, redeploy it, so you would want to reset your sandbox there. It's very fast because it doesn't have to download anything anymore. It just has to wipe the config and start it again. So those are the commands. There are a few other ones, and you can use sandbox help to learn more about those. The documentation for that is on GitHub, and there was a link already earlier. All right, so we've covered that first part there of our developer components. Let's move on to the SDKs. And again, we have these 4 different SDKs available: Python, JavaScript, Java, and Go, that are provided by the Algorand engineering team. These are frequently updated, and these SDKs match the features and functionality that are available on mainnet. So if we think about what has just been talked about yesterday, and we're talking about box storage, we're talking about the ABI, we're talking about BRF, all of those things that have just been released into mainnet are now available in these SDKs, so you can use those in those languages. We also have SDKs available in other languages that are maintained by our community that follow on shortly after the features are released to mainnet. All right, well, let's take a look at where you can find this. You can use our developer portal, so that is developer.algorand.org. and you can click on the button for the SDKs. Choose whichever one you identify with to get it installed, and then I just want to remind you, just go back here, at the bottom, right there you can see that it says the community supported SDKs as well are there, and we have those available in C#, Swift, Swift, Rust, and a handful of others. All right. Here's what it looks like to install it. It's quite easy. If you have Node installed on your environment already, you can use npm install algo SDK, and we know that you already have your Python installed, so you can simply use pip to install it using pip install py-algorand SDK. All right, so now you've got your SDK installed. So the last part of the developer environment components is the language and the framework piece here. So first one that we're going to talk about now is PyTeal, and this is a language binding for Teal. And we want you to use read the docs here, so you can go to pyteal.readthedocs.org and learn all about it, how the language works, and what the syntax is for it as well. And this specifically, PyTeal, will be covered in an upcoming session here later this morning. So how do you get it installed? Quite simply, pip install PyTeal. And what does it look like? What does the syntax for PyTeal look like? Well, PyTeal is about writing expressions that are organized into abstract syntax trees. We feel that this is much more approachable for new developers as opposed to writing Teal, which is an assembly-like language. So as you see here, your program code will later on be compiled into Teal, and you can use the SDKs to make, sign, and send transactions after you have created them and your Algorand smart contract code. So it's not terribly easy to see right there. That's a little small, but a bunch of expressions. We'll see that in an upcoming one. We'll be able to zoom in on that. Importantly, pyteal.readthedocs.org for what it looks like. All right, and then the last piece that I want to take us to is something new, is the Beaker framework. And Beaker has been developed by Ben, one of my colleagues here on the DevRel team, Barnji, yeah, in the house, right here. So meet the dev, definitely. And again, Barnji is on Discord, what seems like all the time. And if you got questions about this, you can reach out to him. All right, so Beaker is a Python framework for building Algorand smart contracts. It gives syntactic sugar, maybe we'll say, to how we can write PyTeal as well. So what does it look like? I'm sorry, first of all, how do we install it? Well, guess what? Pip install Beaker-PyTeal. And do note that you could start here with this, and it will, as a prerequisite, install PyTeal for you as well. So here you are. You've got installed. What does it look like? Well, it looks like this. The nice part about this is it's really focused on making the developer experience easier from a syntactical standpoint. So first you're going to create a class to represent, in this example, a calculator application, and then you're going to see that you have that you're defining methods for each of the various calculator functions in there. It talks about you are providing the input types and also the return types for each of those functions. You're adding a decorator to make them external. That this then says that these should be prepped to use the ARC4 specification for our application binary interface. All of these little acronyms you're going to learn about in the upcoming session as well, but trust me, this is making it way, way easier for developers to take the smart contract code, make functions available, and then turn them outwards so that clients could then come and interface with your smart contracts. Beaker's super helpful for that. All right, so let's see here. Did I miss anything on that one? Yeah, all right, getting started. All right, so what I want you then to do is to now test your development environment. So I've got a nice repo here in on GitHub. It is the organization name for us is Algorand repos there with lots of great code samples here. This one in particular, in here we've got a whole bunch of scripts that help you generate accounts, to test your environment straight away. It goes sandbox, getting everything turned on. As you go down a little bit farther, you'll see about, there are some Python scripts in here that are numbered. So the first one here is about account generation, right? So you see the code and what it takes to use the Python SDK in order to generate a brand new account. Every time you run this, it does. There's no value in them, but they now are able for you to then use later on in your code to send some value. What else do we have in here? We've got the clients. Yeah, you got to know about connecting your client then, or connecting your code then to the infrastructure that's running in Sandbox, right? So here's the code for connecting on port 4001 to the Algo D node, and they're similar for connecting to your wallet to the KMD interface on port 4002. Let's see here, then this is the primitive for all transactions that you're going to do using the SDKs. You are always going to build an unsigned transaction. You are going to then sign that transaction, and then you are going to submit that transaction to the network. And then you're going to wait for its response so that you know that it was actually committed, and then take some actions thereafter. So all of this is covered in this Getting Started guide available on that GitHub repo. All right, so we've covered it all. We have got you all the way through setting up your development environment here. But wait, we have also an additional way that you can choose to set up your development environment that takes all three of those components and sticks them into one, and this is called Reach. And Reach is also a Dockerized development environment here that takes everything, puts it together a little bit later. Yes, a little bit later on on this stage here, we are going to hear from the founder and CTO, Jay McCarthy. He's going to introduce you in much more detail to what is Reach, how to Reach, and then later on this afternoon, we are going to hear from Mr. JP Miller, and he is going to build an application using Reach. So I'm going to cover the basics in terms of getting Reach set up for you here today, and I will leave it to them to actually show you more of the how, all right? So where do you go? First thing that you do to get installed is head over to reach.sh, and they have great documentation for showing you how to install it on the platform of your choice. All right, Windows, Linux, or Mac OS, doesn't matter. So what you do is simply execute the installer script and then make sure that it's running. Here's what it looks like. One thing to note, that you will need to install make, because Reach uses make inside of that Ubuntu or Bash environment. So make sure that you do that. We're going to make a new directory here specifically for Reach, and we're going to then pull it down and then execute it so that it's running. You can ensure that it is running by simply issuing the command reach version, and it'll give you a response back that says it's good. And then you are ready to Reach run and build your code. All right, so we'll see a little bit more about that. So great tool there, Reach. What does it look like? The syntax for Reach. This is a JavaScript language. So if you are a JavaScript or TypeScript dev, this will look very familiar to you. And basically, like this is showing we've got two different participants here, Alice and Bob. We can see that they want to get some data and put some data. So this really allows you to focus on your business logic. It's a high-level language that abstracts away all of the complexities of writing smart contract code. You're building both the back-end code and the front-end testing harness simultaneously, and then when you generate your code, when you say reach run, it runs through a formal verification process and really helps mitigate, almost eliminate common errors that are found within smart contract development, because the compiler itself will tell you, hey, you missed this, go and change this so that you aren't going to introduce bugs into your code. Very helpful when it comes time for getting your code audited prior to deployment. All right, that's a little bit about that. Let's move along now into how do we connect, right? Where do we want you as an algo dev, now that you've got it set up, where do we want you to go? And that is the developer portal. Okay, so here it is again, it's developer.algorand.org. Here we have it organized across the top into build, learn, connect, and in there, most importantly, go into the connect part and connect with us on our Discord server. Our Discord server is discord.gg/Algorand. That's where all the DevRel are at. They're essentially there around the clock because we are globally distributed and there to help you. So you can get the link here. There's all sorts of great content under Learn. We've got articles coming out all the time provided by the community who are showing people how to build various solutions. Our team, as we are putting out new features, are putting out articles that talk about, well, what is box storage? How would I use it? What is an oracle? How do I make a beacon? So all of these different things are always updated on the dev portal. Make sure you connect with us there. The other thing, we've got something new on the dev portal, which are challenges. And these challenges are a lot of fun where they allow you to prove what you have learned over time and be rewarded with an NFT to demonstrate the knowledge. All right, so you can come in and it is a browser-based IDE where you select your language first. You want to do it in Python or JavaScript. It brings up a little IDE within the window itself. You go through the boilerplate code that we have there, and you update the code to answer the challenge. And when you then execute that code, it is evaluated, and if you did it successfully, congratulations, you will get yourself an NFT to demonstrate that. Then you can show off to everybody, like, look what I have done. I am a true algo dev. So check out the dev portal and the challenges there. And now, if you want to know about all of the code that you have seen today in this presentation, it is all right here. So show me the code, hit that QR code. That'll be a link to this presentation so that you can go back and review, get all the other links, and do it yourself. Do the play-at-home game. All right, well, thank you all very much for being here again, and I want to make sure that you do connect with me and the Algo Devs group on Twitter. I've got time for some questions, so if anybody has anything here, let me know right here in the front. So we'll wait for the mic, and that way we can get everybody to hear.
Thank you. I was always curious when connecting to, let's say, Algo Explorer Indexer or the node, you don't need a token. You need a token when connecting to the sandbox. Is there a reason for the difference?
You're right. There is a lot of reverb up here. Something about the indexer and why is?
When connecting to Algo Explorer, the Algo D that they provide,
Yes.
you don't need a token.
Okay, so.
The HTTP header, and you need that for sandbox.
Okay, so I think the question has to do with Sandbox. Sandbox provides an Algo D node, and when we looked at the code that was in here to connect the client, it requires that you give it the localhost and the port number, and it also requires that you give it a token. So Sandbox by default makes that 32 A's. So it's the same token for everybody. Now, is that getting to your question? Yes. Okay, so other API providers, we have other API providers in the ecosystem that are providing public nodes that you could connect to for the public networks, obviously, and some do not require you to provide an API key where they're just free to use. Others do require you to provide an API key. What an API key is really is a security measure so that you can know who is connecting to you, because that would be data that you could either choose to give to an individual. It's 32 bytes, so there's plenty of randomness that can be generated within there. For the sandbox environment, again, we are making it the same for everybody. So we do require it by default here, and if you are using an external API provider, it would be up to them for what they're providing. More questions? Anybody?
Hi, I have a question.
Great.
So I wanted, if you're providing the same API for everybody, what about governmental organizations, specifically if they have their own implementations on security? So which part of all the APIs that you're providing would be responsible for that, and how can we learn about it?
Yeah, I totally didn't hear any of that.
Okay, let me speak. This is better. So if we want to change the form of security within your sandbox to work for external organizations, governmental organizations, how can we use it? Which part of these APIs would be the most appropriate to address, and how can we learn more about it?
So you want to change the
Security mechanism.
change the security model of the sandbox. Okay, so the recommended use for sandbox is for a local private developer environment, and the configuration files for sandbox would allow you to change the default to any other 32-byte value that you would want to provide in there. That would then ensure that nobody else could connect on the default one. If you are connecting to a public network, well, I guess importantly, Sandbox is running within a Dockerized environment. So the external attack vector surface is really limited to that. It's only running on your machine, and it would not poke holes externally through your router to go outside. I think your attack vector is quite minimized with Sandbox.
But if we want to deploy it on a network or a set of nodes, and we want it to be on not a personal dev area, but more of a distributed system or network.
So Sandbox allows you to connect to public networks that Algorand already provides. So BetaNet, TestNet, and MainNet are the public networks that you would be able to connect to.
What if we have a private network?
If you have a what? I'm sorry?
Private network. For
Yes, the private network as well, and that would be just using dev. So when in the example I had said, you use the command sandbox up dev, you could also use the command sandbox up testnet or betanet or mainnet, and then it would connect to those various networks that way. Do you have any other questions? All right, again, my team here on the DevRel team are in the house, so if you have difficulties in setting up your developer environment, please reach out to us. We are sitting around, maybe hands in the air, where are we at? Ben, Steve, Chris, Pranjal back there, and Joe also there. All right, great, we're all here. And then joining us online in the Americas, we also have Everett, Russ, and our boss, Jason. So thanks everybody for the time today. And all right, next up, I'm done with this. So we're gonna bring up the next set of speakers. A couple of my colleagues here, Zeph and Jason, they are senior software engineers, and they are going to talk to us all about what's been going on in PyTeal over the past year. This is the more of a deep dive into how do you use PyTeal, and importantly, what are the improvements specifically for boxes and for the API. Jason and Zeph, welcome to the greenhouse. Welcome to the Developer Tech Talk stage.
All right, Ryan, thank you so much.
You're welcome.
Let's give it up for Ryan one more time. All right, hi everyone. My name is Jason Paulos. I'm a senior software engineer here at Algorand, and I'm joined by Zeph as well.
Yeah, I'm still setting it up.
Just a second. We've got some great stuff to show you today with PyTeal. In the audience today, how many people, by a show of hands, have used PyTeal before? All right, that's a pretty good number. So whether you've used PyTeal or not, I think we're still going to have some interesting content for you.
Oh, there it is.
All right, here we go.
Here we go. Yes. So I'm Zeph Grinschlag, and yeah, today we're going to talk about PyTeal. I'll start off by reviewing a little bit about PyTeal, and then we're going to dive into a new capability called application boxes that the most recent version of the AVM is introducing, and how to use boxes in PyTeal. After that, I'll talk about the ABI router, which is how you create the so-called ARC4 compliant smart contract using PyTeal. Then I'll hand it over to Jason, who's going to do a pretty nifty demo. I think you're going to enjoy it. And time allowing, we'll open it up for some questions. So let's talk a little bit about PyTeal. The Algorand virtual machine, that is the AVM, is called every time you make an application call transaction. And it runs by evaluating byte sequences which represent instructions in an assembly-like stack-based language called Teal. Now, many developers prefer to author smart contracts in a higher level language, and so Algorand provides PyTeal, which is based on Python and lets you compose expressions that then get compiled down to sequences of Teal instructions, and then that Teal is run on the blockchain. Now, on the blockchain, this new capability for storage called application boxes is one of the topics we'll talk about, and we'll talk about how you use them in PyTeal. But also, I'll talk about the ARC4, which represents the fourth Algorand request for comment, which describes the ABI, that is the application binary interface, which you can think of as a set of best practices for interacting with Algorand applications. In particular, it describes how to encode rich data types, how to make method calls, and also how to publicize what your contract is doing through a JSON file, which you could think of as like, if you've ever programmed in C++ or C, it's kind of like the .h header files that have the signatures of the actual application. So we're all here in Dubai, and one of the great things about Dubai is the Burj Khalifa, which I can't wait to visit tomorrow. And the Burj Khalifa is the tallest building in the world, and it's my favorite tall building. I'm wondering how many of you agree with me. It'd be awesome to have a poll. Take a poll and see what people's favorite tall building is. Imagining such a poll, I would put the Empire State Building in the poll because I lived in New York for 20 years. Burj Khalifa would be the second choice. And then we have several other choices, 6 buildings altogether. And if you don't necessarily find your favorite building in the first 6, well, go ahead and choose the 7th choice. Imagining how this dapp would look like on the blockchain, well, you'd need to have an administrator that could create the app or delete it, and then open it up for voting and close it when the voting is complete. Once the app is open for voting, anyone ought to be able to submit their choice and also query for the status. What does that mean? Well, let's think of an example. I would definitely submit Burj Khalifa as my choice. And if we take a query for the status after 100 such submissions, perhaps we would see that 11 have chosen the Empire State Building in New York, 35 chose the Burj Khalifa, agreeing with me, and so on and so forth. Well, there is one constraint that we want to take care of in such an app. We want it to be a fair poll. That is, we want account 1 to, if they submit choice 2, that's fine, but if they submit an additional choice 4, we don't want both of those votes to get counted. Even worse would be to double count if account 3 could keep on voting for choice 6. That just wouldn't be fair. Well, how are we going to ensure this fairness property? You'll need to somehow keep track of who voted for what. So you actually need to store that information. Applications on Algorand have storage capability already built in. There is global storage. That is, the account that created an application can set aside some storage for the application to use during its operations. The problem is that the maximum amount of storage it can set aside for each application is only 8 kilobytes. And that means that if you're storing each account address of 32 bytes to keep track of whether it voted or not, that's only 256 accounts total. And we want this to be open for more than that limited amount. Another thing you could do, you could perhaps use local storage. Every time an account opts into an app, you can set aside some storage for that account to use in the app. But that's a problem because the account needs to opt in, and we want this to be very lightweight. Opting in costs 1/10 of an algo, and it'll be even a little bit more than that for the storage, and also it creates another transaction, and that's just a little too much friction for what I'm looking for. So come to the rescue, application boxes. Makes it a lot easier to keep track of this information. So what are boxes? It's another key value store. However, this storage, it lives in the account that the application itself has. And the term that we use for the keys are names. So every box will have a name and a value. And another convenience is that not only is there an unlimited amount of boxes you could have for this application account, but you can add them as you go along. You don't have to decide at app creation time how many boxes you'll need. And so how are we going to solve this problem in our case? Well, for example, here, account 1 has voted for choice 2. Well, we'll simply save for the name of this box, the address of account 1, and we'll store for its value the byte 2. And if we had 1,000 submissions, that just means we need 1,000 boxes altogether. So how do we actually create and use boxes inside of PyTeal? So PyTeal is making available 7 new methods on the app class. The app class lets you interact with applications and get information about the application, including what is local storage for the application and so on. It also lets you manipulate things about the application. And so there are 7 new methods which are in one-to-one correspondence with the 7 new opcodes which are coming into AVM 8. And so here we see the 7 methods, and I want to start with the bottom 2, which these I would say are like the workhorse methods, box put and box get. So box put is a very handy method. It lets you for a particular box name, it lets you set the value of the box. If the box didn't already exist, it'll actually create the box in doing so. Box get just gets you the entire value of the box. And if the box didn't exist, it enables you to handle that in a way that we'll see shortly. Now, those are very useful for maybe typical use cases, simple use cases of boxes, but boxes can be very big. Boxes can be up to 32 kilobytes. Their values can be up to 32 kilobytes in length. And the stack of the AVM is limited to only 4 kilobytes. So we can't really create a box with a value of 32 kilobytes at the same time because it just doesn't live on the stack. So when you want to create a bigger box, you'll use box create, but specify the size of the box along with the name, and you'll actually create a box with all zeros for that particular size at that point in time. Box length is another very useful method if you want to know the length of the value being stored in the box. And box delete is a crucial method as well, because one oddity of boxes is that if you delete the application after having created some boxes and didn't delete the boxes beforehand, you will never be able to reclaim the minimum balance requirement you set aside for those boxes. So very important to always delete your boxes before you delete your app. And then there we have two last methods, box replace and box extract, which let you manipulate inside a box. You'll definitely need to use them for very large boxes, but sometimes if you have a more complex use case, you might want to use those as well. So let's actually see how we're going to use box get and box put to keep track of voting. So over here, we got a choice. I'm hard coding that choice to be the index, to represent index 1, which was the index of Burj Khalifa. However, in the real application that Jason's going to actually show, it's being received as a parameter, which represents the actual vote that's taking place. Also keep in mind that, yes, we have this key value store, the boxes, which is going to map for any account, the account address, the choice that account has made. We were also going to keep track of a running count. That's going to be kept in our global storage, the older form of storage. So let's actually look at the logic that we're going to be using to store the new vote. So we're going to use our box get method by providing the name being the sender's address. All right? The old choice. An old choice is a PyTeal maybe value. And why is it a maybe value? Because we don't yet know if that box exists. Because the first time the person submitted, the box has not yet existed. The second time, the box exists. And so this maybe value is perfect for encapsulating that determinism. And so what we'll do is we'll call the has value method on that maybe value for the old choice. If it's false, we won't even enter runtime the rest of the code inside this if block. But if it's true, then we'll enter the box exists, and now that the box has a value, we can actually query the value. And what we're doing right here in this line is we're decrementing the count for that choice. Regardless of whether this is the first or a later submission, we're always going to want to save the choice for this for the current sender's address or account in its box. And so that's what we're doing right here. Finally, we want to increment the count for that choice, and that's what we're doing in this next part. Okay. So now you kind of see how to use boxes for storing the votes, which is kind of the main core logic of this poll application. How to put the application together. So we have methods that allow us to interact with our app, and remember what those are. Those are create, open, and close that the administrator should be using to manage the app. And we have submit and status open for all the participants in the app. And we have this other operation, delete, which I didn't call a method for a technical reason, which will be apparent in a bit. So as a reminder, every app call transaction has an onComplete action that goes along with it. Typically, the onComplete action is no op. That is, don't do anything apart from running this code. However, sometimes we want to do more things, like we want an account to be able to opt in to an app. I want to let it do the opposite, which is close out, or maybe you want to be able to let it forcibly opt out by calling the clear state. And some of the, most of the onComplete actions call the approval program, while the clear state calls the clear program. In our case, the one we're most interested in is the delete application onComplete. That's how you delete an application during an app call transaction. Well, if you think about it, if you want to delete the application, it's just enough to say that's the onComplete. You don't have to provide any extra information. You don't need any arguments. Well, that's why I said that delete was not really a method, because there's a special term for application call transactions that don't have any arguments. Those are called bare app calls, according to the ABI, the ARC4 ABI. So the delete is going to be a bare app call. However, when you do have arguments, those are called methods, and the ABI says that the very first argument is reserved for the selector, and the selector is a 4-byte sequence which will let the Teal program figure out which code actually has to be executed. And we'll actually see an example of that. All right, so now I'm going to talk about the router, and every router answers 3 questions, M, O, and E, that is Mo. And for those of you who have no idea who this person is, that's Mo of the Three Stooges. All right. So what are these MOE questions that the router is trying to answer? M is for method. That is, which method is being called? Or if it's not a method, is it a bare app call? The O question is for onComplete. Which onComplete is being requested? E is for existence. Does this app already exist? And if it doesn't exist, well, it means that we're actually creating the app in this very same transaction. So how do you create a router in PyTeal? Well, first you initiate by giving it the contract name and giving it the bare call actions. Now you have a router object. That object has a method property which you then use to decorate Python functions which are going to become contract methods. Now that's a mouthful, but you'll see this working very soon. Now, once you have the router object and you've attached methods by decorating them, by decorating functions, you call compile program, which creates 3 artifacts: an approval program, a clear program, and a JSON contract. The JSON contract doesn't live on the blockchain. It's kind of like a header file if you've ever programmed in C or C++, like the .h file. It has the signatures. But the clear and approval program, those will end up on the blockchain. Okay, so let's actually do this. Let's see how this all works. I'm putting a warning sticker here because this delete action is a no-op. I'm not actually giving it any code, which means it'll always say, okay, you can delete that. You don't want that for running application. You want to authorize, make sure that only the correct sender is allowed to delete the application. But again, you'll see the real code when Jason goes through it. So here we are. We're creating the router. We're giving it our name, which is going to be Open Polling App. And we're giving it the bare call actions, including our delete action. We're also giving it this optional parameter for the description. Okay, so we have that router object. The router has a method property. And we can decorate Python functions to create contract methods. So here we are. I'm going to only, for demo purposes, only do one method here that I'm decorating, submit. And again, it's just a shell. There's not real code running here, just to make the slide easier to read. But other things to notice are that there is this docstring that has a special purpose. And notice that choice, the parameter choice, is annotated with this ABI uint8 type. Okay, what is this uint8 type? Well, the ABI provides a variety of rich types that are encoded in prescribed fashion. So the uint8 is an 8-bit big endian unsigned integer. There are many others. There are uints of other sizes, 16, 32, and 64. You've got booleans and bytes and different kinds of arrays and tuples and strings. To read the doc that Ryan showed before has all that information in there. So let's actually compile the program. So I got the router object. I call its compile program method. I give it a particular version. I'll need 8 because boxes are only available from version 8. And we want to optimize the scratch slots to remove redundant scratch slots. And the first thing we'll have a look at is the JSON contract. So here, remember that the name that I gave the router, it becomes the name of the contract, Open Polling App. The methods, well, I only decorated one Python function, method back, it's submit, and it has some arguments, well, only one argument for choice, and it was a uint8 type. And now docstring ended up becoming the description of this ABI method. What about the approval program? What does it look like? So let's actually look at the code that was generated from this for this submit method. So this is the Teal. And remember, the router is answering 3 questions, M, O, and E. M is for method, which, okay, there we go. Now we're at the top of the code. M is for method. Which method are we in? So it gets the method from, remember the index, the first argument is reserved for the selector, so that's index 0, and it compares it with the selector for the submit method, which is generated using this handy pseudo opcode in Teal called method. So it says, oh, is this the submit method? For us, the answer is yes. And then it goes to the branch main L3. Now it's ready for the O question, which on completion, no op. Okay. Now it's ready for the third question. Application already exists. And this is how you ask such a question in Teal. You ask, does this application ID, is it non-zero? When you're creating, so we've asked M, O, and E, and so now we're delegating to the actual code. And To do that, we need to actually read the application, the method argument. And the first method argument is at index 1. It represents choice, which was a uint 8. So we need to decode that uint 8. How does PyTeal create the teal to do that? Well, we know that uint 8 is just a single byte. So we're going to get that byte at index 0. We put it on the stack, and now we're ready to call the subroutine that implements the code for submit. Now remember that that code for submit was a no-op in our case. You'll see the real code. But it's similar to the code that I showed with boxes, but it's going to return right away in this case. And with that, I think I'm going to hand it off to Jason and the demo. Okay.
Thanks, Zeph. All right. All right, so this is the contract that we've written for this demo. I'm not going to go too much into the details here. I just want to give you a very broad overview of the things going on here. First of all, we have a router object right here. This is going to be the central object that our contract uses to actually route between its different methods. We do have one bare app call action, and that is for handling on delete, which is done up here. And then if we go down a little further, we do have here just keep track of the names of the keys that are going to be used in global state. And we have this variable num options, which lets us control how many options for responses do we want in our poll. In this case, it's 7, but you can change this and recompile if you want to. And then lastly, we have the methods that are going to be defined for our contract. So we have create. This is going to be how you create a new poll with a question and a set of options. We have open poll and closed poll. This is how an administrator can control whether the poll is open for responses or closed. And we have probably the most important method, submit. This is how users will be able to submit a response to that poll, and they'll indicate their choice in the argument up here. Lastly, we have the method status, and this method is responsible for returning information about the current poll. So these are things like whether it's open, what the current count is for each result, how many people have voted for that result, and that's all going to be contained in this poll status object, which is a named tuple, which is kind of an abstraction in PyTeal that lets you create tuples in a more friendly way. And so with that, we just have a statement down here to compile our program from the router. We get our approval program, our clear state program, and our contract object, and we just write those all to files. And so if you want to take a closer look at this code, it is going to be available on a GitHub repo, and we will definitely give you the link to that so you can kind of dive in and see how it works. Next, I just want to briefly show you, this is the approval program that was generated from our contract, and this is the contract JSON that describes our contract according to the ABI, and it has every method that we just defined with all of the details necessary to call them in here. And so that's kind of everything on the quote-unquote back end of this demo here, the smart contract and the information needed to access that smart contract. And I want to show you, we have created a front end for this demo. This is a website, and we're using React and our JavaScript SDK to actually interact with the polling app on chain. And so if we scroll down a little here, we have an option to create a new poll, and I've already populated it with all the information that we want. So we want to ask people what their favorite tall building is, and we have these 7 options to choose from. And I can also control whether this poll allows you to submit another response, to change your response after your first one, and I'm going to leave that as allowed for now. So I'm going to hit create. This is going to send an application create transaction to the blockchain. We're using BetaNet right now because that's where boxes are active at the moment. And all right, so that transaction has succeeded. This is actually our application ID on BetaNet for this polling application. And we have here a few options. This is how you actually submit an answer to the poll. However, if you can see, these options are grayed out. I can't do this yet. And that's because as the poll creator, I actually have access to this admin panel. And this is going to let me open the poll as well as close it to control whether submissions are being taken or not. And I can also see information about the poll. So every application in Algorand has a corresponding account that's used for a few different things. For our purposes, that is where the minimum balance must be stored for the boxes that application creates. So I'm going to fund this account with 32 algos for now, and I'm going to send those. This will be enough for our specific purpose to create over 2,000 boxes of 33 bytes each, and that's going to be, I think, plenty for this demo. So this has gone through. Our balance has increased to 32 algos, and at this point, I'm going to open the poll. And we'll be able to actually send in a vote in a second. Okay, so it has submitted, and now says the poll is open, and I am free to choose for an option. So because we are in Dubai, I am going to vote for the Burj Khalifa, and I'm going to submit this option right now. So it is sending a transaction to the chain to actually send that with an application call and create a box that records my vote. And here we go. You've already voted in the poll. I may submit again because I left that option enabled when I created the poll. But what I actually want to show you is I'm heading over to dapp, which is a block explorer. I want to show you some of the transactions that are happening behind the scenes to actually enable this demo to actually work. So this is the account that I'm using currently. I'm just going to refresh this page. And there's a few things that have happened within the past 2 minutes. So this first transaction, why don't we take a look at this? This has actually created our application, our polling application. This app ID is the same one that we just saw on the last screen. And so this is the approval program for the app, our clear state program, and our arguments that were used to create it. You can also see, if you want to inspect the global state, here are all of our options that the poll is going to be using. All right, so I'm just going to click on the application ID so I can get an overview of this. And in dapp, I can actually attach that contract JSON that we generated earlier to this app, and dapp will kind of tell us all of the methods that are associated with that app. So I have a link to our GitHub repo for that contract JSON, and I'm just going to import that right now. And we now have a new piece to the interface, and this is all of the methods that our application supports. So creating, submitting, etc. They're all here. And what I want to do now is I want to go back to my creator account, and I want to look at the most recent transaction, which was me actually submitting a vote into this poll. And we now have this button for the option to view are the transaction arguments decoded according to the ABI. And dapp is able to tell that this was the submit method being called. And our choice argument, we use the value 1 because the index started at 0. Burj Khalifa was our second option. So these are the transactions kind of underpinning the actual operations that our poll is taking. So now, I actually want to open this up to everyone here so you can vote as well in this poll, and we'll kind of see which building comes out ahead. Before I do that, I just want to make everyone aware that I'm going to give you a QR code. You're going to see a screen just like this. What's happening is we have randomly generated an account for you that's stored locally in your browser on BetaNet. However, it's not funded yet. You're going to need to use the dispenser right here. Oh, it's going to make me actually do it this time. I hope I get it right. Oh, geez. This was not what I signed up for. Okay, well, you guys can do a better job than me. You hit dispense, you'll be funded, and then you can actually vote in the poll. So let me get that QR code up, and I'd like to invite everyone to scan this and vote in the poll with us. So let's take a few minutes to let you do that. I believe in you guys.
Oh, we're getting some results.
Did it work, Seth?
Yeah, we got
You
5
voted?
so far.
Great.
10. The tie between Empire State and Burj Khalifa so far.
Yeah, how are we storing the accounts, I think was the question. This is just a demo on BetaNet, so we're not really using what I would call best practices. But what's happening is we generate a new account locally and we store it in your browser local storage just temporarily, just so that this demo kind of has low friction. But in reality, if you were doing this on mainnet or care about security at all, you would use something like Wallet Connect or a similar protocol to let people use their actual wallets to securely kind of work with the application. We have another question up here.
Hope you can hear me.
Yep.
You made a choice to store your options as part of the contract, not inside of a box. Could you comment on that? Why is it not a box?
Sure. Basically, we've talked about the differences between global state and boxes a little bit. But the answer is global state, it's convenient for applications to use because you don't have to specify anything additionally. And we only have 7 options in this case, so global state is, definitely big enough to handle that. But if you wanted, thousands of options, probably a box is going to be a better choice. All right, I think I will refresh the page and we can kind of see how we're doing. 36 submissions. Burj Khalifa is coming out ahead, 36%. Is anyone still struggling to submit? No? All right, well, I'll take that as a success.
I think so, yeah.
Oh, and I do just want to highlight, where is that repo? Here we go. We have a GitHub repo that you can kind of find using this information. And this has both the slides that Zeph has presented as well as the application code that I had briefly walked through. And it's got a link to that polling site as well in case you want to create your own polls and send them to your friends. So there you go, everyone.
Great stuff. Great stuff, Jason and Zeph. Thank you guys so much. That was really cool. Like we had 36 people do it. I mean, like that was like most of the people in the room and a bunch online. Awesome. Thanks very much for giving us the intro to PyTeal, teaching us a little bit about how to do that. All right, next up, we are going to have. We're going to have Chris Kim set up, but I think that there's another question that we're going to try to get answered off stage right over here. So yeah, take it offline. We're thrilled to have these questions being answered, but my colleague Chris Kim is going to come up here and he's going to tell us, introduce us to the Beaker framework. He's going to show us how to make use of that. So this is essentially adding on top of what we just saw here with PyTeal. This makes it even easier, syntactically even easier and more efficient to write code, write your Algorand smart contracts. Chris, you ready?
All right, awesome.
All right.
I think it's all ready to go.
All right.
All right.
Welcome, Chris.
Hi, guys. Hey, happy to be here. Let's get this party started. But let's be real here. So when you're first learning how to build a smart contract, it's a challenge. You don't just learn a new language. It's about you have to understand the decentralized application architecture. You have to understand blockchain concepts like what deploying a smart contract means, or how to interact with that smart contract, and how that smart contract is executed by the underlying blockchain. Now, these added complexities often scare away new developers. So smart contract development has to be dead easy. Now, the Algorand engineering team has done an amazing job in creating these two languages. PyTeal, our official smart contract language. Give it up to the engineering team over there. They're the ones working on this PyTeal right now. And the Algorand with your smart contract. Now, these are powerful languages that let you create complex and full-scale smart contract on the Algorand blockchain. But if you're someone new, just starting your blockchain journey, these can feel a bit unfamiliar, complex, and overwhelming to just get started. So we kept asking the question, how can we make smart contract development easier? We want to attract Web 2 developers who have never built on a blockchain before. And the answer to that question is the Beaker framework. Hello, everyone. My name is Chris Kim. I'm a developer advocate for Algorand, and my job is to make developing on Algorand simple, easy, and fun for you guys. By the end of this presentation, you'll have a full understanding of what the Beaker framework is and why the Beaker framework is going to completely upgrade your developer experience on the Algorand blockchain. All right, let's get started. So before we dive into Beaker, I want to quickly cover what the dapp architecture looks like on Algorand. So what you see on screen right now is a familiar Web 2 app architecture. We have the front end and the front where the users interact with your application. We have the web server that hosts the server, handles API calls, and the database that stores relevant data for your application. Now, an Algorand dapp architecture isn't too different. It still has those three components, and all you add on to that is the Algorand blockchain. And on the Algorand blockchain, you deploy a program called a smart contract, which is a program that lives on the blockchain that executes transactions under certain conditions. And that smart contract is executed by the Algorand virtual machine. Now, to deploy and interact with the smart contract, you use the Algorand SDK, either directly from the front end or through the web server. Now, today, I'm going to focus on these two things right here, the smart contract and the Algorand SDK, because that's what the Beaker framework improves. So introducing Beaker, the way dapp development should be. Beaker is a Python smart contract framework. When you're writing smart contracts using PyTeal, it improves the code organization and makes it more familiar for Python developers out there. When you're deploying and calling smart contract using the Algorand SDK, it makes it more easy to set up the front-end code and lets you get directly to deploying and interacting with your smart contract. It also provides tooling for debugging. So overall, it's a framework that abstracts away the complexity that you don't really have to think about and lets you focus on building your product. So I want to show you guys a quick code and a direct comparison of a simple calculator application written in bare PyTeal and Beaker. So I'm going to go over to my VS Code, and let's first take a look at the calculator smart contract written with PyTeal. All right, so we see, I'm sure this router class is now familiar because of the previous presentation. We have the router class set up here. It defines how the routing happens when the smart contract should execute certain part of the smart contract. And if you take a look at inside of the bare call actions, we see that if it's an application create transaction, you approve it. If it's an update or delete transaction, you check if the transaction sender is the creator of the application. If that's true, it approves. If not, it fails. So it defines all these rules for you. Now, this router class would be something a new developer would be unfamiliar with. And then down here, we have the four functionalities of the calculator app, to add, to subtract, and to multiply and divide. And all of these methods are decorated with the router.method decorator that's connecting these methods to the router class that we defined above here to let the front end know, hey, if you want to call the add method, the router class connects that and route it for you. Great, so down here, when we run this Python file, I'm going to dump out 3 files, the contract.json file, the approval, and the clear program. So these are the 3 files that is spit out when you run this file. Just to quickly show you what it looks like, this is the approval Teal program auto-generated by your PyTeal contract, the clear program, and the ABI JSON file. It looks like this. All right, now let's deploy the smart contract and interact with it. So I first want you to take a look at line 11 right here, where we're importing this function called getAccounts from Sandbox. So I have a separate file here that I've manually written, and I built this helper function to retrieve accounts that are given by Sandbox for you to play around with. So this is all code that I have manually written. Going back to interact.py, I'm going to define a couple helper functions. I have a create app function here. It takes in a bunch of parameters, and all it's doing is it's going to send in create an application create transaction. It's going to sign it, it's going to send it, and it's going to wait for confirmation and return the result. Another helper function here, compile program. It's going to take in the source code, compile it down so that you can use it when you're creating your application. More setting up to do. We're going to set up the Algorand client so that you can interact with the blockchain. We're going to use the getAccounts function that I defined in the different file and to get an account. We're going to read in the approval program and the clear program from the file system, and then we're going to use the compile program helper function to get an approval program and clear program. Here we're going to define some state storages. When you're deploying Algorand smart contract, you have to define how much local storage and global storage you want to have. And we're going to use that to define the global and local schemas. And finally, we're going to take all of that, put it into this create app function, and deploy your calculator application. Now, we're going to read in that contract.json ABI file here, and then we're going to use that to finally interact with your calculator app and call these 4 functions. So that's what interacting, deploying, writing smart contract looks like with PyTeal and the Algorand SDK. So if I go to the terminal here, and I run this file, python interact.py, you can see that the app was correctly deployed and the 4 functions were properly called. Now let's take a look at what that looks like with Beaker. So this is the folder right here. I opened that up. It's 1 file. That's a good sign, right? So let's take a look at it. So in line 9, you see a class. This looks like a Python class, right? When I expand that, you can see the 4 functions that you saw before, but this is the complete smart contract with Beaker. No router class, no need to connect it to the router. It's all done in the back, and it just looks like a normal Python class. Now to interact with that, we're going to use the sandbox module provided by the Beaker framework to set up the Algorand client to get accounts with 1 line of code, helper functions, and then we're going to create this thing called an application client. And we're going to take the 2 values that we got from up here to create a client for an account. And this client will be used to deploy and interact with this smart contract. And if you look at line 40 here, app_client.create, that's it. That's how you deploy a smart contract with Beaker. And then you right away get into interacting with the smart contract, and you just do app_client.call, and you can call specific external methods that are defined in your Beaker contract. Let's go back to the terminal. Now I'm in the Beaker folder. If I run this file, you can see that it has the same result. All right, let's do a quick recap. So what did we just see? The calculator app written with bare PyTeal. The smart contract code seemed a bit unfamiliar. We see this thing called router class. That's something that you have to learn. We have to manually define helper functions to deploy our app and to compile our source code. And so the front-end setup was very lengthy. Now with Beaker, the smart contract organization was very familiar. It's like a Python class. The helper methods were defined for you just to use right out of the box. So it was much easier to deploy and call your smart contract. All right, let's talk about setting up your development environment if you want to build with Beaker. So these are the 4 packages that you want to install. You want to have Sandbox to have a local private blockchain running in your computer so they can test against when you're building your smart contract. And you want to have PyTeal, Python SDK, and Beaker installed to build your smart contract. Take the time to scan this QR code right now. I just created a Beaker starter kit. So this will take you to a GitHub repo, and it's going to have 2 folders. One, a completed code folder, where it has all the code that you will see in this presentation, and the starter kit folder will have the same files, but it will be missing some code. So you will have to, this is the homework, you will have to go there and fill in those blanks and make those files run, because I believe learning by coding is the best way to learn. I have the instructions of setting up the projects folder and installing all the required packages down there. But for time constraints, please do come back to this slide afterwards and try it out yourself. So these are the Beaker components. We have 3 pillars. To improve smart contract development, we have these 3 components down here. We have the application client for deploying and calling, and we have Sandbox module for testing. Now let's talk about how Beaker improves smart contract development. So that's the right pillar over here. Let's first talk about the application class. So what you see on screen right now is a simple smart contract with Beaker. It has one external method called hello, which returns hello with whatever argument that you pass in. But I want you to focus on this highlighted code right here, the application class. Okay, so we are inheriting this application class, but what is it? It's a base class that all Beaker contracts inherit from, and it provides basic functionalities that all Beaker contracts use. So it includes logic like detecting state variables, on-complete methods, ABI methods, and internal subroutines. So it's abstracting away all of these things, the routing and all that, and you can just, that means your code will be much simpler. Let's talk about states. So on the Algorand smart contract, there are 2 states, local state and global state, and now we're having box storage being added. It's coming soon to mainnet in a couple of days. But on Beaker, the global state, we refer to it as application state. They're the same thing, but I'm going to refer to it as the application state. Now, before we start talking about it, I want you to take a look at this code right here, where we're using the final typing construct. So why are we doing that? So this is not mandatory, it's just good practice. So that's preventing reassigning of the variable, so it just reduces the chance of introducing a bug into your smart contract. So we highly recommend you guys do this, but it's not mandatory. All right, let's talk about application state. So this is how you set up an application state inside of a Beaker contract. You use the application state value up there. It has 5 characteristics that you can set up. If you take a look at the code, we see that the stack type is set equal to teal type .byte. That means this state has a byte value. Default set equals to, this value is immutable in byte. So a default means that when the smart contract is deployed and initialized, this is the value that it's going to have. Static is set equal to true. That means that this state is immutable. You cannot reassign new values to this state. And then we have a description explaining what this state is about. Now, what's amazing about Beaker is that it exposes this state to the ABI. So this is what it looks like in the ABI. You can see that the type of the state, the keys and the description is exposed in the ABI, so the front end knows how to interact and use this state. It will be much easier for them. The second type of application state is a dynamic application state. A dynamic application state is like a dictionary type state where it has multiple key value pairs stored in it. This will have 4 characteristics that you can define: stack type, max keys, keygen, and description. Here, I just want to mention out what max keys is. That's saying that the code here is set equal to 32. That means this dynamic app state can only have 32 key value pairs. Same story here. This is exposed to the ABI. All the informations and characteristics are exposed, and it will just be easier for the front end to know how to interact with this state. Now moving on to local state, or in Beaker, account state. Same story here. You set up the account state the same way you would set up an application state. It has the same 5 characteristics, and all that's changing is instead of application state value, you're doing account state value. And same goes for dynamic account state has the same 4 characteristics, and you set it up the same way. And account state is also exposed to the API. All right, moving on to decorators. Beaker provides 3 decorators for you to use: the external decorator, internal, and on-complete externals. Now we're going to take a deep dive into what each of these decorators are doing for you, but all of these decorators support authorization. So what that means is when you decorate methods with these decorators, you can say, hey, only this account, certain account, can access this method. So let's take a look at what that looks like. First, starting off with external decorator. I took a code snippet from the calculator app here, the add method, and you can see that is decorated by the external decorator. So what is that doing? What that's doing is exposing this add method to the API. So when you take a look at the API, you will see the add method written there, and it will explain what type of argument it takes in and what kind of output it outputs. It's also adding the method to the router. So this is how the smart contract knows when to call this add method. So the external decorator is doing all that for you in the back. It's like magic. All right, moving on to internal decorators. We have 2 methods up here. Let's first take a look at the internal add method decorated by the internal decorator. So what is that doing? Inside of the parentheses, it says teal-type.un64. That's just saying that this internal method is going to return a UN64 type. And what's cool about internal decorator, internal methods is that they're not exposed to the API. So when you look at the API, this internal add method won't be there. So internal methods are used internally, like the name suggests, and the other external methods inside of the smart contract can use the internal method for computation or other stuff. So how do you access it? This is an external method called add with internal. So it's doing the same thing as add, but we're using the internal method to do the same thing. If you look at the highlighted part, in the Python class, you access it with self. So internal decorators are great when you want to have repeated complex computation defined to use in multiple places. All right, last decorator, the on-complete externals. So on the Algorand blockchain, when you're interacting with your smart contract, there are special types of application transactions. These are the 6 application transactions that the Algorand blockchain supports. But on the slide, I only have create and delete up there. So what this means is if the front end says, if someone says, hey, I want to send in an application create transaction, that's going to call that create method right there. If someone sends a delete transaction, that's going to call the delete method down there. Finally, let's talk about authorization. So here, we're saying that this delete method will only be authorized to be called by the creator of the application, which makes sense, right? We don't want everyone deleting your smart contract whenever they feel like it, right? There are 2 other things that you can authorize. You can authorize accounts that hold certain tokens or authorize accounts that have opted in to the smart contract. If these don't fit your need, you can create a custom authorization logic by yourself as well. All right, let's move on to how Beaker makes deploying and calling smart contract easier. So I'm going to talk about these 2 components for now. And let's start with the sandbox module. Now, don't get confused. The sandbox module here provided by the Beaker framework is not the same thing as the sandbox that lets you run a private local blockchain on your computer. This sandbox module provides some helper functions to get values and interact with the sandbox that you have running in the background. So the code here, the highlighted part, is we're doing sandbox.getAccounts. That's going to get a list of accounts provided by sandbox. And if I print that out, you'll see 3 sandbox account objects, each object including an address, private key, signer, which are all the things that you need when you're testing, when you're building your application. Here, I'm just popping one off from that list, and I'm going to print out each of the attributes, and that's how you would gain access to these values to use in your testing. And finally, you can use Sandbox to set up your LLD client with 1 line of code, And just to showcase what you can do with those clients, you can get the minimum fee of the Algorand blockchain, just like that. All right, moving on to my favorite part of Beaker, the application client. So up here, we're doing the same thing. We're using the sandbox module to get the accounts to set up the Algorand client. And we're going to use those two values to set up the application client. The application client takes in 3 arguments: the Algorand client, an instance of your smart contract, because it's like a Python class, you can create an instance of it, and then a third argument, which is a signer of your account that you want to create the application client for. So what is an application client? It's a convenient way for you to deploy and interact a smart contract for an account. Now, if you take a look at the definition of this application client, these are the helper functions that are defined in there. That's about 20 helper functions just ready for you to just use right out of the box. This means if you're not using Beaker, all of these functions you would have to manually written, and that's saving you about 750 lines of code. So Beaker is a powerful, powerful framework. The code right here is a demo code of using the application client that we just created. So I'm just going to highlight the part of the code that is actually using the app client. So starting from the top, we see that we're using the app client to create the application, to fund it, to opt in, call external methods inside of the smart contract, to get application account info, to close out, and to delete the smart contract. And notice how all of these you can do with one line of code. No more manually creating transactions, signing them, submitting them, and waiting for confirmation. The application client handles it for you. So that's it, guys. That's everything about Beaker. So what did we learn today? Let's do a quick recap. We first talked about what a dapp architecture looks like on Algorand, just to do a quick comparison of a Web 2 application and a Web 3 application. And it's not too complex. We're just adding the Algorand blockchain, and a smart contract lives there, and we interact with it using the Algorand SDK. And then we talked about how to set up your development environment to build with Beaker. And then we took a deep dive into what Beaker is, looked at each of the components, and why it's such a powerful tool. Well, that's it, guys. Please take time to scan these 2 QR codes here. The QR code on the right, is that left or right? Right, yes. Right here is going to have all the resources that you will need to become an Algorand developer. The link to this slide will also be in there, so please scan that. The QR code on the left is going to have my social media information. I'm not sharing this to increase my Twitter followers. I want to reach 1,000 though. But jokes aside, the reason why I'm sharing it is because I want to connect with you guys. I want to help you guys answer your questions and connect you guys to the right people when you're building your application. So hopefully, I hope that my presentation has given you a fine understanding of what the Beaker framework is, and I hope it inspired you to look deeper into this framework and start building on the Algorand blockchain. Thank you so much. All right.
Stuff, Chris. Thank you very much. You got some time for questions. Let's
Yes.
look out here. Does anybody have some questions for Chris on the Beaker framework? Put your hand in the sky, and we will come and
We got one
to you.
back there.
All right, speak loudly because it's hard to hear up here.
All right, let's see if I can answer these questions.
A rather dumb question here. What are the situations when we do not want to use Beaker? Or can we use it for every eventuality?
I'm so sorry, I can't really hear you. Can you say that again, please?
What are the situations
I see. So the question was, when should we not use Beaker, or should we always use Beaker? Well, Beaker is a framework, so it's another layer of abstraction, right? So if you're the type of developer who wants to be certain what's happening with your code, you might prefer to just build with bare PyTeal to give you more control over what you're building. Beaker definitely makes it much simpler, but it's relatively new. We're still doing some testing on it, so it could have some potential bugs that we are not aware of yet. But those are like the pros and cons that I guess you will have to wage when you're deciding what you want to use. Yep, back there, and in front here.
I have a question about a developer community. So when we debug code, if we find some problem, like is this algo devs resources is the place we can send our questions?
Yes, so the Algorand resources, it will have multiple links like to the Discord, to the forums. I would say Discord is the best place to get your questions answered. We have Ben, Steve, and our DevRel team always on there answering questions. I would say the forum is also a great place to get your questions answered. But yeah, you should have all the links to the resources there.
Yeah, and related to that, is there like a physical in-person gathering together around the city?
So the question was, is there like an in-person help session?
Yeah, because a lot of time the coding exchange by online is not as effective as you just sitting down with your neighbor and debugging the code together.
That's right. I don't know if we can. Well, we do hold workshops, in-person workshops, and I think those are the places where we can answer questions in person. I would say right now is a great place to get your questions answered. But we do hold virtual office hours to help you help answer those questions. Yeah.
Hello, thanks for the great session. Just wanted to quickly clarify one thing, and I'm sure you covered this already, but for cases when the contract is already deployed and you have an app ID, if I got it correctly, does this mean that you simply need to pass that app ID to the application client when you initialize it? Or essentially, is like what way to deal with instantiating the application client class when you already have the contract deployed? Because a lot of demo examples in the Beaker repo is I suppose for the demo purposes, every time you compile it, you deploy a new contract, right? But what's the best practice to instantiate it if you already have it deployed?
Okay, I got app ID. I'm so sorry. This reverb is crazy. Did you get that question?
Yeah. I mean, it has to do with when you instantiate the app client. Typically we are just redoing it, right? And so you do have the ability to specify a particular application ID. If you don't specify that, then it is going to create it by default. So if you're using the Beaker framework and you have the extension within VS Code installed, the syntax of highlighting will pop up and it will tell you about that in there. Yes. So to follow on then, yes, you can have your testing harness that is using a pre-deployed smart contract, and then you are always specifying your identifier so that you are always calling that contract. Do we have one more? We have time for one more question before our next speaker?
Yeah,
right here.
sorry.
Great.
So just one quick question. How do you decide what makes its way to Beaker and whether it goes all the way back to PyTeal? So certain functions are essentially shorthands for PyTeal code that you would write very frequently, right? So rather than doing that regularly, if you use Beaker, you can just do that in one line of code, as you alluded to earlier. So how do you decide whether that feature goes into Beaker or makes its way back to PyTeal as a standard PyTeal feature?
I got part of that question. Is the question asking Beaker is shortening these PyTeal?
Yeah, because Beaker. So part of the Beaker code compiles down to PyTeal, right? Or is?
Yeah.
I can answer that question. So how do we make the decision of we put in a bunch of stuff that makes the smart contract writing easy and takes out a bunch of the code? Why is that in Beaker and not in PyTeal? That's basically the question. Yeah, so for right now, it all lives in Beaker. It's more of I'd say a playground, right? Things are going very rapidly there. We add lots of new features very quickly. I think over time, that decision and that's, I don't know why I'm holding these right now. That decision becomes like a much more front and center question of like, hey, what's the strategy here to move things between them? Is there some concept of like a standard lib in PyTeal? But for now, this is all about just like finding the problems, mowing them down, and providing a framework that just makes things very, very, very fast and very easy on PyTeal. Cool.
Great, and you're hearing that directly from Paul Regal, our Chief Product Officer, so thank you for jumping in. We got Ben Gudarelli right here as well, the lead developer, so, turn and face the camera so that everybody knows you. Yay, all right, awesome. All right, Chris Kim, thank you very much for this very informational introduction to what Beaker is. Awesome. Our next speaker is, one more round of applause for Chris. Come on, he was awesome. What a... Love it, love it. All right, our next speaker is Jay McCarthy. He's going to get himself set up. Jay is the is founder and CTO, Chief Technical Officer at Reach. Reach is an awesome language for building Algorand smart contracts. Actually, he's going to tell you a little bit about the fact that you could actually use the same. Yes, when in doubt. No, it's up. No, it's on. All right. No, there. Something is working. Welcome back, everybody. All right, we are so glad to have you here in the Developer Greenhouse today. Jay McCarthy, founder and Chief Technical Officer at Reach. Welcome to the Greenhouse. Take it away.
Thanks, Ryan. So today I'm going to be talking about how to build decentralized applications safely, or at least that's kind of what I'm going to be talking about. What I'm really going to be talking about is how to build them correctly. And what I mean by correctly is that before you build anything, the most important question that you should ask is whether you know what it is that you want to build. Because unless you know what you want to build, there's no way to know whether you built the correct thing. So the fundamental question that I'm going to be talking about over and over and over again here is, do you know what your dapp is supposed to do? So the way I'm going to approach this is to talk about something called model theory, and then I'll go through some examples of how to apply model theory, and at the end I'll talk about some of the tools that are available for applying these things. And successful, or maybe you won't be successful, but you won't be not successful. You won't lose your money from your application from doing this. I can't guarantee that you'll actually be profitable. So to start off with, what's model theory? The idea of model theory is there are things called theories, which are mathematical objects that describe the source of truth, the thing that is supposed to happen. And there are models, which are the actual behavior. So, for example, a theory is something like a specification that tells you, here's what I wanted to build, and the model is the actual program that you ended up building. At a very high level, every time you do anything, fitting a model, because you are actually doing something in the real world, but there was some earlier goal that you had. And model theory is about the connection between theories and models. Now, there are lots of examples of ways that we could think about defining the theory. So for example, there are explanations in prose. You can write, English documents that describe what your program is supposed to do. You can combine that with mathematical formulae that try to articulate exactly what the operations that you might do are. And most of the time when people talk about theories, this is kind of where they stop. They say theory is about specification. But I think that actually it's important to realize that a lot of things that normal software engineers do are part of building the theory. So for example, if you're building an auction application and you create spreadsheets that talk about what the correct formulas to use are, then that is really part of your theory, and you should consider it that way. Similarly, if you build like an example testing scenario about how you expect your program to be used, that counts as part of the theory. On the other hand, your model is more than just the actual program, because included in the model are the behaviors that your users ultimately take. Because you imagine when you're in theory world that they're going to do one thing, but in reality that they may do something different, and understanding the connection between those two things is important. So to summarize, there's this question of, what do you know what you want? Theory is when you talk about what you want. Model is what you actually built. So now, the main question of verification is, what is the connection between the theory and the model? And there's lots of different ways to approach answering this question. The most popular one that people do the most is testing. So the idea of testing is that you have a finite amount of execution of the model to see how it conforms to the theory. There are good things and bad things about this. One of the good things about it is that everyone knows how to do it. It's very fast and it's very easy to do. But a fundamental problem of it is that you can only do a finite amount of testing. And in other words, this means that you can only demonstrate that you did not find problems. You cannot demonstrate that you actually did the right thing. You only know that you did the right thing in the domain that you actually tested. A better way to do it is what I'm calling analysis. So the idea of analysis is that we take one aspect of the model, or maybe another way to think about it is one aspect of the theory, and we do an automatic and infinite analysis over that behavior. This might sound really complicated, but almost all engineers have used an analysis of some kind because they've used a type system. Most programming languages have type systems that make it so that you cannot add a number like 5 in a word like an, because adding 5 and an, although 5 ands would be wonderful, it doesn't actually make sense to add these two different kinds of data. And so a type system is a really simple example of an analysis that looks at one aspect of your program and verifies that it doesn't make any mistakes. Now, the good thing about analysis is that you need basically a PhD, and I'm putting PhD in quotation marks, to design the analysis, but you don't need the PhD there when you're using the analysis because it happens automatically. So it continues to be fast and automatic. Another thing that's a good thing about it is that you're using the actual model. This is something that's shared with the testing environment because you're really testing the actual model, not some abstraction of it. The downside, though, is that you are always going to get false negatives when you use analyses. And this is related to an important proof about the theory of mathematics that's called Gödel's incompleteness proof, which basically says that anytime you have a formal system that proves things, you can either prove things that are false, or there are things that are true which you can't prove. In other words, that means that anytime you do an analysis, there's going to be times when you make conservative approximations that say that there might be a mistake, but I don't really know. And the other thing that's kind of bad about analyses is that they typically can only do one aspect of your work. So to use them well, you have to use lots and lots of different analyses. And you should use more and more of them to handle all the different aspects of the theory that you care about. Now finally, the best approach to know the connection between your theory and your model is to do a proof. To do a proof essentially requires you to always have a PhD present watching you at all times. And in fact, probably the PhD is the one that's doing it. The thing that's really great about it is that this is infinite, and it covers all aspects of the connection between the theory and the model. And that means that it can be more accurate. I'm using accuracy in a non-technical sense because technically the false negative problem shows up here in the proof world as well. But typically the completeness is more thorough in the proof world than it is in the analysis world because it's more manual. And it's extremely slow to do this because it is a manual process. And so you would only do this for models that are very, very important. And in fact, it's not really feasible to do proofs about most models in general. And that's because most real model building tools, and remember, I'm using this kind of coded language. When I say model, like think a program, right? Most programming languages that you actually write programs in are totally infeasible to do any sort of proof about. There's no way that you're going to prove anything about a Python program. It's just not plausible. Even more simple languages like C, well, first of all, C is not a simple language. People think it's simple, but it's extremely not simple, are very difficult to do proofs about. So typically, when you're proving things, you're proving things about models that are further from reality. And so anyways, so it's important to understand that this is possible. I mean, it is totally possible to prove things about real software, And sometimes it's necessary to do so, especially when it's extremely important. This is one of the reasons why Algorand publishes proofs about all of their cryptographic systems, because we want to do the best thing for those high-value pieces of the infrastructure. So let's go through some examples of how you would use each one of those three tools, testing, analysis, and proof, to answer questions about the connection between theory and models. Now, one of the main questions is something that is referred to as soundness. So soundness means, does the model respect its own abstractions? The type system that I mentioned before about not adding numbers and strings is an example of soundness. So a question that you could ask is, are there type errors at runtime? So a type error at runtime is, does my program actually try to add 5 and a string together? So I'm not going to go into as great detail on every single one of these questions, but I'm going to choose this one and talk a lot about how this actually works. So a way to test this is to actually run your program on lots of different inputs and make sure that it never throws an exception actually doing this. If you use a programming language like Python, it does not have a type system built into it, so it's not going to check this property for you automatically. The only way to look at your Python program and answer this question would be to actually run it over and over and over again. People have tried to build versions of Python that do type checking, and these are called gradually typed Python. There's something called reticulated Python, which is a tool for type checking Python programs. Now, in the context of building a smart contract on Algorand, if you're going to use PyTeal, the thing that's nice about that is that you actually run your program, compiling your PyTeal program into a Teal program is running your Python program. So you actually don't care about there being type errors in the Python program, because you would see those automatically because the program. The thing about building something on PyTeal, though, is it produces a Teal program. And that Teal program is yet another program. And so we could ask, like, can there be type errors in Teal programs? And the answer is yes, there can. Because Teal programs could accidentally add numbers and strings together. Now, PyTeal can be implemented to do part of this checking, but also the Teal compiler itself, the Teal assembler, tries to do type checking on Teal programs. I say tries to do type checking because there are many circumstances where it gives up and it says, well, I don't know, I can't analyze this, so I'm not sure. I don't know if it really is type safe, and so it no longer analyzes it. So that means that when you compile a normal Teal program, you actually don't know whether or not there could be type errors at runtime. At runtime here means actually sending transactions to the contract. So this is a viable thing that you should be worried about. Other programming languages that target Teal and the AVM do have type systems. So for example, Reach has a type system, and so you cannot write type incorrect programs. However, we are a compiler, so there's this worry that maybe we produce type incorrect programs, so that we produce a program that would have this error. So because we're nervous about that, we've built an analysis, what we call the Teal analysis framework. And so the Teal analysis framework is a verification engine for Teal programs, and we have a more expensive and more refined type analysis for Teal programs that is sound and complete and guarantees that the Teal programs that we produce never have type errors. So if we just take one example of a kind of question you can ask about soundness, that's a way to think about the testing. You could send it a bunch of transactions, make sure they have no mistakes. You could do analysis, and the analysis that you do, you have two options. You can either make it sound, meaning that we'll never make a mistake, or you can make it incomplete, where sometimes it will give you advice and sometimes it won't. And so the actual Teal assembler is incomplete and unsound. So it will say that it has done the type analysis, but it can give the answer yes, no, and maybe. And when it says maybe, it still lets you run your program. Our analysis framework, when we also say yes, no, and maybe, but when it says maybe, we don't let you run your program. So that's an example of what to do about the false negatives that come out of analysis. Finally, it would be possible to do a proof about this property. to prove that a program really was type sound. In this case, though, it's not useful to think about doing a proof about that because we know that high-quality analyses exist, and proofs are always worse if they're expensive because the best analysis frameworks actually can produce proofs, and so we do that with TAF. Okay, so now we can ask I'm not going to go into as much detail as I said, but we can do the same kind of thinking about things like, are there arithmetic overflows in your program? That's an example of a soundness thing. Does it actually parse the arguments to your program correctly? Will it ever try to produce transactions which we know will be invalid and will be rejected by the network? And does it actually respect the real resource limits of the network? For example, one of the things that we know about boxes that were talked about in the last talk is that you can only use 8 box references per transaction. And so that means that if you looked at a program, a question you should ask is, does this program only use as many boxes as references are available? So TAF does that. So TAF analyzes the VM code that we produce and guarantees that we never exceed the resource bounds. And the normal Teal assembler makes no attempt to do this. All right, so that was soundness. Now let's talk about safety. So safety is the property of, does the theory, i.e. what is supposed to happen, contain the model? So that's a fancy way of using set theory to talk about the idea that, does the model do things that aren't allowed? Because if there's something that's in the model that's not in the theory, then that means that the model does something that's illegal. So an example, people generally explain this as, can bad things happen in the program? So you could ask the question, do we ever write the wrong data to disk or to storage? Do we ever make state transitions that we didn't think should happen? Do we ever lose funds? Because losing funds presumably is not in the theory. Or do we ever pay the person who's the wrong person to pay? These questions you can also think about testing, you can think about analysis, and you can think about proof. Another property, another way to think about the connection between models and theories is something called liveness. So this is, does the model contain the theory? So remember, the theory is what is allowed to happen. The model is what actually happens. So the question is, does what actually happened contain what is allowed to happen? If it didn't, then that would mean that there would be some good behaviors that are in the theory that are not inside of the actual behavior. So people generally refer to liveness as, do good things happen? Are the things that are supposed to happen in your program things that actually happen? So presumably, you want your program, when it runs, for the user to actually get paid. And so you can build a test case that makes sure that, okay, well, in this scenario, when we run the auction, Jay really gets his money. That's an example of a testing approach to this. An analysis approach to this would be to think about all possible state transitions and all possible evolutions of the network and make sure that from where you are now, there's a possible path to the good thing happening, no matter where you go. Because every system is an evolving state machine where, like I'm going to do a little physical acting now. So imagine that I'm the start of the program. And what the user can do is they can choose left or they can choose right. They can do one of those things, and then they can go right again, or left, or maybe over here they can only go forward. So there's this whole state machine of paths that I can get there. You can kind of think of it like a maze. At the start of the program, the user is at the start of the maze, and the question is, no matter what choice they make, will they always eventually get to something that's good? Actually, I guess it's kind of like an anti-maze, right? Because the point about a maze is that there's only one right way, but the goal of your program is to make an anti-maze, where no matter what path they take, they will always get to good behavior. So that is the analysis that you want to do when you're asking the question about whether good things happen. In this infinite behavior is the reason why testing is so difficult to verify liveness. Because all programs have basically infinite mazes, and so the only way to approach answering whether or not they have good behavior is to do analysis or proof. It's not really feasible to do testing. So other properties that you might care about is whether you can actually end your program. That's like a really basic liveness property. Okay. Now, another question that you should ask about your model and your theory is one that says, is your theory valid? And what I mean by here is, how does your theory relate to the actual subject matter? And this is kind of a way of thinking that the subject, the human thing in the real world that you care about, that's sort of like the real theory. And anything that you produced that you're calling the theory, it itself is a model of the real world phenomena. Because remember, when I say the word theory, we're talking about things like specifications and formal methods that describe what you want to happen. But programmer to do anything, one of the things that you'll find is that no matter what specification you wrote, they will make something that follows that specification, but does not solve what you care about. That is an example of an invalid theory, one that does not reflect the real world. And so mathematicians, part of our axioms of faith is something called the Church-Turing thesis. And the Church-Turing thesis essentially says, we declare that all our theories are valid. When you say the word computation, you're talking about a Turing machine. So therefore, anytime people think about computations, they must be thinking about our theory. And so people think that the Church-Turing thesis means something different, but that's what it means. It's a statement of faith that we are always right when we do analysis. And so, but this is something you should be very stressed out about, the validity of your specification. All right, let's apply these 4 different ways of thinking about what is worth checking between models and theories to the auction application that the workshops for the rest of the day will be going through. So let's start off by asking a really basic question about validity, about do you even want a dapp? So what we might want, so the premise of an auction application is that think eBay, but related to blockchain. So we have something that we care about buying. Everyone, I'm doing a performance right now. The clothes that people wore on famous performances are, hot topic items. So I will be auctioning off this shirt later today. Okay? So you too can have the opportunity of being part of Jay's talk at Decipher. So one way that we could do this is building a centralized application, or a CRAP. So a centralized application is a traditional one where all of the data is stored in a centralized place, and there's all sorts of advantages to centralized applications. They're extremely fast. They're very easy to build. It's easy to query them, easy to build servers, easy to build clients. They're very flexible because you can change them whenever you want. There's a reason why people love CRAP. Now, the thing is that there are 2 disadvantages to CRAP. They only trust it because of their being embedded in a legal system. Because if you dispute something that eBay does, the only recourse that you have is essentially to sue them or to hope that society will help you and shame eBay into doing what you want. The other problem with them is that they're closed, so we don't know whether or not they're really doing the things that we want. In other words, it's very difficult to trust the model of a CRAP because you can't see what it actually is. Now, the reason we're here, of course, because we love dapps, but it's worthwhile to point out that there is a point of using CRAPs in the blockchain world, because eBay would be better if you could buy things with algos, because then the payment mechanism would have all the advantages of using Algorand relative to using PayPal, which is the most common thing that people use on eBay right now. So I am, of course, a little bit of making fun of centralized applications, but it is worthwhile to build centralized applications that have a connection to blockchain. And it may be for your domain, it is worthwhile to auction off my t-shirt using an eBay, but where you pay with algos. It's feasible that this would be a good thing. Now, a dapp, of course, has advantages, but there are 2 kinds of dapps. There are what are traditionally called dapps, and a subset that I'm going to distinguish as DDApps, or protocols. The essential difference between these is that a dapp is one contract that has the behavior that you want, and the other one is a network of contracts that all speak a common language, doing the same common thing. So in the context of an auction, a dapp would be one contract that manages all auctions, and a protocol would be every auction is a different contract, and they all speak the same language. Right now, when you use a website like eBay, you're speaking to a dapp-style thing. You're speaking to one website. But when you use email, you're using a protocol because everybody has their own email server that they all speak the same language, but it makes it so that people can run their own. Now, there are pros and cons to these two things. They're both trusted by code rather than by law, which is an advantage. But in some ways, the dapp has disadvantages because the main things that are disadvantages about it are that, like all blockchain programs, they're slow. No matter how fast Algorand is, it's not as fast as AWS. When I say slow here, I'm comparing the Algorand world to AWS, not to Ethereum, where of course they're snails, and where we're not. AWS is a Ferrari, Algorand is a cheetah, and Ethereum is a snail. Okay, so in the world of animals, it's great to be the cheetah, but I want to drive a Ferrari. Okay. Now the thing though is that the dapp, in some ways, is more flexible because is less flexible because you can never change the contract once you launch it. You're stuck with that particular program. In the protocol, all you have to do is maintain the same interface. So every single auction can be a different program over time. So it means that ultimately it becomes more flexible. It's more open as well because you're going to have to build clients that work with any given instance of the protocol. But people can then make their own versions of it. So in the decentralized world, there's a strong predisposition to prefer protocols, but from an engineering perspective, people tend to build and want to build dapps. So when we're building our auction, we should think about this. I believe that all the auctions that you'll see later today are in that middle category, not the protocol. So let's think about how we would think about the theory and model for our auction. There's lots of things that go into the theory. There's things like, there's a Wikipedia article that explains English auctions versus non-English auctions versus this kind of auction versus that. Like, that is part of your theory. What is the auction mechanism that you're going to choose? You're going to write a PDF in English that's going to explain what the auction is supposed to do. You're going to have some formulas for figuring out the prices. You're going to have like a manual for testing your program. You're going to have a suite of tests for the contract. You're going to have tests for the client. You're going to have tests for the UI. All of these things are part of your theory, and you should build them all. Over on the model side, you're going to have your actual program. Your Reach program, your PyTeal program. But then you're also going to have the bytecode blob that gets produced by the assembler. That's the real thing that runs, not the Reach or PyTeal program, and that is part of the model. Those are some of the artifacts that matter. You're going to write a client library, presumably in JavaScript, and that becomes part of the attack surface of your program. Because if there's an error in the client library, the auction is still compromised. You're going to build a UI. You're going to use the Algorand SDK. You even have to think about whether or not the Algorand Go node implementation is correct. You're going to have to worry about whether the hardware that mainnet nodes are running on is compromised. It was mentioned in a panel that cryptographers don't sleep well at night. That's because when you really start thinking about all of the potential attack vectors for your program, it includes pretty much everything. And there's all sorts of mechanisms that are built into the design of decentralized networks to protect against a lot of these things on the bottom. So it's not worthwhile for you to think about these when you're thinking about your auction application, but that is kind of the point of blockchain, that all of those problems have already been solved, and you get to focus on only yours. But if you were designing an auction application that was decentralized from the start, and you had to do everything that blockchain provides for you automatically, you would never get off the ground. So let's think about soundness. So we want to ask the question like, do we really obey the ABI types? Do we have any type errors? These are the things that we talked about before. So I spent the most time before about this, but I want to highlight one, which is that does your client verify that the contract that it's talking to is actually the right bytecode? Because you could have a user interface that is talking to an application on mainnet that you don't check that is actually the right one. It has the same interface, but it's not using the right bytecode. There have been real attacks of real actual blockchain programs where the AWS site serving the client was compromised, and it just redirected people to a different contract, and they lost all their money because they used it. For safety, we want to ask questions like, does the contract end with an empty balance? Because we're going to have an auction, and we presumably want the funds to be given back to everybody. And if you end the program, then all the funds are stuck there forever. So that's a very important property to ask. When we think about liveness, questions are things like, do losers of the auction get their money back? That would be an example of something that we really want to make sure is in the program. We want to make sure that the winner really does get the asset. We want to make sure that the prices can be arbitrarily large, because we want to have the problem of people, risking billions to buy my shirt. Another example is, can the application index be this number? So the application index is a 64-bit number on the actual Algorand network, but the current SDKs in JavaScript do not accept this number. So right now there's a latent error in the Algorand SDK that if this number ever gets returned by the network, which it is possible to do, then all the SDKs will fail to actually run and deal with the program. The explanation for why we're okay with this error is that we know that the application ID is actually generated by the block number, and this block number will only occur in 2,000 years or something like that. So it's somebody else's problem. So we have from now until then, unless we change the application ID generation rules to deal with this problem. So the other question about validity is, did we even want to use auctions, and did we choose the right auction mechanism? In particular, is it good to use an auction mechanism that is attached to the blockchain? Because we know that all blockchain things are intrinsically public. And so do we want to know that, like Ryan, he's waiting to bid $100 on my shirt because he's just dying to get my shirt? And does he want his wife to know that? You know what I mean? These are the kinds of questions that you need to ask when you're thinking about actually building a real blockchain application. And this is one of the reasons why there's so much interest in things like snarks and homomorphic encryption and ways of having privacy-preserving applications on blockchain. Those are not questions about soundness, liveness, etc. Those are questions about validity. Can we build the things that we really want to build, that our users really need? We shouldn't just accept that it's always going to be right. So some of the available tools for doing this, I'm going to just point out 3 of them. So the first one is the Teal analysis framework. That's the thing that's built into Reach that does all sorts of soundness and safety analysis for your program every time it compiles. This really has nothing to do with Reach itself. It's just analyses on Teal programs. With Reach, all of these things are being checked. There's also SMT solvers, which is a really good tool for doing safety analysis. Essentially what SMT solvers do is they take a model of your program, which is a set of equations derived from the source code, in particular the Teal source code, and they check to make sure that the actual behavior is contained inside of the theory, and they can do it automatically. Another tool that's very valuable is something called Alloy. So Alloy is a model checker. What it does is it's really optimized for doing the other thing, the liveness property checking. Because what it can do is you can describe the state transitions of your program, and it performs that creates an infinite state space, and you can ask questions about where it goes along there. Another tool that's popular in this world is not Alloy, but the K framework. So if you've ever heard of the K framework, which is one of the tools that runtime verification uses, this is what it does. So this is what I wanted to talk about today. Do you know what you actually want, and how can you check to make sure that what you built actually is what you want? This is the fundamental question you should be asking when you're worried about building a program correctly. And once you start teasing apart what it really is that you want, and saying, I want this, did I really do that? I want this, did I really do that? That is what it means to build something correctly. And there are all sorts of mathematical and software tools that can help you answer that question. And there are all sorts of people in the Algorand community that would love to help you answer this question for you. Thank you so much for your time.
Jay McCarthy, everyone. Thank you so much, Jay. I always enjoy listening to your talks because you break down complex things in a simple way. And I think what not to discount what you said because it was all fantastic, but clearly I broke it down as ants are great and Fox doesn't fit in your shirt. No. Everybody, give it up one more time for Jay McCarthy. Later on this afternoon, we are going to see JP Miller come up and build that auction dapp that Jay referenced there using the Reach language, as well as Joel Polney is going to build that auction dapp using the Beaker framework and PyTeal. But before that, we are going to have some lunch being served. Okay, all right. All right, so we've got, yes, lunch is being served, so please fill your bellies with all the wonderful good food that they're having. And then do make your way back here in 10 minutes' time, because we are going to kick off with a scale pitch competition. I can't wait for that. Everybody, come on back to the greenhouse in just 10 minutes' time. All right. Uh-oh. We need judges. Okay, I can go off.
Hello, everybody. Could I ask that our 4 lovely judges please come and join us at the front? We will be commencing our scale pitch competition shortly. It's going to be rapid fire. We got 10 great projects to see. They'll each have 3 minutes to pitch and 2 minutes of Q&A, and then on to the next one. Our 4 lovely judges, please join us at the front here. Thank you. Sorry, one last call. Is Melanie Moore, please, in the room? Melanie, if you could please come and join us. Thank you, up the front. Melanie.
Ladies and gentlemen, this is the most important and funnest event of this entire Decipher. Are people talking in the back row there? Jay. Jay.
Thank you, Stacy.
I'm going to start over. Okay, I'm so excited for this, and I could not be here yesterday, and all I heard yesterday afternoon was what a loser I am for missing this, because I guess it was amazing. How many people were here? How many people today were here yesterday as well? Okay, all right, okay. So this is the scale day, ladies and gentlemen. It's all about scale, and we have 10 teams, right? Is it? 10 teams competing, and 1 winner and 1 runner-up. I was not asked to be a judge, which I'm very unhappy about, but we have our illustrious judges right here in the front row. They have their bank account, their wallets, right? Right in front of them. No, just kidding. Okay, and the only thing I want to say besides welcome and how excited I am about it is that I'm doing the last panel today, and we are going to announce the winners and the runner-ups. Yeah, the winners and the runner-ups of both days at the very end. So you will be the very kind of last things that come out of my mouth to close Decipher, which I think is kind of cool. So with no further ado, I hand this over to Joe.
I've got it. Thanks. Cool. Thanks. Thanks, Stacey.
Thank you, Stacey.
Okay. So this has been a complete roller coaster. It's been amazing. We were blown away by all the projects submitting to participate in the Scale Pitch Competition. So the Scale Pitch Competition is targeting viable seed stage companies who've either gone through an accelerator or their projects in the ecosystem that are looking for funding. The 4 judges, so we have Ryan T., Head of Ecosystem Funding at the Foundation, AJ Milne from Optio Capital, and Melanie Moore, welcome, founder and CEO of One Protocol. And thank you so much. So just the pitches are going to be 3 minutes. It's going to be really quick. There's 2 minutes of questioning. I do want to highlight that there are accelerator leads in the room. If you want to just stand up really quickly, Lorenzo from the Rocker Accelerator. So these are like targeting projects kind of yesterday from the Bill that want to go into accelerators. It's good to know you're in the room. There's Michael Hofweller. Is he in the room? Hi, he's over there. From Axel. Axel Accelerator. They are closing their applications in January. So any startups in the room that want to participate in Accelerator, they're closing in January. And we have Asim. Is he from Eterna? Is he there in the room? I actually don't know if he's here. Okay, that's fine. Okay, so I'm going to kick it off. Our first project.
Oops, sorry, before we do,
Dave.
just a quick word to the contestants and to the audience to forgive me if I come across as rude. It is a strict 3 minutes, so I know Joe touched on it there. So you guys will have 3 minutes to pitch. With 30 seconds left, I'll make a noise like this. After 30 seconds, you got 2 minutes of Q&A, rapid fire for my judges, and then it's on to the next one. We got 10 pitches to fit in the next 60 minutes, so we got to keep it ticking over. Best of luck to everybody, and thank you.
Yes.
Joe.
And the other thing as well is clap and roar for the projects that you like. You know, it's just really nice for them because it's hard to come up and pitch. So, yay! Okay, great. And the first pitcher is Sarabi from Dignify. Dignify is a DeFi platform to connect digital asset liquidity to SMBs. Okay, welcome, Sarabi.
Hi, everyone. You can all hear me? Great. Thank you so much. My name is Surabhi, and I'm co-founder of Dignify. Dignify is a DeFi platform to connect digital asset liquidity to SMB-focused credit fintechs. Team Dignify, we have dedicated our careers to solve innovatively for small and medium businesses. I'm a structured finance and MSME credit specialist. I have built close to $1.5 billion book in emerging markets in this space. And this is my second startup in SME credit space. My co-founder Nishant, who has also solved for the SMB ecosystem, but more from product and technology point of view. $5 trillion access to credit gap for SMEs exists because lender to the SMB ecosystem, like shadow lenders and credit fintechs, themselves struggle to raise liquidity. And the reasons are, banking liquidity goes to large industries only. Number 2, bond markets are nascent and underdeveloped. Number 3, opacity of the TradFi world. Oops. Yeah, sorry. Meanwhile, in the Web3 world, stablecoin liquidity has grown 30 times in last 2 years. However, yields have been highly volatile. Digital asset liquidity is currently seeking competitive and stable yields, diversification, and real-world impact. Web3 rails allow us to build global credit markets on chain because global liquidity is accessible, tokenization, which solves for fractional ownership and liquidity, and on-chain immutability, which allows us to build credit primitives on chain. This is a protocol schematic. Borrowers, reputed lenders can borrow from the protocol. Liquidity providers invest into a diversified pool of opportunities, and governance is managed by a DAO made up of credit experts and lending experts. Looking at the massive opportunity, few DeFi RWA protocols have emerged in last 1.5 years. We believe that early stage focus, which is required to scale such an offering, seems to be missing. Focus on an end borrower, focus on a specific geography, and also focus on skin in the game by the protocol and risk management. Therefore, Dignify's moats are built around these 3 things. Number one, we are sharply focused on SMB-focused credit fintechs only for our GTM. Borrower geography is going to be emerging market, but again, SEA is our target market. We are providing first loss of 10% to early liquidity providers, which is augmented by 110% collateral provided by borrowers, tokenized and registered on-chain. Our journey, our MVP is there on the testnet. We have a team, and we have also put together a strong borrower pipeline of $50 million. Next step for us is do a fundraise, go for audits, and do a mainnet launch. Thank you so much.
Thank you very much. Okay, questions from our judges.
Thank you very much. Very well done, very well presented. You mentioned that you have a target, a pipeline already of 50 million. Have you executed on the platform any transactions just yet?
No, so we are on testnet at this point of time. Protocol is not live yet. We have to go for security audits, and also then we can start and do a GTM. So we are pre-launch to that extent, but we have done all the groundwork for this to be made possible.
Do your credit underwriting standards have a sort of expected default rate for these loan pools?
Oh yeah,
Default rate.
expected default rate, I'm sorry. So for the target market that we are accessing, which is credit institutions in emerging market, this defaults actually in last decade is less than 1%. And there is a registered data given by Bank of International Settlement. It's a published data, less than 1% default rate.
Are you focused on a special market to go to market now?
GTM, right? You are
Regional market, yes.
yeah, so this is, GTM is in Southeast Asia. Indonesia and Singapore, to be very specific. That's our GTM.
Thank you for the presentation. What do you see as the key risk in terms of the next 24 months growing the business? Key risk? Thank you.
Key hits? Oh, yeah, sure, key risk. So key risk would be, for example, for us, if we were to go live, our approach is to build it in a progressively once we achieve product market fit. So the risk is if we are not able to decentralize it, that would be one of the biggest risks. Very strong risk management system in place for a protocol like ours. That would be a risk.
That's great. Thank you very much. Round of applause, please.
Thank you so much.
Thanks, Sarabi. You can give that thing. So Sarabi has pitched a few times, and always kind of in the back kind of chat, you can hear everyone always writes, I want whatever she's selling. So she's a great pitcher. So thanks a million, Sarabi. Our second pitcher for today is Decipher. It's Alejandro Gutierrez, and Decipher is bridging traditional finance into DeFi. So give Alessandro a big, warm welcome.
Hey everybody, my name is Alejandro Gutierrez. I'm the co-founder of Decipher, and I'm telling you how Decipher is bridging traditional finance into the DeFi space. So, after COVID, liquidity is starting to get constrained for many businesses and for many industries. And the reason behind this is because traditional finance has a huge issue on deploying capital towards loans, especially for SMEs and for developing countries, right? So what this tells us is that traditional finance is realistically not supporting economic growth, right? Good example of this is trade finance. Trade finance has a deficit of $1.7 trillion at the moment, and is expected to grow between $3 and $5 trillion fairly soon. On the flip side, actually, we are seeing a huge appetite for yield generation generated products that are not solely related to digital assets in the DeFi space. And the idea behind this is because investors, they want to diversify their portfolios, but also they want to just regain some confidence in the market. So, based on, or after seeing these problems and based on our expertise providing supply chain finance services in the DeFi space for the last years, we came with a concept of tokenizing real-world assets in the DeFi space. And the reason behind this is two. The first one, we are trying to provide alternative sources of liquidity for supply chain finance companies in order they can just pass that fresh liquidity into SMEs and into as well developing countries, right? And the idea is that this platform is allowing them as well to just have some financial innovation in order to just make the financial system a little bit more inclusive. The second part is stability in the DeFi space. As you know, it's extremely convoluted at the moment, and if we bring in real-world assets into the DeFi, what we are trying to do is trying to bring non-correlated assets that are going to make everything a little bit more stable, but also cutting over leveraging. That is one of the issues that we have at the moment. We believe that this is one of the largest opportunities that we have seen in the financial market in long time. We're talking a $7 trillion opportunity here, and we believe that we can cap probably $5 billion out of the global lending market within the next 3 to 5 years. Competitors, the real-world asset space is extremely small and new. It's more a competition. We're working with most of the biggest players in the space, but it's good to mention that we have been the first ones bringing this type of approach into the Algorand ecosystem, and we're working with the likes of Agro Token already. Team, we have a well-rounded team, tons of experience in the TradFi space, but also we have been one of the first movers in the real-world asset lending space in DeFi, so that gives us a huge competitive advantage compared to some other teams. Finally, I think DeFi is set to be the new foundation for financial infrastructure. And real-world assets actually are going to help us just to clean up the act in the crypto space and create solutions actually for the real world, right? As it's impossible to keeping with unsustainable yield chasing. So what we want to ask you guys is to join us in this road to create a more inclusive financial system that is built in DeFi, and we can avoid the scams of the future. Thank you very much.
Thank you, Alejandro. Thank you. Thank you.
Come back, come back.
Far out. Forgot, sorry guys.
Well done, first of all.
Thank you.
Again, the question of traction, of actual traction, live traction, do you have any right now?
Yeah. So we have done through pools that are not ours at the moment, we have done $7.5 million. With our own pools, we have put $1.5 million so far in capital deployed. All this has been going through factoring and trade finance at the moment. All on chain.
In event of default, is there any sort of legal mechanism for you guys to take claim of these real-world assets?
So again, sorry.
In event of default, so somebody's borrowing cash, right? You're tokenizing the real-world asset.
Yep.
That's collateral. What happens if a borrower defaults?
So we have actually a financial structure that is an SPV. All the assets actually are going there. So if there are any default, then you go and liquidate these assets, right? Yeah, it's in a traditional way, but the idea is that we are preparing for when NFTs actually are going to be able to be taken to court, and then you can just prove that you are the rightful owner with them. What is that going to be? I don't know, but that's what we are going to prepare towards, right?
Liquidators are getting a lot of practice right now, so we'll see.
Yeah, we will see.
It's also a question that is asked here, why Algorand?
Why Algorand? Well, I think we have an approach that we want to be in as many chains as possible, and there is interesting that is one, credibility from the tech perspective, but also it gives you a more traditional focus from the chain, right? And we want to be just surrounded by companies that have that similar approach. As you can see, we're a fairly traditional play in DeFi, so we need that.
What sort of help do you and the team need? What sort of help do you need?
Liquidity. I think it's one of the biggest ones, right? Especially where we are with the current market conditions. And it's a huge education that needs to be put in forward for this, right? We need to educate more traditional people to come, to start tapping. We believe that it's a huge opportunity there because they are fairly familiarized with this type of products. So people know pretty well supply chain finance, inventory finance, factoring, and that probably can be a good segue to bring more traditional people to invest in this type of solutions.
Decipher, ladies and gentlemen, thank you very much.
Thank you.
Thank you. Thanks, Alejandro. Coming all the way from Ireland. Woohoo! Okay. So our next pitcher is Philip Garbado from DFlex. DFlex is an exchange infrastructure for optimized DeFi trading. So welcome, Philip.
Hello, everyone. All right, so DFlex is the Algorand liquidity ocean. So many Algorand dApps require asset exchange services. However, the Algorand trading ecosystem is very fragmented. There's several different options for providing liquidity. There's 4 major AMMs, 2 major order books, and several other DEXs in development. This liquidity higher prices for clients on any single exchange. The solution is DFlex. DFlex is exchange infrastructure for best-in-class DeFi trading, leveraging Algorand's renowned efficiency by combining and optimizing liquidity routes across existing DEXs. DFlex offers 2 products, a routing protocol for slippage-optimized market orders, and a limit order protocol for on-chain limit orders. DFlex is developed by the founders of DFly and myself, Phil Gabardo, the founder of Alamex. DFlex is the conjunction of DFly and Alamex. So the routing protocol and the limit order protocol are implemented on-chain as Algorand smart contracts, but both protocols have off-chain components as well, including APIs and SDKs, to simplify the integration process for dApps. The routing protocol finds the optimal liquidity route between any 2 tokens, using a combination of multi-hop and split swaps, leveraging all available liquidity in the ecosystem. The limit order protocol allows users to place limit orders on-chain, which can be filled using any liquidity in the ecosystem. Both protocols are composable, can leverage each other. So the routing protocol can leverage the liquidity from the limit order protocol to optimize swaps, and the limit order protocol can leverage the routing protocol to optimally fill orders. DFlex charges a 4 basis point transaction fee for swaps through either protocol. Half of the fee goes towards the DFlex treasury, and the other half goes towards the referring dApp. So DFlex has completed implementation of the routing protocol and the limit order protocol, as well as the APIs and SDKs to accelerate adoption by dApps. Both protocols have been audited by Vantage Point with no vulnerabilities found. The next step is adding limit order liquidity into the order routing, which should be done in Q1 of 2023. Over the past 30 days, DFlex has partnered with 8 different dApps to provide asset trading services and has processed over $2.5 million of transaction volume through 520 unique wallets from a total of 5,400 swaps, resulting in $300 of revenue. Thank you.
Thank you, Phil. And over to our judges. Anyone?
Well done, straight to the point, clear value proposition, simple solution. I have nothing but good things to say. Well done. There's one question though. Obviously, we're biased towards Algorand right now. This is an Algorand conference. Does this scale to other chains, or is this an Algorand-specific solution?
Yeah, so a lot of the infrastructure that we've built is kind of chain agnostic, but there are some components that are definitely coupled to Algorand. So for example, our routing contract is written in Teal. It's very Algorand specific, and it relies on some technical requirements that only Algorand has. So for example, composability, contract-to-contract calls, and several other kind of nuanced things.
Yeah, great presentation, mate. The joining 2 businesses, so DFly and Alamex, are both teams coming together, or what's the structure of the actual team?
Yeah, so both teams are kind of joining up to develop DFlex, the underlying protocols, but we're maintaining both of our individual products. So both Alamex and DFly will continue to exist, but they will both leverage DFlex protocols to power trading.
Is there a sweet spot in terms of trade size that you've seen that kind of mitigates the slippage that you would have if you were to go to an individual AMM by using DFlex?
Yeah, I would say anything over $1,000, you tend to get sizable gains by leveraging DFlex over a single AMM, on the order of more than $1.
Can you tell us more about the competitive landscape?
Right now, there's no other competitors that are providing these kinds of services.
And how big is the team?
The team consists of myself and the 4 founders of DFly, but we also have a community around us that's able to help with things like marketing and sales and partnerships.
Well done.
Thank you.
Thank you.
Thank you.
Thanks, Phil. Give it up for DFlex. Okay, so now we have a troublemaker coming to the stage. This is Adam Hoffman from Nimble Insurance. Nimble Insurance is a decentralized insurance marketplace. Okay, so welcome. Give him a big warm welcome.
Thanks, Joe. Hey, everyone. I'm Adam, co-founder of Nimble. We're insurance, so you all know probably what insurance is. So I figured I'd quickly just kind of hustle through here. So the fast version of insurance. Insurance used to be super simple. Chinese merchants would split up their goods and cargo among different ships. So if one ship went down, not one business went out of business, right? That's pretty simple. And then from there, some wealthy people said, hey, let's get in on that action. And they said, we'll cover your risk and we'll share in that. And from there, insurance companies popped up and said, we'll take that straight to the bank and then we'll make an absolute mess out of it. So from there, that's what they did. They made a mess out of it. So regulators came in, and as we know, the rest of it is super linear and easy and so easy to understand, and we all love insurance. Not true, but this is what insurance looks like today. An absolute just cluster, right? So it's a $6 trillion industry. Carriers are making tons of money on 3 to 4% returns, but the insureds are paying the premium for that. It's wildly confusing. There's high barriers to entry from the regulation side and the tech side, and that's led to something that didn't show up on my slide, but it's led to wild numbers of unhappy customers. So it led us to rethink what insurance is. So we want to build an insurance world that works for everyone, and this is how it works. Leveraging Algorand's technology and blockchain technology, any insured asset is a risk pool. Decentralized underwriters, actuaries, we can dig into that some other time about what they do, but they're the insurance professionals who make sure insurance works. They're going to determine the rates and the structure. From there, all of that is set up. LPs can fund on top of that, and an allocation of all of that goes to what's called the Nimble Common Reserve. The reason we do that is, if you zoom out, here's all these risk pools all contributing to the common reserve. So you're creating a system where each risk pool is independent, but they're all helping to make sure they all remain solvent. And we have to do that in a secure way. So expected claims for a risk pool is those claims are paid by premium, which gives the LPs some cushion to know that they're not putting all their money on the line. And then it goes up layers to traditional reinsurance, to get to a point where the total insured TVL is fully protected along that 30-second click line. So, and what do we do to make sure it's equitable? The more people in the Nimble community, the more revenue. That incentivizes growth and behavior. Insurers can get cash back if the premiums, if the claims are lower. And as the community grows, expenses stabilize, which continues to support that model. And I just made it under the buzzer.
Fantastic. Thank you very much. Nicely done. Over to our judges.
Great presentation. First question, did you do those animations yourself?
I did do those animations last night. That's why the slides were late.
Oh, impressive. Okay, very good. And what type of catastrophic events does Nimble Insurance cover?
Yeah, so what we're doing now is we're working with our 15 project partners on Algorand to provide coverage for smart contract vulnerability and smart contract hack. But those same smart contracts that we use to make sure that process works is scalable to really any insurance asset. So we're having conversations with real world companies like cell phone insurance, insurance for mobile devices, and other use cases like that. But right now, we're focused on our project partners on Algorand.
Seeing the team here now, can you give a little bit of background to some key team members?
Oh yeah, for sure. So I spent 22 years in the insurance industry, so that's my background, and you can all say Sonic is the tech co-founder. Annalie she spent time in crypto in the partnership sector. Everybody comes with a certain skill set, but we're making sure that everybody's also a builder. We want to make sure that we can break things comfortably and then fix them again, and also be able to connect the dots. Insurance, crypto, it's a hard it's hard to work together in that, so we just make sure, I could go down everyone and say great things about them, but I only have 20 seconds.
Adam, great presentation, mate, and great team. What's the key risk for you?
Yeah, I think the biggest challenge for us is in regulation, because insurance regulation is tricky. We are getting a full insurance license through Bermuda, which solves that, but we want to be a part of that conversation ongoing, so that's always a challenge.
Yeah, just on traction and real-world traction.
Yeah. So traction right now is the DeFi asset projects. We have 15 of them that represent about 150 million in TVL. And then from there, we would be rolling out, and I can't really, hopefully the traction's great in the real world, but right now we're focused on that DeFi assets.
Nimble, ladies and gentlemen, thank you very much.
Thank you, thank you.
Thanks. Thanks, Adam. Thank you. Okay, so we have Cometa up next. Cometa is single-sided liquidity lending. Cometa actually just finished one of our accelerators, the Rocker Accelerator. Give a wave, Lorenzo, over there, accelerator lead and partner at Rocker. So I just want to welcome to the stage Daria.
Hello everyone, I'm Daria and I present you the Cometa, a single-sided liquidity lending protocol. In future, everything will be tokenized, but to make it happen, we need one more significant element, and this is liquidity. But currently, liquidity attraction is too expensive and complicated. Imagine that you're a project that just launched a token, and now you need liquidity, but you don't have cash. What are you going to do? You can get a loan, but in most cases, lending platforms do not accept your tokens as collateral. You can use liquidity mining, but you have to give your tokens for free, and you have to pay in advance to cover impairment loss risk in user rewards. As a result, you waste around 30% of the tokens. To bring DeFi to the next level of stability and to help the Algorand ecosystem grow, we have to find a new way to attract liquidity and users. And this is the Cometa, a single-sided liquidity lending. Cometa allows projects to attract low-cost and sustainable liquidity and gives liquidity providers double trading fees and impairment loss protection. Sounds like a magic, right? But let's see how it works. Liquidity providers provide cash, and projects provide token. We put it together to the DEX, and as outcome, we have trading and impairment loss. Trading fees come directly to liquidity providers, and project has to cover the impairment loss. Cometa is extremely capital efficient for projects, just in theory, because we validated our approach using historical data. Also, we did a dozen interviews with projects, and 90% of them want to try the Cometa. For liquidity providers, Cometa is a great balance between profits and risks. Single-sided liquidity market is rapidly growing. It has the potential to become the core DeFi primitive. And we are not alone who wants to bring DeFi to the next level of stability, and we believe that single-sided liquidity is a game changer. On Algorand, we match algos with project tokens and brings Algorand sustainable liquidity. Our deep tech background helps us to provide easy-to-use but not easy-to-build solutions. Our advisors have massive experience in crypto and DeFi. Last 3 months, we get more than 30 partnerships. We grew our TVL to $300,000, and we have an excellent engagement with Twitter and other platforms. We're supported by the top investors, and this is the Cometa. Let's build the future of DeFi together.
Thank you, Daria. Very good. Over to our judges.
Thank you, Daria. Why Algorand?
It's a great question. We choose Algorand first from the technical perspective because we believe that it's secure and fast enough for the DeFi, the future of DeFi. But now we also realized that we can help Algorand with liquidity. We don't want to waste algos. We don't want to waste tokens. We want to merge them together and like double liquidity next year in Algorand.
Daria, very well done. I think it was a great presentation, and I have to commend you on your shoes. They're absolutely. Now,
thank you.
Now, in all seriousness, you mentioned that 90% of the projects that you've spoken to actually buy into that. How do you see this translating for you, let's say, in the next 12 months in revenue for the company?
Great question. So we talk with around 40 projects in Algorand. It's almost all projects that we have. A lot of them want to try. I would say 30% of them have sustainable tokenomics for us, healthy tokenomics. And our estimation, if the market will be the same, at least as now, we can reach around maybe 5 million TVL by the end of next year. But it's, you know, it's kind of optimistic, realistic way. We need support foundation and so on, and then we can make it.
Love the logo as well. Good name.
Thank you.
I was wondering about how the projects go about covering the impermanent loss. Like which like token is that covered in? How do they pay it back to the liquidity provider?
Could you just repeat again?
Yeah, so how does the project cover the impermanent loss for the liquidity provider, like the mechanics?
How they cover, how we manage it. Yes. So projects need liquidity. They are ready to pay for it, right? And they have to cover the impermanent loss. Based on our statistic, if the token price drops less than twice, that's huge, then it's much cheaper just to use liquidity mining. So basically, you just pay for it. But if they don't pay, we just sell tokens at the collateral auction, like MakerDAO, I think, does. So it's kind of lending. Yeah. But we have a great article from my team about that, the huge one about how we work it. Please check it.
I just wanted to know, how are you funded so far?
Funding. Right? So we have Cogitant VC, it's outside Algorand, we just bring him. We have a big brain, our lovely biggest VC, and now we talk with Borderless to try to onboard him as a lead investor.
One final question. The vault, did you guys create this yourself, or did you use existing architecture for it? The vault, did you...
The vault?
Yes, did you create it yourself, or you used an existing vault architecture?
No, we invented our smart contract here as my deep tech team. We built a smart contract by ourselves. The whole infrastructure that we built is our own infrastructure.
Commented, ladies and gentlemen. Thank you very much.
Thanks, Daria. Okay, so pitch number 7 is Pollenize. Mars and Shirov will be pitching. Pollenize is the esports of innovation. So please give them a big warm welcome.
All right, let's do this. First of all, thank you to Joanna and the Foundation for having us. My name is Mars, this is Shirov. We're the co-founders of Pollenize, the esports of innovation. And we crowdsource creativity within communities and to solve real-world problems. And then we tokenize that intelligence into tradable assets. And that's all within the competitive dynamics of our game platform, which Shirov will show us in a moment. The inspiration for Pollenize was born from our history in the music industry as music performers and music producers. And we're really fascinated by how, as musicians, we're able to rapidly create valuable assets in the form of songs. And so we took that process of creativity, which we experienced, and we turned that initially into a board game. We developed those game dynamics for 3 years before porting that on-chain. We completed our first raise at the end of last year, and we've spent this year basically building Pollenize Digital so we can scale our vision globally, where people of all cultures can come together to create and collaborate on solutions to solve the world's biggest problems. So,
thank you, Mars. Very, very quick tour here, just to show you how we incubate ideas at scale and turn them into tangible value. This is our homepage. Players come through, and it all starts with mission control. Missions are challenges that are set by brands, they're set by NGOs, they can be social problems, they can be technical problems. We've been doing alpha here in the Algorand community with brands like Cometa, actually, and we've been running different challenges. You can see them here. I want to go into one of my favorites actually, that we ran about 2 months ago, just as a quick glimpse into Polynize. So this is one of our favorite subjects. Governance generates a lot of chatter, but we wanted to focus on solutions. Let's look at how could we improve governance. And we had about 50 or 100 players. And what you're seeing here is the game summary page, where people have come in and incubated their ideas to solve this problem. And each one of these cubes with a sphere inside is called a poly, and that is one person's idea to solve this problem. This is a digital incubator that you're seeing in front of you. Now, I don't have a lot of time, and I can't go through the process of how we train creative thinking and actually lead you through the process, but I can show you the result. Let me show you probably my favorite poly. Actually, the top scoring poly here, we've got leaderboards of the best ideas and the best innovators. Our top poly in this game, really amazing depth of thinking, 7 generations through the game of evolving this idea by one of our top players called Shaper of Entropy. And this is a very, very deep and detailed idea. He's even uploaded an algorithm for how you can do governance better. So we can love to talk to you more about all the other things in the platform, the competitive dynamics and so on, but I do want to just finish by saying we now want to take this out to the world, especially student communities. We've done it for 1,000 players here, and with your help, hopefully in the partnerships that we need to take this out, we can do that next year. Thank you very much.
Thank you, guys. Judges.
Thank you, guys. What's the revenue model for Polynize?
There's 3 revenue models that I'll just quickly mention here. Short-term, asset sales on the player side. We've already been doing that. That's avatars, in-game assets, boosts for the game, creds. These are all working well. Medium-term, there's an opportunities coming up around taking the product and turning it into productizing it for corporates, for example, who want to run this as an experience with their teams. That's one example there, universities and so on. Longer term, and the ultimate revenue model here is a scaled one. We've got royalties flowing back to creators for what they're creating. We've got asset sales and so on, and a platform clip, and essentially a royalty model is the long-term model there.
Well done on stage over there. I love your vibe, and I love the fact that we're looking at something that isn't driven by DeFi, just at its core. 2 questions. Why Algorand? And tell us more about the team, and thank you.
What was the second one, sorry? Team, yes. Currently, team sits at 6. Shurav's leading the tech team with Simon Hacho, they've been working together for 20 years. We have a lead designer in Manchester, head of community and head of marketing, so that's 6 at the moment. So we've really locked down to extend our runway through this cold and bitter winter. Why Algorand? I've had my eye on Algorand for years before we actually decided to go on there technically. And basically, our platform essentially is a Web 2 platform. So we needed technology sitting on the bottom of the stack there that just worked, and that we could do it, we could connect and go. So that's what's happened, and that's what we have.
Super cool. Love the leaderboard look too. Are these tokenized ideas patentable in any way, or is there sort of a legal framework you're thinking around monetization of these IPs, these concepts?
Yeah, this is a very, very good question, and a very common question, and one that's actually probably key to our scaling here is to essentially, I might give a slightly detailed answer to this because it's a deep question actually. There's a closed model of IP. It's called basically patents, and I've spent many years in software. In my opinion, it doesn't work. There's an open model, which is called open source software, which has no economics in it at all for creators. What we're essentially doing here is working towards what we believe will be a viable, not just us, but a third point in that triangle, and that's essentially to keep the flow of ideas open, because that's what creates creativity, but to reward creators using the kind of Web3 things that we can do, such as royalties. So that's why Web3, sorry.
How many users do you currently have, and how do you measure the...
We have 1,000 users, roughly, now. Yes, user acquisition is one of them. The growth of our assets, primarily these polys, so the actual activity in creating these polys, is another one. And there are various other measures that we'll be looking at in the next period. But basically, user acquisition. If you don't have great creators at the middle of this, then you're not creating value in the platform.
Pollenize, ladies and gentlemen. Thank you very much.
Give it up for Sharav and Mars. Thanks a million. You want to give the... great. So next up is Mark Farrington from Illustrated World Series. Mark's been in our ecosystem for a while, and on his last competition, they had 1.3 million attendees online viewing the Illustrated World Series. So Illustrated World Series is building an ecosystem for competitive creativity. So please give Mark a really warm welcome.
Hi, I'm Mark Farrington, founder of the Illustrated World Series. We're an esports tournament organizer, global events IP, and media and entertainment space, producing up to 4 events per year with a focus on art, on illustration, and competitive creativity. We began 5 years ago delivering IRL tournaments. The way it would work is artists would battle in 60-minute knockout bouts. To illustrate a recent news headline, they would have to have a grayscale palette and a single color of their choice. We'd have a judging panel and a social voting component that would decide who would win. COVID arrived, we moved online, instantly, a much larger audience. Attendance grew, with each event averaging over 500,000 unique views. Moving online, we realized our events, they anchored our brand, but more importantly, we discovered huge appetite among our base, wanting an opportunity to flex, be seen, showcase, and compete for themselves. So we aim to build an interface for artists so they can stream their skills, engage their communities, monetize their content year-round on their terms. This will build a new market for artists and provide UGC between our main event, building our base too. Once creators realize they can quickly earn money via our player versus player and play-to-earn gaming mechanics, we'll grow fast and will benefit from the network growth effect. Year-round engagement will double up as qualifiers for our main events, feeding talent through. Key product features which creators can toggle on and off include a click-to-commission button, we take a percentage. Pusu, put up or shut up, stake your NFTs to win. Vote your winner, join whitelist, buy now, gifting and request, we take a percentage. And instant bid live ad. You can advertise from $1. There's a 3-minute window to complete the bid. 75% of that revenue goes back to the creator. We take 25%, so you can advertise with $1, monetize with a fan. $1 and a fan is all you need to get started. Why blockchain? Creator control, secure, fast, awards are instantly transferred and traced. Gaming and blockchain, it's a natural fit. Why Algorand? Fast, affordable, green, scalable, zero forks, never down, great UX, everything we need. Our revenue models are largely built around our play-to-earn commissions, our ad revenues, RWS NFT drops, sponsorships, and brand activations. We also have a major APAC partner ready to pump our content out across terrestrial, cable, OTT, and fast channels, building our Asian market. These guys are already doing amazing things with Riot Games. Our team, George Howard there in the middle, the arts advisor for Algorand, Nelson Diaz on the end, doing great things with NFT, me, and our ask is 5 million seed raise for 15% of the equity in the company, 15% of our token, but most importantly, 250 grand for an MVP, which will take 12 weeks to build out, which can be paid through a safe agreement and offset against a latter stage investment. Let's go. Let's onboard the next 10 mil. Thank you.
Thank you, Mark. Over to our judges.
That was the best Why Algorand pitch I've ever heard in my life, especially with the flashing colors. Fantastic.
Oh, yeah.
Yep. So my question is, for the artists that are in this IWS, how do they currently monetize their works? Like, what's their main source of income?
Yeah, they advertise on Instagram, on Twitter, on TikTok. They stream on YouTube, on Twitch. They advertise their wares to agencies. They take commissions on board. They put on their bios saying, I'm currently available to work, all that sort of stuff. There's nothing really on the social scene that allows these artists to go on and monetize with $1 and a fan and start it from there with a kickback of 75%. You know, there's nowhere else that does that. So there is no, to answer your question, there's nowhere. Yeah.
Great presentation. A quick question around customer acquisition. What is your strategy from a customer acquisition perspective?
Yeah, sure. So we'll kind of slowly, I guess we'll migrate our fans from our social feeds, you know, from Instagram, from Twitch, from Twitter. We'll slowly get them across to our interface. We're also doing a partnership with Influence, who are a company who own billions and billions of reach of influence around the world. They're asking us to take some equity in our company in exchange for that to really pump our platform.
You had 5 million, you're raising 5 million.
Yeah.
What does that actually allow you to do, and how will you spend it?
Yeah, so that's to do with building out our ecosystem more widely. I want to build out the team. I need a team. You know, I've bootstrapped this with not a penny spent on marketing for the last, 4 years? I've self-funded it. It's bootstrapped. We've not taken any investment. We were lucky enough to get an Algorand Foundation grant, which helped. But basically, I need to build a team. I need to build out some infrastructure, so I'm not doing everything myself, and we can scale this so it's realistic as a kind of global business. You know, so largely it's spent on the team, the infrastructure, and the build-out.
Do you know Talent House and Elo?
Sorry?
Talent House and Elo, do you know these companies?
I don't think so, no.
They're a little bit, I would say, also in the space, but more Web 2 and also investing, and I think you should talk to them.
Talent House, okay, thank you.
Talent House and Elo. Yeah, it's under the roof of Talent House. It's in the UK.
Thank you.
Thank you very much. Very good.
Thank you, Mark. So all of the newcomers who've joined the room, the Developer Greenhouse recently, this is the Scale final pitch. This is for viable seed stage companies who've either participated in an accelerator or are currently looking for funding. So our next pitch is a pitch to us quite recently, and we had a look at it and we said, this is really interesting. It is called Meta Amazonia. Melissa will be pitching. Meta Amazonia is a metaverse for social and climate impact, and it's really fun. So hope you enjoy.
Thank you so much. As she said, Meta Amazonia is a metaverse for social and climate impact. We operate at the nexus of blockchain, sustainability, and Web3. But before I tell you more about Meta Amazonia, what we're doing and where we're headed, I have to tell you where we've been. So I'm going to tell you this story. Our story is that we have actually been operating in the Amazon rainforest for the last 15 years, protecting it. We actually own and operate 50,000 acres of Amazon rainforest. And we have reduced 2.5 million tons of CO2. Now, if you don't know how much 2.5 million tons of CO2 is, it is actually 2.5 million cars driving around the world once. There are 1,000 families that are currently living on our reserve, and we support them through SDG projects, and we have partnerships with top-tier universities like Cambridge, Imperial College, and UCLA. Now, in our reserve, you can see here the yellow areas. The yellow areas is our actual reserve in the Amazon rainforest as we speak. And what you can see here in the red is the deforestation rate in the surrounding areas, which is 25 times more than our reserve today. And this is what it looks like. It's beautiful. Don't you want to protect it? So where does tech come in? Where does Web3 come in? Well, Meta Amazonia is a photorealistic digital twin. We're building it on Unreal Engine. Whole host of both physical and digital utilities that allow people to immerse themselves and get involved in our fight against climate change. We have a whole host of revenue streams, our core ones being our non-timber products, acai berries, Brazil nuts, etc., and our verified carbon credit program that's been in operation for the last 13 years. But with MetaMazonia, what we will be able to do is to introduce new revenue streams like NFTs, in-metaverse sales, and fees collected on the secondary market. Now, for us, 50 million acres, it's not enough. Our intent is to get to 5 million acres of protected land. That is the size of Switzerland. And we believe that blockchain is absolutely critical to do that because it allows us to be more transparent. It gives us the opportunity to crowdfund, and it gives people the opportunity to be able to immerse themselves in our world. Our land, every NFT plot that is sold in MetaMazonia comes with underlying economic rights associated with carbon credits and non-timber products. And we believe that Algorand is absolutely the perfect fit. Beyond the transaction speeds, for us, Algorand is a blockchain for social impact, and that's exactly what we show up. That's what we're doing. So we feel there's amazing value alignment here. So far where we are, we're at phase 1. We've built a demo. It's fully immersive. You today can go. In order for us to scale, we need support. We need both technical and financial support to be able to do that, to introduce new utilities, to be able to introduce multiplayer, to be able to host events. Now we have a great team, very thankful to be amongst incredible people. We have some fantastic partners, and you probably want to see it, so let's show it to you. So as you can see, we've used GIS data, we've used LiDAR scanning, we've used drones, and we've actually recreated, this is a village on our reserve today.
Thank you very much, Melissa. Thanks. Questions from our judges, please.
Really great presentation. Just in terms of traction, you mentioned that you need help from a technical perspective. Can you double click on that and do you have a clear roadmap in terms of what you plan to achieve in the short term?
Yes, absolutely. We want to be able to introduce we want to be able to introduce multiplayer gameplay because that will allow us to introduce all utilities such as being able to host events, ecotourism, as well as how hosting classrooms and university classes within the metaverse. And we do have a very detailed roadmap. Very happy to share that with you later.
Melissa, thank you for the presentation. What's the demographic of your user?
At the demographic of our user, we really see the youngest generations being a key part of this. We're actively trying to target students. And we also intend to introduce gameplay so that we can also introduce the gaming community. Beyond that, we're also trying to strike up because what we want to be able to do is to provide them an opportunity to invest in the metaverse and to invest in Web3 in a way that also helps them.
Does an acre translate to like a number of carbon credits? Is there sort of a evaluation or formula there, or is that all?
Credits are that the methodology for that is as per Vero, which is the top international regulatory body in the world for carbon credits. So we have a contract with them for 32 years, and they come in and they audit the amount of carbon credits that are actually, so they audit the tons of carbon mitigated every year. That's how we know.
Do you have any revenue projections already? I know it's difficult because onboarding needs to come first.
So we do have some revenue projections, but we're currently just working on our tokenomics right now. I'm very, very happy to sit down with you and to take you through that all after this.
MetaMazonia, ladies and gentlemen. Thank you very much.
Thanks, Melissa. Okay, so just 2 more pitches to go in the scale final for a developer greenhouse pitch final. Just to give everyone context of like how did we get to the last 10 today. So we had loads of people applying. We had a semi-final on Monday, and they were such great sports. They all came on Monday. Every single one of them turned up. It was brilliant, and we got down to our final 10. So this has been a bit of a journey. So I'm very pleased to welcome Harsh. Harsh is building AlgoScan, a block explorer and analytics platform. So So please give them a warm welcome.
God, there's way too many people here. Hi, I'm Harsh, and I built AlgoScan. It's a blockchain explorer and analytics platform built on Algorand. So a little bit about me. I'm doing this for about 10 years now, and last year I quit my job to focus full-time on AlgoScan, and it's been amazing ever since. It's been what so here's the problem, right? Algorand is growing. I mean, we've seen consistent month-to-month growth across all metrics, including DeFi, NFTs, and Web2 businesses coming on board. This conference is actually a great example of that. I mean, look how many people were here last year versus this year. And this growth will only accelerate as we see different asset classes, new smart contracts, and a changing AVM protocol come online. With more developers, investors, and institutions entering the ecosystem, Algorand will have to scale to the needs of this growing community. And scaling Algorand comes in many forms. I mean, it involves analytical data feeds on core blockchain metrics, asset monitoring tools for developers and institutions, better systems for smart contract parsing, on-chain analysis tools for wallets, assets, and transactions, and risk management systems, allowing users and investors to do better due diligence. I want to see where the money is going, what wallets it's coming from, and what apps it's involved in. This is where AlgoScan comes in. It's a blockchain explorer and analytics, an all-in-one analytics platform, building tools that make on-chain data accessible to everyone, not just the developers. And it involves a suite of robust tools. So we have AlgoScan, which is a general block explorer and open analytics platform, and then AlgoScan Pro, a premium analytics dashboard with enriched data feeds providing access to key blockchain metrics. And this is AlgoScan's network effect. As Algorand grows, so will AlgoScan. Developers need better analytical tools for their ecosystem. Investors, both retail and institutional, need monitoring platforms for their investments. Users want fast access to enriched on-chain data with an emphasis on transparency. AlgoScan will help Algorand scale for everyone. Now, the market. I mean, we're already familiar with Algo Explorer. It's the #1 explorer on Algorand. AlgoScan actually stands at #2. We do better across all metrics, and we're the topmost SEO-ranked explorer on Algorand. Then we have Goalseeker, which has a little bit of a buggy, Algorand support, and dapp, which is primarily meant for sandbox developers. In terms of the analytics side, there are currently no platforms that are exclusive to Algorand. So let's take a look at across the pond at Ethereum. We have Dune, The Graph, Infura, Flipside, Nansen, and Alchemy. All of these do millions or billions in queries and hundreds and thousands of users, and offer or generate revenue in the 5 to 6 or 6 to 7 figure range monthly. Speaking of revenue, as the second largest block explorer in Algorand, averaging 1,000 plus daily active users, with AlgoScan V1, and with V2 already released, we expect to have increased analytics and a revamped UI. AlgoScan is uniquely positioned to offer premium analytical tools to Algorand through a series of robust APIs and data-enriched dashboards. Check us out at algoscan.app, please.
Thank you very much. Over to our judges.
Thanks for the presentation. Your service.
Sure. So if, looking across the pond at Ethereum, it's clear that both users, investors, everyone really wants sort of these data-enriched feeds, right? We just don't want to look at transactions. We want to see deep analytics about where wallets or where the money is coming from, where is it going, what tokens, what contracts, what different asset classes involved in. And the idea is that users are willing to pay for that transparency, and investors and institutions even more so. So that's where sort of our revenue model comes in, which is the idea that if we offer these premium APIs and premium dashboards and enriched data sets, the users will come and pay.
My question is actually a follow-up. If you're on stage next year at Decipher, what does AlgoScan look like?
It is it's the #1 explorer on Algorand. That's where it starts. And, we're already onboarding tons of users to our premium products and giving them access to full transparency on chain without, the necessarily expertise of, having to decipher all these different items.
Good zinger there. What's your monthly overhead cost to maintain all these guys, et cetera?
Yeah, so I'm doing this out of pocket, right now, but it's about $3 based on traffic. I think with the launch of V2, we're expected to almost instantly. And so it'll be sort of on the upper side, near 5,000. Yeah. Oh, of course. There's fixed cost or cloud data storage or fixed costs, and so they only increase as the blockchain really increases, right? But like querying that data is like sort of like this one-time cost, and then we scale with our users.
What kind of marketing do you do? How do you reach now the new customers?
It's a good question. I haven't done any marketing. Most of the stuff that we've done with AlgoScan has been sort of just native growth, me just talking to projects and different people and going, hey, look, check this out, tell me what you think. And people have been really responsive to that, yeah.
AlgoScan, ladies and gentlemen, thank you very much.
You.
Hart. Thanks a million, Hart. Okay, so we are on our final pitch for today. This is dapps. And Mohit is going to be presenting. Mohit came from Algorand. Do you want to give a big wave there? Anil as well. Algorand, all the Indian efforts, it's been really, really great. Some really strong teams we're seeing coming from India. We've also had a lot of people asking about pitching their companies, and they're like, we want to pitch. So we are going to be rolling pitching competitions out through our Hack Shacks globally in 2023. So keep an eye on the website for the locations, which will be going up very shortly. So please give Mohit a big warm welcome.
Hi, everyone. So one of the greatest problems plaguing the Web3 space right now is adoption. There are thousands of applications, but they don't have any users. Most of these applications are ghost applications. And why isn't adoption really happening in Web3? If you were to look at it from a developer or a startup's point of view, first of all, finding a customer is really difficult because you can't make use of ad networks like Google and Facebook since there is no way to target a user. And even if you're able to get a few users, keeping them is even more difficult because unlike Web 2, where you have so many tools to remind a user about your application, like you can send them an email, you can send them an SMS, you can send them a WhatsApp, you can't really do any of that in Web 3. On top of it, for users, it's even worse. Like for a new user coming to Web 3, the UI sucks. There is no better way to put it. What they're used to is if they need something, they tap a button on their phone and an application opens up. However, in Web 3, it's a 9-step process. Plus, on top of it, there are so many scams that they just don't want to try out anything new. To solve these problems, we are creating dapps, which is a decentralized app store. This is open source, censorship resistant, and neutral to any infrastructure. The idea of dapps is to make Web3 completely invisible to the users, much like internet is invisible to us when we are browsing Instagram. With this, developers would be able to easily find users, and users would be able to install apps with a click of a button. The categorization and sorting essentially enables discoverability of apps so that newer set of developers find audience for their innovation. For application and messaging without the need of a middleware, so that developers can now create feedback loops and get the users back into the systems. The ratings and reviews to an extent keep the scams at bay. Device, so users can access it from their phones, tablets, laptops, even servers. So think of dapps as Apple App Store plus Apple Dev Tools for Web3. These are the tools that we are creating. They're able to solve the customer acquisition, as well as personalize the experience of the user and make it absolutely seamless for them to come to Web3. Now, why are we the right team to execute on this? Tarusha and I are the two co-founders. We've been working together for the last 11 years and have executed successful products in the past in Web3. For example, we launched India's first Ethereum exchange back in 2016, and our most recent Web3 product, Uniform, recently did $1 million plus in revenue and is being used by the likes of Polygon and Reef and other projects. Now, we recently closed our pre-seed round where 36 of the best brains of the space have come together to join us, and we're really proud to have these amazing people with us. Now, finally, dapps is essentially like Dubai. See, a couple of decades back, this was just a desert. But with the right infrastructure, ability, and motivation, we're able to make this place flourish, right? Right now, Web3 is a ghost town. With the right infrastructure, with the Algo team, with the right ability and motivation that we bring in for developers and users, we can finally make adoption happen in Web3. Thank you so much.
Fantastic. Thank you, Mohit. And for the last time today, over to our judges. Thank you.
Thanks very much, mate. Why Algorand? Why not a different ecosystem?
So as you might have heard from all the previous participants that everybody want to adopt multiple chains, right? The beauty of our product is that this is agnostic to any chain. So once a developer has deployed on Algo, anybody connecting from MetaMask would still be able to play those games that are being deployed on Algo. You don't have to deploy on multiple infrastructures. Just with one chain and you're good to go and access from any other platform. On top of it, the more chains that we add, the more powerful our system becomes. Like for example, one of the layers that we have is the identity layer. Here, when you are trying to reach out to a user, you don't have to map out their multiple addresses. Our system does that for you. So a user coming in from any chain using your product, it's the same for you, right? It basically enhances your data and allows you to personalize their experience better.
Thank you for the presentation. Quick question in terms of the monetization strategy and how do you plan to charge for applications? I mean, there is I think, heated debate on Twitter today around the App Store. So, what is your model?
So first of all, thank you for the question. I'm a big fan of making money. So we have 7 different monetization strategies. First is the AWS tier model. So whatever the developers use, they basically pay for us. For example, if they are using our identity layer, so for each identity that they are fetching of the user to beyond the free tier, they are paying us per notification. For the commerce layer, we are providing them better set of tools to empower them and make more money out of it. And we in turn make ads. And with the identity layer, essentially the identity layer becomes the Facebook pixel of Web3 now, because now you can segment and target a user based on their behavior. And we, of course, take a part of that revenue. This is currently not commercialized. This is all completely projected right now, because right now our core focus is to attract as many developers as possible.
You mentioned you have closed the seed round. How big was the seed round?
So it was a pre-seed round where we had capped the investment per investor to 10 grand, and it was a 314K round. The idea was to reach out to the best people in the space. So first of all, we figured out that what is it that we need to make dapp successful. For example, we need good tech, good UI, good compliance, influencers, And then we made a list of the best people that are in the space. We reached out to them, 36 of them agreed to become part of our journey. That's how we closed our pre-seed round. Of course, a lot of them are spilling over to the seed round as well.
Let's give it up for dapps, please.
Thank you.
And our other 9 wonderful projects. Thank you very much.
Okay, so, wow, okay, we got through the 10. Thank you all so much for being a really great audience and supporting them. And just give them one more big round of applause, everyone. They really deserve it. Thank you also to Joe Polney, who's just about to come up. We're just eating into his workshop. He's one of our hardest working DevRels. Give a wave. Okay, so finally, thank the judges as well. Thanks a million for your time. I really appreciate it. So what's going to happen now is the judges are going to deliberate. We're going to be announcing the winners after the last panel this evening, which is the path to mass adoption, real-world solutions with global impact, and that's happening in the arena at 20 to 5 today. And so after that panel, the winners for the build pitch competition, the winner and the runner-up for the build, and the winner and the runner-up for the scale pitch competition. So listen, thank you so much, everyone, again, and we look forward to seeing you hopefully at the announcement later on today. Thank you.
Thanks, Joanna. Oh, wonderful. That was so much fun. All right, congratulations to everybody who pitched. I can't wait to see the results. All right, devs, we're gonna get back to building. So this afternoon we have 2 developers who are going to build the same dapp using 2 different languages, PyTeal and Reach. So first up is my colleague Joe Polney. He is a developer relations engineer. And then a little bit later, we're going to have JP Miller from Reach come up and build it. So while Joe gets himself set up over there, just checking in with you guys. How you guys doing? Day 2? Yes. All right. To all you guys out there streaming with us, so glad you are there. It's great. Let's get straight into it with Joe. Welcome to the greenhouse. Take it away.
All right. Thanks, Ryan. So today I'm going to be going over how to build an auction app with Beaker. And In this talk, I'm going to be going over not only smart contract development, I'm going to be talking about testing and implementing your contract in a front end. But before, I'm going to briefly talk about why you want to use Beaker in the first place. So why Beaker? So before Beaker, you need to, when you're writing a contract, you need to write a lot of helper functions. You have to manually bother with encoding and decoding all the data you're dealing with. There's no cohesion between your development and your testing. So you have your code base for the smart contract, and then you have a completely separate code base for the testing, and there's no cohesion between the two. And then finally, when you're writing the contract and when you're interacting with the contract, you have to manually manage the state, and it can be a little bit cumbersome, and if you have to do more things manually, it's easier to make a mistake. So Beaker eliminates a lot of those things, and if you want to learn more about Beaker, earlier today, Chris Kim did a talk going over the fundamentals of Beaker, but today, I'm going to be going over how to build an actual smart contract using Beaker. So the first thing I want to talk about is the design, what the app we're going to be building looks like. So this is going to be a fairly basic app. It's going to basically have the owner be saved in the smart contract, and then the owner can start an auction, anyone can place a bid, and then auction lasts for a desired length, and then once that length is reached, the winner becomes the new owner. So in Beaker, we're working with Python, so the first thing you got to do is import the modules you're using. And here we're importing both PyTeal and Beaker. So Beaker is a framework that sits on top of PyTeal, so we'll still be writing PyTeal logic, but we're using Beaker to help organize and integrate with our testing and front end. Then we also have some other imports for writing files. And then finally, we get started by creating our class. So the class inherits from application, which is provided by Beaker, and this gives us a lot of helper functions and allows Beaker to know that this is a smart contract that we're writing. So the first thing I like to do when writing a smart contract is think about what sort of storage you're going to be using in the smart contract. On Algorand, there are a couple different kinds of storage. Here we're using global storage, which is basically key value pairs that is saved in the application itself. So for our application, we're going to be defining 4 different key value pairs. The first 2 are owner and highest bidder, and these are both going to be saving bytes. So you'll see we have stack type equals tealtype.bytes, and that's telling Beaker that this owner key is going to be saving some value that is the type of bytes. And then we're also, for both of these, we're defining our default values. So the default value for our owner is just going to be the creator of the application, so global.creator address. And then the highest bidder is just going to be an empty string, because when we create the application, there's going to be no bids, so we want to use an empty string to signify that there's no bids. And then we have 2 integers being saved in key value pairs. We have auction end, which signifies the timestamp at which the auction will end. So on Algorand, you don't have access to the time during execution, but what you do have access to is the timestamp of the last block in the chain. So we can use that to get a rough estimate of when we want the contracts or the auction to end. And then finally, we have highest bid, and this is going to be saving what the current highest bid is. So any new incoming bids have to beat out this value in order to be considered a valid bid. And now we can actually start getting writing our logic. So the first thing we're going to do is write this pay method. And this pay method is a helper function that we're going to be using in our other methods later in the code base. So what we do here is we decorate it with this @internal decorator. And what this is telling Beaker is that this is an internal method that we're using internally, but our end users aren't going to be directly calling this method, and it's only going to be used within other methods in the contract. So we have that @internal decorator, and then the tealtype.none is specifying that it has no return type. So this is basically a void function. And now we can get into the actual logic itself. So the first thing you can see is we're defining our function with 2 arguments, receiver and amount. And this is going to signify who is receiving the payment and what the amount of that payment should be. And then we are using inner transaction builder, which is an abstraction used to send inner transactions in the smart contract. An inner transaction is a transaction that a contract itself sends, and it sends funds from its own address. So every application you create on Algorand has an application ID, and then the application ID to generate an address that I can spend funds from. So we use this inner transaction builder.execute to define what that transaction should be, because we want to signify that this is a payment transaction. We're setting the receiver and the amount according to our arguments that we pass in, and then we're setting the fee to 0. And we're setting the fee to 0 here so that the smart contract itself doesn't have to worry about ensuring that it has enough algo to pay for fees. Instead, on Algorand, fees can be pooled together. So when you call the smart contract, the fee on Algorand is generally 0.001 algo. But here, whenever we call this inner transaction, we need to send 0.002 for a fee so we can cover this fee amount because we hard-coded it to 0. So now, this is the first actual external function that we're going to be calling, and this is what we're going to be calling when we create the smart contract itself. So we have this @create decorator, and that is signifying to Beaker that this is the method that we want to call when the user wants to create the application. And all we're doing here in this create method is initializing the state. So if you remember, when we defined our global state, we set some default values. This initialize application state function will set those keys to the default values that we defined when setting up our state. Okay, so now this is the first real functionality that end users are going to be interacting with, and this is the start auction function. And this is the function that the owner can call when they are ready to start an auction. So the first thing you're going to notice is on this top line, we have the @external decorator. And this is telling Beaker that this start auction function is an external function that end users can call, and it's exposed in the ABI. And if you're not familiar with the ABI, it's basically a JSON file that tells end users and SDKs what sort of methods are available to call, how to call them, what arguments they have. And so this @external decorator handles all that for you and signifies Beaker, we indeed want to expose this as an external function that can be called. So now in the arguments that we take in 3 arguments here. We have the payment and starting price and the length. And if you notice, all of these types that we're annotating it with start with ABI, and that's because these are ABI types in accordance with the ABI specification on Algorand. You don't really need to know the technical details of how the ABI specification works. Really, the main purpose of the API is to provide these abstractions of types so you can easily work with them in higher level languages like PyTeal and Beaker. So the first thing to mention here is that our first argument, payment, is expecting a payment transaction. So on Algorand, we have atomic transactions, which mean you can up to 16 transactions together. So defining payment as an argument to start auction is signifying when we call start auction, we want another payment transaction to be grouped together with the start auction. And then in our contract, we can use this argument to inspect that payment and get details about that payment transaction. The next argument, starting price, this is pretty self-explanatory. This is going to be the starting price for the auction and signifies what is basically the initial highest bid that a person needs to bid in order to become the highest bidder. So the starting price will signify what the first bid needs to surpass in order to be considered valid. And then finally, we have length. So as I mentioned, Algorand, you can get by looking at the timestamp of the last block. So what we're doing here is passing in a number of seconds that we want our auction to last, and then when the end should be. So now in our actual logic, what we're doing here is the first thing is verifying our payment transaction. So as part of the start auction call, we need to send a payment to the contract so that it is able to spend on Algorand. On Algorand, a contract or any account needs a minimum balance of 0.1 algo, and if you're below that balance, you're not actually active in the ledger, and so we need to fund the contract initially so it's able to send transactions. So the first 2 assertions we have here, the first one is verifying that the receiver is indeed the current application address, and then we're also asserting that the amount is equal to 100,000 micro algo. Then what we're doing is we're setting our global state. So we're setting the auction end. So like I mentioned, we're getting the latest timestamp from the last block, and then we're adding the length to that to signify when the auction should end. And then finally, our highest bid, we're just setting that to our auction price. And that's going to be used in the logic determining what a valid bid will be. Okay, so this is the logic for the bid itself, and this is probably the most complex part of the program. And there's a lot of things going on here. So first, again, this is an external method, so this is an ABI method that you can call externally. And then we are also sending in a payment here, but this time the payment will be the bid itself. So when you want to bid, you call this function, but you also send a payment signifying the amount that you want to bid, and then you have to pass in the previous bidder. And on Algorand, in order to interact with account or an asset or an app, basically anything that involves reading or writing state on chain, you need to predefine what sort of state you're going to be reading. So here, one of the arguments for this function needs to be the previous bidder, because we might be sending them a transaction returning their last bid. So we need to define who that previous bidder is so we can send them a transaction. Then for our actual logic, we first do an assertion, making sure that we haven't passed the auction end. So this is getting the latest timestamp and making sure it's not past the auction end that we set. And then we're verifying the payment transaction. So we assert that the payment amount is greater than the highest bid, and we're asserting that the transaction sender is of the application call is the same transaction sender of the payment. And now we have some conditional logic. And what we're doing is we're checking if the highest bidder is an empty string. And if it's not an empty string, that means that there was a previous bidder. Therefore, we need to execute a transaction returning their bid. So we have, if the highest bidder is an empty string, we're going to assert that the highest bidder is equal to the previous bidder dot address. What this is doing is basically ensuring that the previous bidder we passed in is indeed the highest bidder. And then the function takes two arguments, the receiver of the payment and the amount. So here the receiver is going to be the current highest bidder. That pay function call is going to execute an inner transaction, sending back the previous bid to the previous bidder. And once we do that, we can then update the global state to signify who the new highest bidder is and what they bid. So we're setting the highest bid equal to the amount of the payment that was sent, and then we're setting the highest bid to the payment sender. So now in our global state, we'll update what that highest bid is and who it came from. And this is an iterative process. This function will be called multiple times whenever someone wants to bid. And then finally, we have end auction. So end auction is a function that can be called by anyone, and it essentially triggers the logic that ends the auction and basically resets the state. So first thing we're doing here is asserting that we have indeed passed the auction end time. And then we are going to execute a payment to the owner of the amount of the highest bid. So as an owner, you start the auction, people bid on it. At the end of the auction, the highest bid gets sent to the owner. And then once we pay the owner, we can then set the owner to the new highest bidder. We can set the auction end and highest bidder state values to their default values. So for auction end, this is just going to be 0, and for highest bidder, this is just going to be an empty string. And this is going to basically reinitialize the state to what it was when we first created it, except this time it's a new owner. So that was what the smart contract looks like. And now I want to get into kind of the real value proposition of Beaker, and that is what's called the application client. And the application client provides abstraction for actually interacting with a smart contract. In this case, I'll first be going over with how to use the application client for testing, and then we'll be going over some integration on web as well. So first, let's talk about what our end goal for testing is going to be. So we want tests that are reproducible, quick, and simple. And as I mentioned earlier, before Beaker, it was hard to really get that simple is really the key thing that we're adding here with Beaker. And as you can see here, we run these tests that are using Beaker, using PyTest, and we have 15 tests that passed in 0.82 seconds. And this is all because Beaker automatically connects to the underlying local network. So if you start up a network using Sandbox, automatically connect to that. And if it's in dev mode, it'll execute instantly, and you have super quick testing. So the first thing we do in our test is get all our Python imports. First thing is importing Beaker itself, but then we also import our auction class that we made. So if you remember, in our contract itself, we had a class called auction, and in our test, since we want to interact with that contract, we need to import it. Then we also import some various functions from the SDKs, and I'll go over what they do when we encounter them. And then finally, we import PyTest itself for actually executing the test. Okay, so this is our first fixture. And for those that aren't familiar with PyTest, is you have fixtures and you have tests. And fixtures are basically like helper functions that help you initialize state to what you want it to be when you're ready to actually test. So here in our create app fixture, we basically want to write code that creates the application that we can then use in our test. So the first thing we do, we're going to create some global variables that we're going to use throughout the test. If you really wanted to avoid using global variables, you would probably want to use fixtures and properly, pass down the values. But in this case, it's just a little bit easier to use global variables. So that's what we did here. And then the first thing I do here is I use this sandbox.getAccounts. And this is kind of the first that really alleviates the need for running our own helper function. So what the sandbox.getAccounts function does is get all the accounts on our local network and then gets their values. So this specific array is going to be sorted by the amount that the accounts hold. So basically this will be a sorted array ordered by the amount that the accounts are holding. And then now what we want to do is we just want to pop off one of those accounts, and we use that account as the creator for the application itself. And then now we're ready to instantiate the application client. So like I mentioned, the application client provides some abstraction for interacting with our application. So here what we do is we call client.applicationClient from Beaker, and we're specifying a couple things. The first the client we want to use to interact and create the smart to create and interact contract. Here we're just using sandbox.getAlgorand. This is just a helper method for getting the default sandbox connection information and connecting to AlgoD through that information. And then we're specifying what the app that we're creating the application client for is. So if you remember, we imported this auction class from our smart contract, and we're specifying the Teal version as version 6. Then finally, we need to pass a signer, and what this is basically specifying is when we create the transactions with our application client, how do those transactions get signed? And of course, Beaker provides abstraction for handling that. So in our creator account that we popped off our array from .signer method, and this is a method that automatically sign transactions for that account. Then once we did a little bit of that setup, we .create. What that's going to do is create the application itself. Okay, so this is our second fixture. This is going to be initiating the start auction function. So what we're doing here is we're using our app client to, and if you remember, this was a global variable, so this is coming from that first fixture. What we're doing is getting suggested parameters. So when you make a transaction on Algorand, you get the suggested parameters, so you don't have to manually specify things like how long the transaction should be valid for and what the fee should be. The suggested parameters will calculate that all for you. So we get that from the application client, and then we're using the SDK to make a transaction, attach a signer to it, and then we just have one line here, appClient.call, where we're specifying we want to call the start auction function. We're specifying our payment argument is going to be that pay transaction we created. We're specifying our starting price is going to be 10,000 microalgo, and our length is going to be 36,000 seconds. And now we have a fixture for sending our two different bids, because the logic is a little bit different for both of them. We want to make sure we have complete code coverage. So here, for a fixture for our first bid, we're popping an account off the array to signify as the first bidder. We're getting our suggested parameters from the application client. We are creating a pay transaction, which will be the actual bid. So the starting amount is 10,000. We want an amount that's higher than that. So as you can see in our transaction, we're specifying the amount is 20,000, and then attaching our signer to it, and then we call the method with appclient.call, specifying we're calling the bid method, and then passing in the payment transaction, passing in the previous bidder, and attaching a signer to it. And then now we have our second bid, and this is very similar logic to our first bid. Really the main difference here is that when we send that second bid, we need to figure out who the first bidder was and add them to the application call so we can return their payment. So what we're doing here is we're getting our suggested parameters, but we're doubling our fee here. So if you remember, we set our inner transaction fee to a hard-coded 0, and what we're doing here is doubling this outer fee so that that 0 transaction fee is made up for in this outer transaction call, which is why we're doubling it. And then what we're doing is we're also getting our first bidder amount. This is something we're going to be running an assertion on in our test later, so we want to save this before we execute this, because we want to make sure that the accounts are actually given the algo that they rightfully deserve. And then we make the bid transaction much like we did the first time. So creating the payment transaction using the SDK, and then calling the bid function, passing in that payment transaction and the previous bidder. And finally, we have our end auction fixture. And this is a little bit different. So we do the same doubling of the fee to cover that inner transaction. But one thing you might notice here is that we're not actually using Beaker, the appclient.call method. And the reason we're not using appclient.call is because this end auction functionality depends on the timestamp that we get on chain. The problem is, if we want our test to be quick, we don't actually want to wait that 36,000 seconds that we defined to be the length of the auction, right? You don't want to wait that long every time you test. So instead, you want a way that you can essentially spoof what the current timestamp should be read as during execution of the contract. So we use a feature of AlgoD, the node software called Create Dry Run. And what this basically does is creates a template of a transaction that is executed against the current state of the blockchain, but it's not actually added to the ledger. So what we're basically doing is like simulating what this transaction would actually do if we were to send it to the network. And one of the nice things we can do during this dry run is specify the latest timestamp. So if you see here, we have latest timestamp equals some super large number, and that signifies January 1st, 2050. So we're well beyond when the end of the auction should be. And this is basically going to ensure that when we call this end auction, we are indeed past that end time, and we actually trigger that end auction logic. And then so once we form the transaction or form the dry run, we then call appclients.client.dryRun. So we're still connecting to AlgoD through our app client, but we're just calling the dry run endpoint rather than .call. And then we are getting the global delta. And so what this basically is it's a summary of what global state has changed throughout the course of the smart contract execution. Okay, so now we can actually go into our actual assertions that we want to use for our testing. This is really kind of like functional regression testing. So we have some simple tests that verifying account balances, and state. So our first one is when we create the application, we want to test that everything was initialized as we expected. So first thing we're doing is test create owner. We're verifying that when we create the auction smart contract, the owner is set to the creator address. Then we're going to test the highest bidder. We want to make sure that's an empty string. And then we test our highest bid auction end values to be 0, because those are the default values that we expect them to be when we create the contract. And now we have some assertions for when we actually start the auction. So after we call our start auction call, the first one we're doing is making sure that the auction end is not 0 and it was properly initialized. And then what we're doing is verifying that the highest bid is equal to the starter amount. So in our fixture, we specified the starting amount to be 10,000. So here we're just reading the global state of the application through Beaker and making sure that it is indeed 10,000. And that's an important thing to note here, is that getting the global state is just a single line call. It's just app_client.get application state. And this provides a ton of abstraction on a lot of manual things you have to and getting it into like something human readable, whereas Beaker does this all for you, and we can just assert that it's equal to 10,000. And so now we're doing something very similar on our bids. So for our first bid, we're verifying that the bid amount is updated properly, much like we did when we started the auction. And then we're verifying that it saved the highest bidder. So we're verifying that the state was updated properly. And then now we have for our second bid fixture. So in our second bid, not only are we verifying that the state was updated as we expected it to, much like our first bid, but we're also verifying the amounts of the accounts that are involved in this process have the balance that they expect, right? So we're making sure that the first bidder balance, they get their first bid back. So here you'll see, if you remember in our first bidder fixture, we had this first bidder amount variable, and this was how much algo they had in their account, or micro algo they had in their account before sending the bid. And then we want to make sure that now, after sending the second bid, they have that initial bid value back. So they sent 20,000 as a bid, they should be getting 20,000 back when there's a new highest bidder. And then we're also doing the same thing for the contract. So we're making sure that the contract has the expected value in it. So we're making sure that it only has the 30,000 that we just sent as a bid, plus the 100,000 micro algo that was used to seed the account initially. And then finally, we have some assertions for the end. So the first thing we're doing is ensuring that the second bidder address, we're ensuring that the owner is set to the second bidder address when the auction ends. So when we call the end auction, there is a second bidder that has the highest bid. So the end auction will then change them to the new owner. We want to verify that that actually happened. And then we also want to be checking that the highest bidder is set to an empty string and our auction end is set to 0. So basically reinitializing those default values that we had. And again, if you remember, we used dry run here. So we're using this global delta variable that we got from the dry run when we sent it to our node. So that is what testing looks like using PyTest. You, of course, don't need to use PyTest. And we also have tooling for interacting with a Beaker smart contract on TypeScript or JavaScript, which I'll be going over for web integration. So you could write tests using a JavaScript testing platform, something like Jest, for example, is also an option. But now I'm going to be going over web integration. Right, so writing the actual smart contract is only like half of the story when it comes to writing a full-edged dapp. You want a way to implement that smart contract into your web application, so you have a fully functional dapp that end users can actually use. So what's our end goal here? As you can tell, I am not a Web 2 dev, so we have a very simple interface here where we basically have a couple of buttons to initiate the various functions that we've created in our smart contract. And we want to be able to do all these things on testnet. So I'm going to be going over a couple of key things, going over like what it looks like, and then code, showing a little bit of that, and then going over a quick demo. But the first thing to mention is this tool. Basically what it does is it takes a Beaker smart contract and basically re-implements it in TypeScript automatically. So one of the artifacts of a Beaker contract when you execute it is this thing called the application spec. And this is basically a JSON file that, that specifies what sort of functions are in the smart contract, what the compiled code is, what are the types, basically everything you need to know in order to interact with the smart contract and recreate the smart contract itself. So we use that application spec to then generate TypeScript code. So here you can see I have a npm script just called Beaker. So I run npm run Beaker. It'll compile to generate that source code automatically. And once we have that source code generated, in our case, Beaker/auction client is where the generated code lives. So you can see here in our JavaScript file for our front end, we're just importing that auction class from that TypeScript file. So it's just a regular TypeScript class that we can import and use to interact with the smart contract. We also have some other imports, so Algo SDK and myAlgo, since we're going to be sending transactions on testnet. And since we're going to be sending transactions on testnet, by default, Beaker will just connect to a local sandbox. So instead, we want to create our own connection to a public API using AlgoNode here that connects to testnet. So once we have that connection set up, we can start actually interacting with the smart contract. So this is a snippet from the JavaScript code showing over what it looks like when we create the smart contract. So we'll have a button that's just called create, and when we click that button, what we want to do is instantiate this auction class. So this is a class that was auto-generated by Beaker TS, and we're passing in some parameters here. We're specifying which client. We're specifying a signer function used to sign transactions, and I'll show you what that looks like using myAlgo in the next slide. And then we're it from a drop-down menu. And finally, to create that, we just call auction_app.create, and it's an asynchronous call, so we have a wait there to make sure that we initiate those variables. And we are now ready to, and we have now, after this line of code, deployed the contract on testnet. So one of the input parameters to when we created the application client was this signer function. If you remember, there was a signer function in our PyTest, but that function was automatically given to us through the sandbox.getAccounts abstraction. In our case, we need to write our own signer function that lets the end user sign their transactions using myAlgo. So here we have this myAlgo.signTransactions function, which is basically a wrapper around the native myAlgo APIs. And then we're using that to actually sign the transactions, and then we're returning the signed transactions. So this signer function, all Beaker is expecting is basically a function that takes in transactions and return those signed transactions. How you get from transactions to signed transactions doesn't matter to Beaker. That's why we can just write our own function that calls out to myAlgo to sign those transactions. So we now have our application deployed. The end user has called .create, and they now want to do other things. In this example, we're signifying the start auction function, but it's a similar pattern for all the other functionality as well. So what we're doing here is instantiating this auction class pretty much the exact same way that we did when we created the auction. But this time around, we are specifying the app ID. So with a Beaker application client, you don't, it's not just used for creating the application, a brand new application. It can be used to interact with an existing application, provided you know the application ID. So here, that's what we're doing. We're telling this Beaker or this auction class that, hey, this is the app ID that we want to interact with when we're calling methods on it. And then, much like we saw in our PyTest, we're forming a transaction and then passing that as an argument, and then passing in our arguments to this start auction function. And the nice thing here is that you can see that the auction class, it's aware of what those arguments are. It's aware of what those types are. It's all auto-generated TypeScript that provides that sort of seamless experience of interacting with a smart contract like it's a regular JavaScript library. And that's the real value of this application client here. So if you want to learn more, this is a QR code that will send you to a link tree. It has the link to the repository for the Beaker auction. It also has a repository for Beaker and a link to our Discord. And so if you want to learn more, go there. And real quick, I will go over just an example of what this actually looks like when we serve the code. So if we do npm run serve, it will load our beautiful interface here. And so now what we can do, zoom in, make this a little bit bigger. So the first thing we're going to do is we can connect our wallet. And then now that we have our wallet connected, we're going to be using this Alice account, and we're just going to call .create. And that's going to tell, when we did that, that called that signer function and told us that we want to sign the transactions using my algo. Give it a minute to create the application. It is an application that is actually deployed on testnet here, and we can take a look at our application state, and we can see we have all those keys that we specified in our Beaker smart contract. So now we can go here and we can start the auction. So we'll start it for 10,000 micro algo. So again, calling that signer function, signing with my algo, and then we're waiting for that transaction to go through on testnet. And now we can see the auction has started. So if we go back over here and we reload, we now see that our values have been initialized, right? So we now have the highest bid to 10,000, and we have a auction end time. And now we can bid. So we can use this Bob account, send a new bid. And again, same thing as before, it's using that signer function to sign using my algo. And we will see the new values populated in our global state. So we now see the 20,000, and we'll see that using Beaker and very few lines of code, we've been able to deploy a contract on testnet and easily interact with it in JavaScript using auto-generated code provided by Beaker TS. And this is really the value add of Beaker, right? This ability to have one smart contract code and then be able to leverage that same code base in Python tests and JavaScript tests and JavaScript front ends, Python front ends, you name it. This is what the application client can provide for you. Okay, so that is all the content to go over. I'll bring this up on the screen If anyone else is interested in the resources, are there any questions?
All right, here we come. Question time.
Thank you. In that bid function that you showed us before, there was an argument for highest bidder or previous bidder, something like that. And I'm wondering just the logic of when you're bidding, like you're a third party or whatever other account, why do you care to send the highest bidder? Doesn't that live in the global state? And I'm just wondering why that structure.
Yeah, so let me see if I can go back to that. So the reason that we have to pass in the the previous bidder argument here. So the reason we're passing that in is because we're sending a transaction to that previous bidder to return their bid. And you might ask, why can't you just read that from global state when we do that? And the reason is because on Algorand, you need to predefine any accounts that you're sending a transaction to. And so like when you send a transaction to a node, it sees which accounts it's going to be interacting with beforehand and load it off disk into memory. So during the actual execution, it's not actually reading out to disk, it's just reading that account state from memory. But it needs to know before actual execution what accounts it's going to be touching. So we're passing that as an argument here to let the AVM know, hey, we're sending a transaction to this account, we need to update its state, preload this into memory. If we didn't pass in this argument, what would basically happen is the AVM would panic and say, hey, you're trying to touch account that you basically don't have permission to touch. And it would panic and the transaction would fail. So that's why we need to specify it as an argument rather than just reading from global state during execution.
Do we have any more questions? Oh, good. We're coming.
I do have a question about the start auction function. I do believe there was no checking there who is actually calling that function. So I might start an action as a BOP, maybe. Is that correct? So I might start the auction not as an owner of an auction. Or was there checking? Was the code checking for who is signing the transaction?
Oh, okay. So you're saying in this, sorry, it's a little hard to hear. So you're saying, like, is there code to like assert that the owner is actually the one starting the auction?
Yeah, that's the question.
Yeah. So there's actually not, but there should be. So one of the things that I forgot to include here is if you saw Chris Kim talk earlier, Beaker has a authorize decorator, and so on this, like before this line at external, there's a decorator that will specify that only the current owner can call this function. So you can write function to do that. I just forgot to show it here.
Okay, thank you.
Yep.
Do we have any other questions? And that was a good catch out there. Nice work. Nice. All right, everyone. Well, Joe Polney, my esteemed colleague here, giving us the example of the application written in Beaker. Nice work there. So that was the auction dapp written in Beaker. We're gonna rinse and repeat. We're gonna do the same dapp, but JP Miller's gonna come up and do it built in Reachlang. So while he gets himself set up, you know, we're gonna do a little dance here. Little show of hands out there. Who has already successfully installed their developer environment? Who's already got it done? Nice work out there. All right. Anybody struggling out there getting your developer environment set up? All right. I didn't see any hands, and if you're shy, don't worry. There's one hand. All right. That one there with his hand raised. We're gonna come over. We'll get some of the DevRels to come and help you. That's what we're here for. That's what our job is to get you guys set up and successfully building. So make sure that you're connected with us on our Discord server. That is discord.gg/Algorand. We will be there and make sure that you are there. Make sure that you are checking out our developer portal. That's Algorand, or developer.algorand.org. Hope that you can come and join us there. We've got all sorts of demos and sample code, and we'll get you taken care of. Lots and lots of documentation. For what JP is going to go through here today, he's going to build the auction dapp in Reachlang. You can set that up by going to reach.sh, and they have the installation documents there. Almost ready. Good. All right. Looking good. Yeah. All right. We're having so much fun here. I'm so glad that you guys are here. This is great. Here at the second annual Decipher conference here, I haven't heard where it's going to be next year, but I hope that all of you will come and join us wherever in the world we get to go. We've had a great time here in Dubai. It's my first time, so thank you for having me, Dubai. This was awesome. All right, this is a lovely, lovely venue. Thank you to everybody who has come out, flown from all over the globe. I can't remember, there were like 60 different countries where we came from. That's just incredible. Looks like we are getting closer, so I'll just keep going on, right? Let's see here. What else? I will tell you, I'm getting a little tired. Who's been watching the World Cup out there, right? The pretty exciting stuff going on. Did your team win last night?
Okay.
All right. Good.
Are
any of your teams still playing? Are you ready to go through into the knockout rounds here upcoming? Very exciting stuff. And let's see here. What else have we got going on there? So thanks to everybody who's been here on the Tech Talk stage in the greenhouse over the last couple of days. I'm looking out there. I see Zeph. Man, wasn't it great to see him out there showing us how to build using PyTeal in his example of the tallest, your favorite tallest building out there. That was kind of a fun example. And right, JP's going to make it difficult on himself here. All right. Here we go. All right. Well, we're having fun. How's it going, JP? What do you think?
I think we're here.
You're going to do it that way?
Yeah, we're gonna do it the hard way, cowboy way.
Let's do it.
All right, let's do it.
Mr. JP Miller from Reach is going to build us an auction dapp.
Well, here we go. Okay.
I wish I could moonwalk, but I can't.
Gotta
Take
do
it away,
All right,
JP.
thank you, Ryan.
Welcome.
How's everyone doing? All right. I'm JP Miller with Reach, and let's see, where's my slideshow at? Here it is. There we go. Okay, with DevX, so I'm the director of DevX at Reach. You might know Nick Stanford. He's our local hero. You've got me today. It's my LinkedIn. If you want to connect, say hello. So at Reach we want to solve the question of how can I build dapps quickly and safely. It doesn't take me months to learn. And Reach is our solution. So Reach is a high-level Web3 programming language that is also a compiler, verification engine, and a deployment tool. It looks and feels like JavaScript, so it's easy for a full-stack developer to get up and started. We're able to train full-stack developers in about 6 weeks and have them ready for a job in about 8 weeks after they've built a program, shown some experience. So one thing I'd like to highlight before we actually get into the code, I'm going to get into a text editor and show you some code. I was hoping to code it out here, but I don't know how that will work, so we're going to maybe just go block by block. But before we get into the code, it's wise to stop and think about the problem that you want to solve. So we're building an NFT auction, and we're actually going to do 2 apps today. Those Reach programs, they're high level and they're so compact. We have the time in 50 minutes, maybe 40 minutes to allow time for questions, to go through 2 quick apps. And we want to think about these problems. So one problem is, how can I mint NFTs? And how can I do that with reach? And then the other problem is, how can I serve those NFTs in an auction so I can sell my NFTs, or I can allow other users to sell their NFTs and allow bidders to bid on them? And then you want to think about, like, who's all involved in this process? Who are my participants? You know, there's going to be an auctioneer or a seller of the item. There's going to be bidders. There's someone who's minting an NFT. You know, are they the same people? Are they different people? You know, think through all of those problems and all of your actors who are going to be participating in your application. And you want to start thinking about the flow of the app, the logic of that application. Right? And these are all important things to answer, questions to answer, before we actually start building the application. Oftentimes the temptation is just to get right in and start coding, and you know, without like a framework or like really thinking through the control flow of the program, we can get ourselves in trouble midway through. So if you'd like to follow along, or if you'd like to look at the code base, there's a QR code to the GitHub repository. For this first one, we'll look at the NFT minter. All right, let me pull this up. So I think actually what we can do here is pull that over here and grab this one over there. We're just playing musical chairs. It's not just a kid's game. I guess this is musical windows without the music. Okay, cool. And then over here, we'll just go, where are you at? There we go. Blow that up a bit. Maybe a little more. Okay, cool. All right, so our first program here is an NFT minter. I want to be able to mint an NFT, and I want to build my own NFT minter. So how could I do that with Reach? This is actually an interesting program because we won't actually use any of the back-end Reach. We can do all this in the front end with IPFS. So like I said, I'm going to pull this in a few blocks at a time. We'll walk through the program in blocks. And we'll look at it together. So the first things I do, this is front end. I'm going to import my Reach, and I'm importing a test framework. And then I'm also importing IPFS. And then I'm just setting up a constant standard library so I can easily call my standard library, right? Which is just a library, just like an analog library is a collection of functions to make our life easier as developers. All right, and I want to be able to connect to a wallet because this is Web3. It's not your keys. It's not your NFT in this case. So I want to connect to a wallet, and we can do that with the set wallet fallback. And you'll notice on line 6 there, the provider environment, testnet. So there's a clue here that we're going to deploy to testnet. If I wanted to make this a real application when I was done testing it, and I want to go to mainnet, we're often asked the question of how can I deploy my Reach app onto mainnet, and it is literally as easy as doing this right there. And now your app will go to mainnet, and this is okay, but we'll leave it at testnet for now. And then we'll set up our accounts. There are different ways you can set up accounts. Today we're going to use a method called new account from mnemonic. It just grabs the 25-word mnemonic from an Algorand wallet, my algo in this case, and we're assigning one to a minter and one to a receiver. So we're going to, in this, we're going to mint an NFT, and then we're going to transfer it from the minter to a recipient. And I'm just giving the minter and receiver debug tags so that when we test this in the terminal, instead of seeing AGF134, we see minter and we see receiver, right? So we have something that looks human readable instead of an address. All right. Then we'll format our tokens. So contracts want to, in the blockchain, they want to read tokens in atomic units. So it'd be like counting all of your dollars as pennies, right? And humans don't really like that as much. We don't want to think about like $10,000 in terms of pennies. And so we format the currency. This is for our humans so that they can read the currency easily. And then we just set up a little helper function in this get bal that explains the who has a token and what the balance is. And so this will show the balance of the token. And let's see, it goes over a little bit. So this just is waiting for the balance from the standard library, and who is the account and the token, and then we are formatting the balance so that it's human readable. All right, then one more helper function here to log our balance, and we'll walk through this together. So this function, log balance, is an asynchronous function that takes an account. It sets a token as false. So token in this case is a non-network token, which would refer to an NFT in this case. A network token would be like your algo, and then any other tokens under the algo blockchain be considered non-network tokens, so NFTs. And this just grabs a balance and the unit to track if it's a token. If there's a token there, then it shows how many there are of the NFT. Otherwise, it'll show us how many algos we have, and then returns that information. All right, the last thing here is we'll just wait our log balance for the minter. So now we're going to grab the balance of the minter, see how much that minter has when they start. Okay. So now we'll begin to a couple global constants just to set up our NFT. So when I imagine this is a JPAL. If you have one of these JPALs, then you're a friend of JP, and the symbol is a JPS. Right? All right, so this will be the name of our NFT. And then we start setting up our IPFS. So before this, I went to, I created a little image, I put it up on IPFS, and I got a CID, right? And I did that with NFT storage. And so we just set this up. And all this bit of code all came from IPFS's documentation. So setting up the accounts node, awaiting the IPFS, and calling their create method. And then we want our NFT to be ARC69 compatible. So I went to the ARC69 documentation and grabbed these parameters. So this is the supply, there's one of these. This is the CID address from NFT storage, so I got that from IPFS. And then we have a clawback value, a freeze address, and then we can set our ARC69 token to be default frozen. If that were true, then we wouldn't be able to transfer the token. And then we can also reserve it, and we could add a node if we wanted to. All right, so this sets up the options for our NFT. Grab a function for getting the IPFS data. So previously, as I mentioned, I put this image on in some way, right? So, and again, this came from IPFS documentation. So I get the IPFS data, set up a stream and a decoder, and then I just set up this 408, and all this was almost directly from IPFS. I just needed to add it in this new data because Reach doesn't allow for increments, so I couldn't do like a plus equals with Reach, so we just set up a new data let and add that in there. All right, so this will get our IPFS, and then I can do a console log. If I were to, I could, remove that, and it would show me like the metadata of the NFT, and it's not human readable. So we'll spare ourselves that and just leave it commented out. And this will return that data so it's accessible for us. We can interact with that. All right, so now we're ready to mint our NFT. So we'll go back to our Reach standard library code. We'll mint our NFT. So this function mints an NFT. Address, the name, so this would be JPAL, the symbol, JPS, this is of our NFT, and all those options that we set up earlier. And then we let our user know that we're minting the NFT. Set up the NFT constant, which launches the token. This launch token is a reach standard library method. It will launch our token for us, it mints it, and then we return the ID, because we'll need that for the transfer. All right, and then now our NFT will be minted. We're ready to set up our transfer function. So this will be for our transfers. Again, we're grabbing those addresses, the from address, the to address, the NFT ID, and the supply, the amount of the NFTs, which will be 1. All right, and then we wait for the receiver, token accept. This token accept is a method that we need to use with Algorand that allows an address, the receiver, to opt in, to accept the token, because we have to opt into addresses before we can accept a token. We let our user know that the receiver opted into the NFT, and then we'll transfer it over. And then we just show that the NFT was transferred, and we also have a test. So line 73 here is from our test method where we imported the test of that first line. And we're just proving that the amount of the NFTs before is the amount of the NFTs after. So there should be 1 and 1. Our last thing that we'll do is call all of our functions. So we set them up, now we want to call them. Okay, so this one on line 76 will call the IPFS data to get that data. 77 mints the NFT. Line 78 transfers from the minter to the receiver. And then we show the minter's balance, and we exit. If we didn't have line 80, that process exit, then the program would just hang. It does nothing. Right? So at this point, we're ready to run. So let me get my terminal. Where is that? Okay, let's blow that up. And we're going to do, in this case, we'll do an npm start. So this is all run with Node. So in the background, I set up my package JSON and set up the IPFS and all of that. And if you grab that QR code, you'll see that in the repository. So we get the swarm that's listening to IPFS. It's getting the IPFS data, minting the NFT. We can see the NFT information there, so we've minted our JPAL. The minter has one of the NFTs, and then the receiver opts in, so this is where they accept the token. And then we transfer the token from the minter to the receiver, and now the receiver has one of the NFTs. And then we see a successful test, and now the minter has 9.957 algo, and at the top they had 9.959. Right on. So we've minted an NFT, and we've done that with the Reach Standard Library, and we did all of that in 91 lines. And I think on this program was 80 lines of code. So not too shabby. All right, so now let's have some fun. We've got an NFT. Let's put it up for auction and make some money off of it, right? So let's get that set up. So if you'd like to look at that code, that would be here. While you do that, I'll get this set up. Okay. Okay, and we just want to pull this one over here. Okay, so let's program some reach. Let's build a reach code. So this is now we'll get into reach, the back end, index.rsh, which is your reach shell. So in this auction, let's just think about it for 30 seconds. We're going to have an auction. We want an auctioneer, someone to start the auction, and we want bidders. So the auctioneer, we're going to call them a participant. They're actually going to launch the application and put it on the blockchain. And then we're going to want bidders. And our bidders are going to be APIs. And we'll talk about that. But APIs is essentially front-end users, front-end clients that are peening the back end. They're communicating to the contract and saying, I want to bid on this NFT item. And then we'll want to set up something called a parallel reduce, where we get into a race. We want to race one another to win this item, win this NFT. And so our logic is going to be that, okay, we're going to have an auctioneer or someone to start the auction, and then we're going to say, okay, the auction is ready. And then all the bidders are going to bid on that NFT. And they're going to race one another to win the NFT until the time, so there'll be a deadline, and once the time is up, then no one else can bid on it, and we'll announce who the winner is. This is like, roughly speaking, like 45 seconds. That'll be the logic of our program. So the first thing we always do is we start with the version of the language, so in this case, reach 0.1. And then we're going to set up our initialization. So we're going to set up our creator. So let's see here. All right, so app initialization, we're going to set up our participant interact interface. We've got a creator, they're a participant, and we've named them as creator. And they've got a function called getSale, so they're going to grab the NFT ID, they're going to identify the minimum bid amount, and set up how many blocks they want the auction to last for. And then they'll call an auction ready, a C bid, and a C outcome. And you'll see that we have types next to each of the method names. So every function here, every method has a type. So auction ready, for example, is a function that has no input and has no output. C bid is a function that takes in a tuple of an address and an unsigned integer and has no output. GetSale is a function that has no input but outputs an object. And the object contains 3 fields, the NFT ID, the minimum bid, and the length in blocks. And when we start building our front end, the back end is going to reflect the front end. So all of these functions that Creator has in the back end, we'll name the same functions in the front end. And so when you're building a Reach application, you only need to track 2 files in your mind, the back end and the front end, which makes your app development much faster and less complicated. This is easy to keep 2 things in your mind, whereas it can be harder if you need to track over multiple files. All right, the next thing we'll do is set up a bidder. My bad there. We'll try it again. Okay, so we'll set up a bidder. There we go. And our bidder is an API. And let's see, I have a slide about this. So, an API is a front end that wants to communicate with a back end. And what it's going to allow us to do is for any client is going to be able to call that contract and say, I want to call this bid function. So let's build that. So we set up the bidder, and they have one function, bid. This bid is a function that takes an unsigned integer. This will be the amount that the bidder is willing to pay, and it'll output a tuple, their address and an unsigned integer. And then we'll also have that const v is information that you don't need to be connected to a wallet to see. Anyone could go to Algo Explorer and look at that information in the Block Explorer, but we're just going to make that easy so you don't have to go to Block Explorer because you can do that or be interested in doing that. And then the last thing we'll do is initialize our application. And we don't want to infinity it. I'm not sure what that function. Sometimes VS Code can be very persistent. This takes us out of app initialization mode and puts us in the first step or the first state of our application. All right, so we'll give our creator the first thing to do. So the way Reach works is you work in steps in different states of your application. So the creator is going to be in their local step in this only. So only the creator is going to create this constant, this object that contains the NFT, the minimum bid, the length in blocks, and they're going to declassify and interact with the getSale function. So interact and declassify this is how the interact right there is how we'll move between the back end and the front end. So in the front end, we're going to define getSale, and that getSale is going to have some information inside of it, and it's going to do something. And when we call it in the back end, interact allows us to essentially like middleware go from the back end server, the blockchain, right, to the front end, to the client. All right, and then we'll publish this information. And to publish information is to put it onto the blockchain, so now it's publicly available. So once it's published, you could go to Algo Explorer and you could see this information in the Block Explorer. And so we're publishing all the information inside of that object. And we're going to set up an amount, and then we'll commit that information. So set up an amount to 1. There's 1 NFT. All right, we're going to commit. And that commit takes us out of a consensus step and puts us back in a step. So we're moving to a new state. Okay. Bring in 4 more lines here. And the next thing we'll do is pay. So we're going to pay our contract. So the thing that I like to think about when I'm thinking, okay, what can a blockchain app be useful for? What is a dapp useful for? Is to lower the cost of verification. Right? So I have to think like, well, blockchains are expensive, all the gas fees, etc. It's slow. Like, how are you going to lower the cost of verification? You mean like lower gas fees? And that's not what I'm talking about. I'm talking about the verification. So here we're building an auction. We're building a robot auctioneer. Whereas in the analog world and in our real life, if we were going to, maybe you've been to an auction, so you've experienced this. You have an auctioneer, you have like a big auction house, there's a name behind the auctioneer. They're certified, they're licensed, they're bonded, they've paid insurance companies to say that they are like the truth and they are honest, and then they've got all this reputation behind them, they've got marketing and branding, and they'll spend hundreds of thousands or millions. If it's a large auctioneer organization, or it's like a franchise, they'll spend millions of dollars to produce verification, to say you can trust us as auctioneers, and we can come and hold an estate sale for you, or we can sell things from your business or whatever it might be, and you can trust us. And they spend millions of dollars to create this verified trust. And here we're doing it for 0.001 algo, or even on an expensive network like on Ethereum, where your gas fees are $50. $50 compared to millions of dollars is still very cheap. And so we're lowering the cost of verification, and I said all that to say that we're paying the contract. So the contract is going to hold the NFT in escrow. So we don't need an auction house to hold our NFT in escrow. We're just going to put it in the smart contract. And that's what line 30 does. Okay, and then the creator is going to say, I'm ready. The auction is ready. Let's go. And you see lines 32 and 33 are our views, so the v.nft.set. This is the pattern that we use to create a view. So it's view.thefield.set and NFT ID, the argument. So we're showing the NFT ID, and we're going to show the minimum bid. And this way, anyone can hop on our app, and they would be able to see, oh, this NFT is at 20 algo. Like, okay, I know I need to bid at least 21 algo if I'm going to be in the running for this. All right, then we're going to assert a balance. This assert is a static assertion. This is always true. So we're saying the balance of the NFT ID, which is 1, is always going to be equal to the amount of the NFTs available, which is 1. So we're saying 1 is 1, and this is always going to be true. And it's ever not 1 or 1, then we're going to display the message that the balance of the NFT is wrong. And what this does is it tells Reach's verification engine to pay particular attention to this detail. If this math is ever incorrect, destroy the contract. Okay, and then we'll set up our end parameter. So constant end, we will end the auction after the last consensus time function plus the length of blocks. This will set up our end, and we're going to use end to get out of our while loop that we're going to create. So now we're going to begin to create a parallel reduce. So parallel reduce is a race, and whether you know it or not, you've been participating. Parallel reduce is a reduction, and you've learned about reductions back in first grade when you did 1 + 1 = 2. That is a reduction. So I have a slide about that. Here it is. So a parallel reduce is simply a reduction, and we're just reducing input events. So these API calls are input events, and they're going to race one another to try to win this NFT item, but only one can win. And so what the parallel reduce does is it does the heavy lifting for us to decide which bidder takes which priority. Right? So we know that if a bid comes in and then a second bid comes in 5 minutes later, it's easy to say what the priority is. It can be harder if this is a popular item and people around the world are bidding on this. That could be very challenging to decide, okay, which address takes which priority. And the parallel reduce does this for us, and it will manage the state of the API calls. All right, so line 36, we set up our constants, our highest bidder, the last price of the auction, and is it the first bid, which is a Boolean. We set up our parallel reduce. You'll see creator starts at the highest bidder. The minimum bid is the original last price, and is first bid is true. And then define is a method that comes with a parallel reduce that allows us to show this view of the current bid. And then we're going to set up an invariance. So invariance, I'll say it like this, that the verification engine is not able to see what happens inside of a parallel reduce. It's kind of a black box to the verification engine. So what we can do is set up an invariant, and the verification engine can track the invariance. So the invariant is established just before the loop. So I don't know, we'll see that in a second if you missed it. And then the condition in the body of the loop must always validate the invariant by the time we get to continue, by the time we get to the end of the loop. And when the while loop closes, the invariant must still be true. So essentially we're saying this is a dynamic assertion that as we go into the loop, this thing will always be true when you're in the loop or by the time that we're at the end of the loop, and we either start a new loop or we exit it. And this tells that verification engine to watch this math. And so we're setting up an invariant on the balance of the NFT ID. So again, it's just saying that 1 = 1. And then line 42 there is the invariant of our balance. So is it the first bid? And if it is, then it's 0. Otherwise, it's the last bid. And that's going to be the balance. And then we start our while loop. And we're in this while loop while the last consensus time is less than the end. All right, where's my mouse here? There we go. Okay. All right, now we'll set up an API. So this is going to allow our bidder to do what they want to do, which is to bid and win. So our API block, it goes from 44 to 55 there. It sets up our bidder. So we're calling that bid method within the bidder. And we're doing a check. So this check is a dynamic assertion that says inside of this block that the bid must be greater than the last price. Otherwise, we're going to say, hey, your bid is too low. And we'll return that bid. We'll notify the highest bidder and the last price. And if it's not the first bid, if we're going to end it, then we're going to transfer the last price to the highest bidder. In other words, if no one buys the item, then we're just going to send that back to the creator. Otherwise, we'll ignore it. And we're setting up who to this, and then we're interacting with a C bid. So we're calling that C bid and saying who made the bid and how much it was for. And this return statement, that who bid and false, that matches right here at the top in this parallel reduce, this creator. And so everything in Reach is, once you set, you notice we used a lot of consts. We don't use any vars, and in a RSH file, we don't use lets, because information is immutable. Once we publish something or we publish data to the blockchain, it's immutable. We can't change it. So how do we update things like in a loop? Because the problem would be, like, once I get into a loop, I'm either going to be in the loop forever, or I'm actually not going to be able to access that loop, right? Because information is immutable. So the parallel reduce, when we return, this is able to modify those parameters. So the new highest bidder becomes the who. So I'm looking at line 36 at the very top. So the who, the address, the bidder, the highest bidder becomes the highest bidder. Kind of silly when you say it like that, but there it is. The bid amount becomes the last price, and now is first bid becomes false because it's no longer the first bid. So in other words, this NFT is no longer going to go back to the creator. And this is how, within that return statement, is how we're able to update variables inside the parallel reduce, and how we're able to do something like a race and change information inside of the Reach program. All right, then we just want to set up our timeout. So we want a way to exit the loop. So set up that timeout, and this is just going to, hey, once we time out, this is the final highest bidder, the last price, and we're going to say that is first bid, and we know that'll be false at that point, assuming there's been at least one bidder. And then our last block of code here is going to set up the transfer. So this transfer amount, we're going to transfer the amount, which is 1, and the ID of the NFT to the highest bidders. In other words, the NFT is going to go to our bidder. We're going to have our creator interact with our show outcome method. So this is going to show everyone who won the race. And then we're going to close out the contract. And when we close the contract exits, and it destroys the contract, right? And Reach is going to make sure, the verification engine is going to make sure that the contract will exit with 0 balance. It's going to make sure that we won't overspend. And it's going to make sure that it's going to assert that our front ends and our participants are honest. So that is the back end, and we built an entire auction in 65 lines of code there. And so this completes the back end. And we'll go through and we'll build a front end. We're going to move through this front end portion a bit faster. So we're building this with React classes. Hooks are the new thing, but classes, the components still work. So like I said, I'm going to move through the front end a little faster so I can demo it for you and have time for a couple questions. This is going to import all the data that we need, all the React stuff, all the views, and it imports our standard library. And then sets a constant for our standard library. Then we're going to import a wallet. So this MyAlgo Connect is going to allow us to use the MyAlgo wallet. And again, we see that provider environment testnet. So again, if I want to make this auction and put it on mainnet, how could I do that? It's as simple as changing testnet to mainnet. Okay, and then we're going to set up some standard units. Chance for it to go to sleep, setting up some default amounts for bidding and the default values that will show in our view. And then we'll do some React stuff. We'll set up our properties and we're going to mount our components. Okay. Okay, and then we'll just start our contract. So let's start that contract. Reach is agnostic, so we're front-end agnostic. I'm doing this with React, but you could do this with Angular. I'm using React classes, but you could use React hooks if you wanted. You could do this with vanilla JavaScript. Reach is completely front-end agnostic. We don't really care. You could do it with Python with the RPC server. Okay, so here we're grabbing that new account from Mnemonic. This allows us to quickly grab an account that we've pre-populated with some algos so that we can play with it. And then we set our state to get the auction ready on the front end. Okay, and then last steps here, we'll elect our bidder. Set up the state for the bidder and return the view with the app views. All right, then we'll set up our properties for our creator. All right, so this just sets up the React component for the creator, sets up the creator's properties. We'll set things like their minimum address, the minimum bid amount. We'll set the state to view deploying, so okay, now we're going to deploy. And we get the contract information. So there on line 52, we're getting contract information, and we're going to make that publicly viewable. Now we'll get the sale. So this looks familiar. So setting up the NFT ID, the minimum bid amount, the length in blocks we're going to set to 30. That's about 2 minutes here. And then we'll start to see these functions that we made for the creator in the background, or in the back end. So auction ready, so say, hey, this auction is ready. Set the state to true, and let our participants know that, our API members know that they can bid. All right, we'll set up a cbid so we can see the user's address and how much they bid for. And then that show outcome function. So this is the front end representation of those functions that we set up in the back end. There's the show outcome so that everyone can see the outcome of the auction. People want to know who won. Okay, and then render the view and set it to the deployer view. All right, we got about 10 minutes left here, and I want to give time for questions, so I'm going to drop in the rest. It's about 30 lines here, and we'll just walk through it. So now we set up the bidder. We set up the bidder's properties. We set their view to attach. The creator's view was deploy. The bidder's view is attach. This attach function sets up logic for getting the accounts and setting up the currencies. And then we have a bid function here where this ties in with the bid. We call the API bidder and give them the ability to bid and their bid amount. So this ties in with the back end. And then we set the initial state for waiting for turn. So just waiting for their turn to start bidding. And we show their address as a formatted address and their bid amount as formatted currency, so it's human readable. We have our set bid method here, or to show the view. So this is going to show the view of the bid. Again, making that accessible for anyone, and then we close the app. Okay, so let's see, where's the terminal at here? Okay, and we're going to use Reach React. So this allows me to quickly set up a front-end wrapper using React. And this is going to be on localhost. So it'll set up a localhost environment where I can test this out on my testnet. So we're going to start the development server here in just a second. We should be able to go to localhost 3000. So localhost 3000 is up and ready. There we go. It's up there. So let's go to my browser here. Okay, let's start this auction. So first one's going to create and sell. We're going to set this to 1 algo. I will set the minimum bid and create and deploy. So we're going to deploy that. And while that's deploying, I'll open another window. Also get started. This is going to be the bidder though. Okay, so it should be ready in just a couple seconds. There we go. So auction's not quite ready yet. Current bid is at 0. I'm going to copy that contract info. And now on my bidder's view, so this could be a whole nother computer somewhere else, right? It's the client. And I'm going to show that auction information. All right, I'm going to need to sign here. Okay, there's our NFT. I have the ability to bid now, so I'll start the bid. Minimum bid, 1 algos, we'll bid 2. All right, well, let's send it. Sign my wallet. Okay, waiting for the results. Wait for the results there. There we go. Current bid just updated to 2. So I can go back here actually and I can refresh to pretend like I'm a new bidder. I'm another bidder in the parallel reduce. This could be someone completely different. And I'm going to make another bid. Sign our wallet here, see the NFT. We see the current bid is now at 2. Let's push it to 4. Bid and send it. And then we'll sign. All right, waiting for the results. Let's see. This should update to 4 in a second. There we go. Updates to 4. Now, what would happen if I try to bid 3? See if I can show that easily. So we'll try to sign again here. Okay, and let me bid 3 this time. And send it. So we won't see anything in the front end. This would be a feature that we'd want to implement. But if we go look at our console, I don't know how well this will show over there, but over here it'll say, hey, your bid was too low. So there we see that error information, bid is too low. So yeah, we would want to bid more. All right, and we should be getting close to the edge. Here we go. So the auction ended. We see our winning address and the winning amount, 4 algos. Oh, NFT auction from start to finish in less than 30 minutes. There you go.
JP, nice work, JP. That was awesome. We definitely have some time for questions, and I know we have some questions, so we're going to get the mic out there. Who's got a question? Get your hand in the air. We'll get those answered right here. Okay, here comes the mic. Right. That was awesome, JP.
Yeah, it was fun.
And it was fun to see it built in 2 different languages, right? To see it in PyTeal and then see it repeated in Reach. Here's your question.
I wanted to ask about the first stage when you upload the NFT from the URL stream. There seems to be an issue in the code, I believe, that we are reading a chunk of bytes, and there seems to be a mix-up that if the NFT size would be bigger than the the default chunk size for the text decoder, then we wouldn't actually read the full NFT bytes, I believe.
So in the first program where we minted the NFT?
Yeah. So I believe there is something that needs to be fixed. So my question is, how, because I like the part when where Rust is blockchain agnostic, as I noticed there was some code that is actually connected to Ether logic. So how do I test that? Because on the previous presentation we had some test examples that we actually have seen what's in the blockchain, and if I deploy that code on Ether, for example, how do I test that?
Gotcha. Yeah, so different blockchains have different byte sizes and different parameters for their NFTs. Use a condition, right? So we're able to check what connector. So you would set up a connector, a condition based on connector. If I'm connected to Algo, use these parameters that meet the ARC69. Or if I'm connected to ETH, then use these parameters that are compliant with an Ethereum NFT. And so, yeah, we just do that with a condition statement.
But does Reach have some kind of test framework to connect to certain network and?
Yeah, so connecting is like to a different network. So find my terminal. You just set it with the connector mode. So, export, and then I do a reach connector mode. And I'll set it to Algo if I want to be connected to Algorand. And I would do ETH if I wanted to set it to something else. And then we also are connected to Conflux, which is the only blockchain that operates in China. So I can set connector modes just as easily as that. Mm-hmm.
Do we have any other questions out there? Don't think I see any others. So with that, I want to thank you, JP Miller, showing us how this is done. Awesome. So glad to have you up here. All right, next up, we are going to have a brand new language. So we've seen Reach, we've seen PyTeal. We're going to see something new today. I haven't even seen this. I'm really excited about Tealish. And we've got the CTO from TinyMan, Fergal Walsh, going to join us here today to introduce what is Tealish, a new higher level language for Teal. So take it away. Welcome.
Hello, everybody. Hi. So, as Ryan said, I'm Fergal Walsh. I'm CTO of TinyMan. So, as you may know, just last week we announced TinyMan AMM version 2. So, or for those of you who don't know anything about TinyMan, TinyMan is the original decentralized exchange in Algorand. We've been around for about a year on mainnet. So V2 was announced last week, and it's going to be, the contracts are public. The audit reports and the protocol details are now public. It's going to be deployed to mainnet in January 23. These new contracts, we're pretty excited about them. They contain nice new features like flexible liquidity, flash loans, flash swaps, but most importantly, they're composable and interoperable with other protocols on the Algorand network. So we take advantage of all of the new great features available in the AVM that have been developed over the last year and rebuild the contracts from ground up. But I'm not here to talk about TinyMan AMM today, or really anything to do with TinyMan at all. I'm talking about something called Tealish. So in order to build TinyMan V2, we first built this thing called Tealish. So Tealish, the tagline is a readable language for Algorand. So it's a new smart contract language for Algorand, but maybe not a language, maybe a dialect of Teal for Algorand. So in this talk, I'm going to talk about why we built it, about how we built it, and why that might be of interest to you. This is not an introduction to Tealish, so I'm not going to walk through how to build a contract in Tealish, but more the design, the design of the language itself. So why did we build a new language for Algorand? Well, Algorand has a bit of a problem. I'm sorry to say that so bluntly, but at the moment, it does. The developer experience is just not, it's not good enough. It's okay, but it's not good enough. It's holding us back as an ecosystem because the tools are still quite a struggle to work with. Now, we're still quite early. We're only a few years into this project. We're thinking very, very long term with Algorand. But we need to accept that it is a problem at the moment and then see what we can do about it. So I didn't always think this way. I thought that Algorand had fantastic tools. I loved the language of Teal. We at Tinyman loved it. We loved Teal in the same way that we loved Algorand itself. We loved the elegance of it, the simplicity of it. It's brutal, but it's kind of beautiful in the same way. It's very low level, but there's no abstractions that get in the way of writing programs. It's very easy to understand what's going on. You're programming directly for the AVM, and that's very, very powerful. And obviously, it's very fast. The AVM is extremely optimized, and it felt pretty safe for working in. And so we wrote our Tinyman v1 in Teal, Teal version 4, actually mostly Teal version 3, just a few things from 4 towards the end. But when we reflected about the experience of writing Tinyman v1, we realized it was a pretty inefficient process. It was inefficient, it was stressful, it was exhausting. We put in huge amount of efforts and endured a lot of stress to write something that is actually very, very simple. Like the maths and logic of an AMM, a basic AMM, of what Tinyman was, is very, very simple. But it took an extreme amount of effort to get there. And by any reasonable standards, our code is not readable. Like, we put a lot of effort into writing our Teal in a readable way. We put a lot of effort into commenting it. But is this really the way to build the future of finance? Is this how we should be writing contracts for the future of finance in 2022? Like, when we tried to think about Tinyman version 2, we just couldn't fathom how we would build the things where we knew we could build them with the AVM features. We knew what we wanted to build, but we couldn't think how we were going to manage to build a program of that size with the current tools. So what actually is the problem? Like, why do I say that's unreadable? Why was it so stressful and exhausting to write that kind of code? So Tealish is kind of, as I said, it's fun, it's awesome to write small little programs. It's great while you're in the zone. But Teal relies too much on our poor brains. Too much burden is placed on the writer of the code. And our brains are pretty limited. They don't have a very big stack. Our slot spaces are very, very low. So mental stack overflows became a real thing. As you try to write Teal code and as you read Teal code, and I'll get into this more and more, but reading is so important for smart contracts. People need to be able to read the code. And so you spend a lot of time trying to load up the whole code into the stack on your head, understanding what's going on. The slightest interruption, and you lose an hour of work. You have to start again, and it's insane. So this is not actually an efficient way to write big programs. It's great for small stuff. It's fun. It's really great for solving challenges in Teal, but it's not an efficient way to write serious programs. So, I mean, Tealish, okay, I keep doing that. Teal is kind of what we see on the left here. It kind of goes top to bottom, but our minds don't work like that. We are conditioned to read programs from left to right. We like to have kind of expressions inside each other. We like to have stuff in one line. We're pretty good at reading programs like that. Teal doesn't have common abstractions. So yes, you can do conditional stuff. You can do if this, else that, blah. But it involves a lot of manual work. It involves a lot of lines of code to do quite simple branching and things. There's a lot of burden placed on the developer. So does it have to be this hard? Well, okay, So at this point, probably about half of you are politely in your head, but you're still screaming at me saying, what about PyTeal? Why aren't you using PyTeal? Surely it solves the problems. And, okay, PyTeal, it is great. It is a great effort at improving the way of making Teal programs more readable. But it's just weird. As an experienced Python programmer, it is extremely confusing. If you're experienced in Teal and Python, it's doubly confusing because you're trying to keep in mind the differences between Python and Teal, or Python and PyTeal. You're trying to figure out which, like, I know how to do an if statement in Python, but that's not how I do it in Teal. But I will do a normal Python if statement inside of my PyTeal code, but that bit is for generating actually an AST, not the runtime code. It's really confusing. I've used PyTeal quite a bit. I try to explain it to my colleagues, and I just get so confused, and I find it a struggle to explain. And then as I try to debug contracts that I've written in PyTeal, I keep finding I have to go back to the Teal. And then there isn't a one-to-one mapping, and it's just quite difficult. Now, I know Beaker is doing a lot to improve this and adding a lot of structure to that, and that's a really great improvement. But in the end, it's still PyTeal in there. And the guts of the programs are still PyTeal, and they're the bits where the important stuff happens. So we wanted something better. And I mean, we don't want to fragment the ecosystem into multiple languages. But at the same time, I really believe it's too early to settle for mediocre tools. So, as I said, we're only a few years into this in this Algorand ecosystem. If we're going to be in this for long term, we need good tools, and we shouldn't try to just settle too early on the first thing that we try. So I really believe we need to try multiple things and see what works, see what doesn't. I don't believe Tealish is going to be the future of Algorand. There may be many things that will come later and can replace it or do things much better than anything that we can think of, but we want to offer an alternative to the tools that are there at the moment, an alternative way of thinking about the problem. So what do we want? We want an AVM native language. It is a unique virtual machine. We want a language that works for that. But we want a language that is designed for the AVM and humans. Humans are a hugely important part of the process of reading and writing contracts, much more so than normal software development. We want a language where intent is obvious and semantic mistakes can easily be found. We want a language where we can iterate on ideas, where we're not afraid to write some code, try it out, throw it away, rewrite it, and keep ideating and iterating until it's as good as we can get it. We want a language that's easy to debug. We want a language that generates auditable code. Now, this is really weird. Like most programming languages, they develop bytecode, and you don't care what the bytecode does as long as it works. We want to generate auditable Teal. Teal is the output of Tealish, and we want that Teal to be readable and auditable by professional auditors or by independent, knowledgeable people who know about Teal, so that they don't need to trust the Tealish compiler. The Tealish compiler will be continuously developed, but they should, if they have good knowledge of Teal, they should be able to understand the Teal and ensure that it does what it's meant to do or what they think it does. We want a language that our technical users can understand by reading our contracts. Basically, we want a readable language for Algorand. Now, when I say readable, like readability is in the eye of the beholder. So who are we talking about for readability? It's the developers, it's the auditors, it's the reviewers, so your teammates reviewing your code, and it's the technical users of this ecosystem. If we're writing a protocol, those users should be able to read our contracts and understand exactly what we're doing. So what is readable? To me, readability means this. It's a familiar syntax, so when you look at the code, it should not be insane. It should look like other programming languages to some extent. There should be a good balance between verbosity and terseness. It should be explicit, so there shouldn't be magical things happening. It should be predictable. You should have a good idea of what's going to happen when this code gets executed or this code gets compiled. It should be strict. So I love Python. When I'm not doing Teal or Tealish, I'm doing Python. Python is not strict, and I love that fact about it. But I don't use Python for writing smart contracts. I want my smart contract language to be extremely strict. I don't want it to be generous or forgiving while it's compiling. I want it to be strict about types. I want to be strict about exactly how I use it. I want a consistent style. So there should be one way to write this language. You shouldn't be able to have a choice. You shouldn't be able to decide where you put your brackets, how you format your code. That's not important, and it doesn't add to readability. There should be an abstraction of common patterns. It makes it easier to recode. If statements look like if statements, you know how they work. You can look at the details. You don't need to look at the structure of it. There should be compartmentalized code. So you should have some way of scoping your code so that you can look at bits of code, chunks of code, bit by bit, and understand them in isolation. So with this aim in mind, we started building Teal. So we thought of our favorite language as this, and we decided to mix them together. So we basically took Haskell, Perl, and no, okay, that's definitely not what we did. We started with Teal, and we said, what do we need to add to Teal what do we need to mix with Teal to make it into a readable language? So we're working up from Teal. And why are we working up from Teal? Because, as I said, we want something that is for the AVM. So the Teal is designed for the AVM. Teal has, all the opcodes are very, very specific to how the AVM works. And we want learning our language to equate to understanding the AVM. So we don't want to re-implement stuff that's in the AVM. We don't want to implement it in different ways. We just want, if you learn Tealish, if you understand Tealish, you understand the AVM, and vice versa. So first and foremost, we want to make the stack implicit. So instead of putting stuff vertically in your program, let's just put it horizontally. Infix notation is easier to read for most people than prefix. And then we want some kind of expressions. So we put those expressions inside functions. So if we're using the assert opcode, an opcode is like a function. It takes some arguments. So those arguments, we put them, we can use expressions as arguments. So we write this like this. By the way, the first line is not valid Tealish. It's an expression, but it's not a statement. So that you can't use 2 + 1 is nothing. Where does the result go? What are you doing with it? So the second line is the first piece of valid Tealish. Then we can have more complicated expressions, and then we can use other opcodes in our expression. So if an opcode has a return value, then we use that as an expression. And we just use the opcode directly. So app global get, if you look that up in the opcodes document on the Algorand developer portal, that's exactly what it says. app_global_get. That's the name of the opcode. And then this is the first time we see something that we say, well, maybe we can make this a little bit nicer. Maybe, okay, you got a magic number there. Let's extract that out. That's a constant. Let's give it a name. So we just tell the compiler that this thing has a name. We give it a type so that we can do type checking later. And then here we see another opportunity for making it easier to read. So we could just kind of stay pure and say, well, there's this global opcode, and it has this, the first argument is the name of a field, so we just pass it as an argument to the function. But it would be maybe more readable, more understandable to use a namespace and field kind of syntax. So we have global.round and txn.applicationargs. And applicationargs is an array, so it makes you can index into that array, and it just uses standard other language in the world. Okay, so now we move on to slots. So in our Teal programs, we want to temporarily store stuff into slots. Unless you're JJ, you need to use slots. JJ can do everything on the stack, but normal people need to use slots to temporarily store pieces of information. So normally you just put these into, you number your slots, and in the TinyMan version 1, we kind of came up with a scheme for trying to remember the slot numbers for each thing. So if it was a number ending in 1, it referred to something to do with asset 1, and if it ended in 2, it was asset 2. And then there was other magic numbers like 42 and 57 and things, but we tried to keep some kind of sensible structure to it because we had no other way of keeping track. We were trying to keep track ourselves. But why not just use names? So we use slots like variables. So we have a pool address. So we define bytes, pool address equals transaction accounts 1. We use typing, as I said earlier. It's more friction for the developer, but there's lots of advantages to having types. Okay, so at this point I'm going to flip things around and show, okay, we have our Tealish. So what does our Tealish do when we compile it? Well, our Tealish kind of turns back into what was on the other side of the slides. It turns back into Teal. But it's not just, and it is Teal, it's not the bytecode, it's actual Teal text. And why is it Teal text? Because it has all of these comments and annotations. So each line of the generated Teal includes the original line of Tealish as a comment to explain the intent of what's happening. Every time they use a slot, it includes the Tealish line, and then includes the variable name as a comment on the Teal lines. And it also includes the original developer comments. So then as you read through the generated Teal, you have the full context of what the developer was thinking as they were writing the code. And all of this is generated by the compiler, so you know that every single time that a slot is accessed, there is going to be a comment to tell you what that slot was for. So once you have slots, then, well, we have 256 slots, which seems like a lot, but then when you try to do a lot of stuff in a contract, you're going to run out of slots. So we need some way of scoping so that we can tell the compiler that, okay, we're using these slots at the moment, but after this point, we no longer care about those slots. They're out of scope. We're not going to read from them again, so you can reuse them. So we introduced this concept of the block, a block of code, and they're named, and you basically jump between blocks of code. This is very similar to how people write Teal code. They have labels, and then they do things within those blocks of Teal code, analogous to that. And so we define our variables inside our blocks. Tealish automatically assigns the slot numbers, and then once it goes out of scope, those slots can be reused. And then a common pattern is jumping between different sections of code. Usually this happens at the start. Sometimes it happens, you do some kind of conditional stuff at the start, you jump into a main method, and then you do some other conditions, and you jump to further sub kind of stuff. So this switch statement is basically just taking this very common pattern and turning it into something a bit more readable, less boilerplate code. It looks like we could make this even more magical, and you just pass in the method names and it would automatically jump to the functions, but we're trying to avoid any kind of magic to make it more obvious what the language is doing. Okay, the next most common type of thing that you're going to do in a Teal program is some kind of conditional stuff. So if this, then we're going to do that, otherwise we're going to do something else. But all with it just like in close proximity to each other. So this very common pattern, we just turn it into a if statement. And this is really boring. Like, this looks kind of like an if statement, and there's elifs and elses, and it's exactly like in other languages. And it's meant to be boring. Like, there's nothing interesting about this. It shouldn't be exciting. It should just be really boring and really predictable about what it does. And now that we've put it into this form, then actually maybe it's easier to notice some possible logic errors that are in your code, which are less easy to spot when it's written in the Tealish style, in the original Teal style. Okay, inner transactions. So these are one of the unique features of the AVM. Every modern application on Algorand uses inner transactions. They're a core building block of protocols. So we wanted to give them first-class treatment in Tealish. So in Teal, they look like this. You begin a transaction, and then you have some fields, and then you put some stuff onto the stack, and you store them into those fields. So in Tealish, we just basically remove the excess stuff and just turn it down into its most simplest form without losing any information. So you have your inner transaction, you have your fields, and you put your values in those fields. And then you have groups. We have, like, inner transactions can be in groups, so we have just a group concept here. And by the way, like, in my examples, I'm showing them nicely formatted and stuff. You can write your Tealish like this, and it's not going to be so readable. But the compiler will just put it back into the right way to write Tealish. So then your colleagues will be able to read your code. Or if your colleague doesn't write the code properly, you just automatically fix it. So that's the Tealish. I fixed it for you. So then we have functions. So in the AVM, there's a support for subroutines with call sub and ret sub. And so these are functions, basically. So in Tealish, we have a kind of fairly standard syntax for functions. Again, we have types. So types are tracked everywhere throughout the program. At the moment, and then our calling style for functions is exactly like opcode. So we're just passing in arguments, and those arguments can be literals or expressions. At the moment, our functions look exactly like this. So the arguments that you pass in, they get stored into slots, and then we do stuff with them. In AVM8, this is all changing with frame pointers. I have finally understood frame pointers in the last 2 days, and they're going to be awesome. They remove a lot of the challenges that we have with functions at the moment. And so instead of storing stuff into slots, we'll be using frame pointers to reference variables, and that's going to allow for much more scalable programs. Right now, we try to keep functions as small as possible, limited in what they do, limiting the amount of space, amount of local variables that they have. But with frame pointers, that's not going to be an issue anymore. Some stuff, we just kind of left it as it is. So this is some maths. This is extract from Tinyman v2. And it looks kind of ugly. That's not beautiful. But if you take the time to read it, it's unambiguous. There is no two ways of understanding what it does. If you read it, you understand exactly what the compiler and what the AVM is going to do with those, with that information and the mathematical operations it's going to do. Like, you have this ugly operator B star, and then you have B slash for divide, and then you have normal pluses. You might have some B pluses in here, but they're important. They're really important. When you use a B star versus a star, that needs to be explicit in your program because they mean totally different things, and they have totally different costs. So it's important to be explicit about when you're using them and make sure you're using them in the right places, but not overusing them. So we just left this as it is. If we attempted to make it more beautiful, we might have just make it less readable, actually. So these are all the features that we needed to write AMM v2. So infix maths and logic operators, expressions, where we have expressions inside expressions inside expressions, calling opcodes, some constants, accessing fields like globals and transaction and g-transaction and all those things, variables, scopes, conditionals, inner transactions, and functions. Well, not quite. There was some other stuff we needed. We needed this. So I make typos and spelling mistakes all the time. We needed our compiler to understand when we make mistakes in our code. So that has not been defined, or you spell the variable wrong, or all these kind of things, you get a compiler error, as you would expect. We're trying to assign the results of this multiplication into an integer variable, but actually, that's not an integer, that's still a byte. So it's telling you that you're doing the wrong thing. And here, it's telling us that we have one name, but there's two values. So asset params get returns two things. So you need to consume them. You need to do something with both of the return values from that opcode. And then we needed lots of these. So we had tests where our tests ensure that a specific line of Tealish with an assertion is being raised in certain scenarios. So our tests are written using another tool called AlgoJig, which we also developed in tandem with this. That's a whole topic for another day, but basically it allows us to test against a very specific known state of the ledger, and then to assert that certain things have happened properly or that the correct assertions have been raised. Now, all of these things are possible, like those proper error messages, these asserting that a specific line of Tealish has caused the error. These are possible because this is a parsed language with a language model and a source map. So we know exactly when we get a PC counter error from the algod, we know we can map that back to the Teal and back to the Tealish, so we know which line and which characters on that line caused the error. So developer experience tooling was super important. So with these features, we gained new contract writing abilities, basically. We were able to ideate and iterate on the code. We were able to keep changing as we went along and to build really exactly what we wanted to do. We did, like, once we had built something, we didn't get stuck on it because it was easy to change. It was easy to keep on iterating and refactoring until we had it exactly as we wanted. And it was easy to quickly notice mistakes. Sorry. Seems like this thing's powered by the blockchain or something. So in TinyMan v2, we had over 1,000 lines of Tealish, 15 or so distinct methods, a lot of maths, and it's a fully composable, flexible protocol, and we have a lot of safety checks in there. And this results in over 3,500 lines of Teal. That's commented, annotated Teal. And so this generated Teal, it's pretty readable because it has all of those comments in it. It has our intent. It has comments for all the variables that we're using. And so I should mention that these contracts have been audited at multiple levels. So they've been audited at our business logic. They've been audited at the Tealish level. So the auditors have basically generated models and done analysis based on the business logic that we've described in Tealish. And then it has been audited at the Teal level. So they've read through all 3,700 lines of this Teal to ensure that it maps to our business logic. So they're not relying on, and we are not relying on the accuracy of our compiler. It's still audited in the exact same way that any Algorand smart contract should be, which is the actual code that gets executed by the AVM. And the auditors had great comments about, so they didn't balk at the idea of auditing contracts written in a new language. They were quite happy to audit the Tealish, and they had very positive comments about the readability and usability of it. So that told us that it worked. We achieved the aim of creating a readable contract. So this is what we needed for our AMM v2. So what's next? Where does it end? Well, probably we would want to do stuff like loops and structs and arrays and classes and interfaces and inheritance and polymorphism and all the other stuff. Or would we? Is that really what we want? Do we want feature parity with Python or Go or other general purpose programming languages? Well, to answer those, we should go back to our design assumptions of what we were thinking of when we designed this language. And our assumptions are that program size for contracts will always be small. So the size of programs is not going to scale with Moore's law. There's a totally different rules of scaling that apply on the blockchain where you have thousands of transactions that need to be executed in seconds. The runtime memory constraints are always going to be small. So cost optimization is always going to be important. And we assume that the AVM capabilities will always be limited and very domain-specific. Algorand does not try to be the world computer. It has a very specific domain, and the AVM has very, very specific opcodes. It has a specific use case. So in our view, most of those possible features and features of other languages just are not appropriate for contracts on Algorand. We don't need them, probably. There are some stuff that we do need for sure, like loops and structs and arrays and more. But we want to keep it simple. We want to keep it so Tealish is easily digestible. We want to add this little extra burden to the developer. So we want knowledge of Tealish to equate to knowledge of the AVM, and vice versa. So we don't want loads of extra stuff at the Tealish level that is unique to Tealish. We don't ever want to see this article about the 10 things you didn't know about Tealish. There should be nothing you don't know about Tealish after you've read the documentation, which is not very long. We want it to be very easy for people to keep in their head. But we do need stuff like loops and things that are fairly standard. We didn't need them in TinyMan AMM2, but we always had them in mind as a feature. So we have while loops and we have for loops, and they're boring. They just kind of do what you would expect them to do. And the teal they generate is really boring. We have structs. These are interesting. These are nice. So one common pattern that we've seen is people putting loads of stuff into byte strings and then putting those into global states or local states, or now with boxes. And there's a very good use case for this. But it's really painful to manually manage the offsets and the sizes of your types and all these kind of things. So we thought, why not just define in the language a way of defining your data structure? So we can say that we have some ints and we have some bytes, and they have an order in these byte strings. But all of this happens at the compiler level. So this is managed by the compiler, not by the AVM, not by runtime code. So the code that is generated is exactly the same as what a human would generate with the same problem, just the human didn't need to think about it at that level. So these are already in Tealish. Arrays are coming soon. They will follow the exact same way that structs work for static types, not for dynamic types. So we don't expect to add like dynamic length strings anytime soon, or dynamic length arrays, because that involves runtime computation in the AVM. It gets a lot more complicated and it's a lot harder to reason about, and I really want to be sure that it's necessary to have that before we implement it. So how is Tealish going to keep up to date with the AVM? What about, like, let's imagine a few weeks ago you wanted to play with boxes. You heard boxes were coming. You saw the PRs on Go Algorand, and you're really excited to try them out. So you write some code. You know how to use it. Like Tealish, you don't know how to use boxes in Tealish because you don't need to know how to use boxes in Tealish. You know the opcodes, so you know how to write it in Tealish. So you write some code, and then you go to compile it, and then, unknown function or opcode box create. Okay. You check up the documentation, you make sure that it wasn't create box. No, it's really box create. Okay, I spelled it right. What's going on? So you search the repo, and okay, Tealish hasn't implemented boxes. What am I going to do? I can't use Tealish. Okay, I'll go back to Teal and I'll try to, no, you don't. I'll search like for app local get. That's an old opcode. I know it exists. I'm going to check how that's implemented in Tealish. And it's not. It's just there in a JSON file. That's not an implementation. We were lying to you. We didn't implement any of this stuff. So what's going on? That JSON file is, well, that's the specification of all of the opcodes that exist in Algorand. And that's how Tealish knows about opcodes. So Tealish has no implementation for the vast majority of opcodes because it doesn't need to, because this file tells Tealish how it works. So Tealish has a CLI, and in that CLI, there's some line spec tools. And those tools allow you to fetch a new version of the line spec. So you heard about boxes. You saw that it's been developed on a feature branch. And you say, I want to use that with Tealish. So you go Tealish line spec fetch feature AVM box. So feature AVM box is the name of the branch on Go Algorand. So you're fetching the line spec file from there, and you get the new opcodes. And then you can try to compile your code again, and it tells you that you actually use that box create opcode wrong. It was expecting 2 arguments. You fix that, and then you have compiled your code. And now you can actually experiment with those features in Tealish directly, even though Tealish didn't know anything about those opcodes. So this is how Tealish is going to support the AVM going forward. There does not need to be any special work done on Tealish to support AVM 9, 10, 11, 12 for the new opcodes. But sometimes we might want to add syntactic sugar. So like, for example, this boxes example, we thought of, well, okay, boxes they're nice and simple, but they get complicated. There's box extract, box replace. You need to use these sometimes. And that's kind of like extract and replace that we have for working with byte strings. So maybe we can support them in the same way. So we introduce a box type in Tealish, and then we have this kind of generics type of syntax where you say, I'm creating a box, and it has a type which is defined by a struct. So this is a box that contains this kind of structured data. And now when I read and write to that box, I use the fields of the box, and internally that uses box replace and box extract as it needs to do. And so that can work for as large boxes as are possible on the AVM. So that's some syntactic sugar that is added on top of the opcodes. That's an example there, don't need to go into that. Okay, so on our roadmap, we're continuing to develop it. There's still some further work needed, some other things we would like to add, like the arrays example that I mentioned. We also want to add some support for external functions. So I mentioned that functions are getting a revamp, and finally, we have a nice way to support functions of reasonable size without awkward restrictions. So then we're going to be able to support declaration of functions to mark them as external, and then have ABI router type of support in Tealish. Developer tools will continue to improve. The compiler can get better and better. It can give you better and better error messages. We're working on a debugger or replayer for in conjunction with our testing toolkit, so that we can make it easier to debug contracts. And we also have test coverage tools, so that basically for all of our tests, we can ensure that when we run a test, we keep all the traces, and then we ensure that every single line of Tealish has been executed by our tests, which is really nice to have. And then, because we have a language model, we can implement static analyzers, which can automatically check for common types of issues in contracts. And then continuous documentation improvements. And then, so on most language roadmaps, one of the items on the roadmap is the Tealish compiler in Tealish, or X compiler in X. We never want to see this. If this is possible, it means the project has failed. And there's one guy right there who I know is going to try to do it. But hopefully it should be impossible. That is not an aim of the project. This is a very domain-specific language. So one of the things we like about Python is the Zen of Python. In the Zen of Python, the developers have basically written down some things which capture their vision and design philosophy for the language. When we talk with developers in our company, and especially for newcomers to the language, we often refer to the Zen of Python. We often say, like, the Zen of Python says explicit is better than implicit. So in your code, you should be explicit. We refer back to other things. So we came up with a Zen of Tealish. We borrowed directly explicit is better than implicit, because especially for contracts, it really is. But there's also a bunch of other things that we think are really important. I won't go through them all, but code is both for humans and machines. Readability is more important than writability. They are the main 2 points of our design philosophy. And that's what led us to building Tealish the way it is. So if you'd like to learn more about the project, we have a read the docs, so tealish.readthedocs.io. We have a GitHub, and you can obviously learn more about us at tinyman.org. Thank you.
Fergal, awesome talk. Honest criticism to bring us in about, how do we reason about Teal? Tealish is definitely something that we are all very interested in. If I ask this question, are there questions out there? This whole room is going to have every single hand up. You will be here until all night long. So I am not going to do that, but I am going to invite all of you to come and talk to Fergal about this just the same after this. At this time, I'm going to say thank you, and we are going to wrap up the developer greenhouse. The Tech Talk stage is now coming to an end. We have done so much over the past couple of days, and I want to welcome to the stage now my colleagues on the DevRel team that have joined us here for our second annual Decipher conference. So, in closing, if I can get my guys to run up here, we are so glad to have these guys. Many of them you saw giving presentations today. A couple of them, yeah, you didn't, but their impacts have been great. Chris Kim, Pranjal, Steve, Ben, and and Joe. So thank you to these guys. And then behind the scenes, who you don't see, but they are right out there, is our other colleagues, Russ, Everett, and all of our boss, Jason. So we thank you to you guys for keeping us online on the Discord servers. And the reason why I struggle with Ben and Steve all the time is because that's Barnji and Nullen right there. So that's the other reason we want to get these guys on stage, because you know them by different names. Again, thanks to you guys. Thanks to all of you for joining us here. This is the end of the greenhouse for this series, or for this location. We will be doing the greenhouse in the coming year at other locations. But for now, we're going to close this down, and the closing remarks are going to happen now on the main stage in the arena. So let's all head over there and see the closing remarks. Thanks to everybody. Good night.